A cheerful welcome to this one-day joint workshop by NDMA and NRSC on harnessing space-based Earth observation and GIS technologies for disaster risk management. It's amazing to see such a brilliant mix of scientists, experts, and tech leaders all gather to tackle one of our biggest challenges, using smart technology to make India safe and more resilient to disaster. A special welcome to our guests from NDMA, NRSC, academia, and GIS and space tech industry. Today we are not just talking about satellite and software, we are working together to shape the future of disaster management. Now before we launch into our session, no rocket required, just quiet note, it's spirit of sustainability, we gone paperless. So instead of printing the schedule, just scan the QR code back on your ID badge to view the agenda and speaker details. Thank you for supporting our Save Life, Save Tree paper initiative. And yes, even satellite love Green Planet too. Now I welcome our dignitaries on the dais. Our chief guest, Dr. Prakash Chauhan sir, Director NRSC. Sri Rajendra Singh sir, Member and HOD NDMA. Sri Safi Hassan Rizvi, Advisor Mitigation NDMA.
Brilliant decision.
Okay. Without further delay, let's begin our inaugural session with a special address by visionary leader in disaster management, renowned for his strategic insight and dedication to India's resilience. Please join me in warmly welcome Sri Rajendra Singh, sir, member and HOD at NDMA. We are honored to welcome you, sir.
तूने झूठ बोला ना वो झूठ का फल मिल गया तुझे झूठ मत बोला कर विजनरी लीडर इंडिया चोर तो नहीं respected dignitaries on the dais, Dr. Prakash Chauhan, Director NRSC, my friend Hasan Safi Rizvi Sahab, ED NIDM, Arvind J, Additional Principal Secretary, Principal Chief Secretary, Telangana, and scientists, domain experts, startup innovators, distinguished guests from academia and civil societies, officers from central ministries, NDMA and SDMA, and dear participants. A very good morning to you all. It is a privilege to join you today at the 13th Coder Workshop on harnessing space-based Earth observations and GIS technologies for disaster risk management, organized by NDMA in collaboration with our esteemed partner NRSC. This gathering is much more than a technical dialogue. It is a strategic moment in our journey to modernize disaster risk governance in India. This workshop symbolizes our collective resolve to shift from reactive disaster response to anticipatory, data-driven, and technological empowered risk reduction. It represents a confluence of science, policy, innovations, and field-level actions. India's unique geoclimatic locations render nearly every region vulnerable, be it a cyclone on the coastal states, earthquake in the Himalayan regions, landslide northeast and Himalayan region, and flood in the Indo-Gangetic Plain and drought in the Deccan Plateau. Climate change is intensifying these challenges, making events more frequent, erratic, and devastating. The need of the hour is a paradigm shift from post-disaster relief to pre-disaster risk reduction, and this transition depends heavily on technology. India's space program, led by ISRO, and its specialized centers like NRSC, SSC, and NESSC, is among the most advanced and cost-effective in the world. We have real-time access to high-resolution satellite data through platforms like COSAT, RISAT, INSAT, BUON, and MODIS. And this data enables us to map floods in near real time, monitor land use and landslide, detect drought stress, assess cyclone impact, forecast heat island and forest fires. Yet, raw data alone cannot save lives. It must be translated into a usable intelligence, and that is decisions that are timely, targeted, and accessible even to the last mile responder. That's where the GIS become indispensable. GIS platforms such as QGIS, GeoServer, Google Earth Engine help visualize risk in actionable format, integrating hazard data with population, infrastructure, and vulnerability indications. This empowers administrators to prioritize evacuations, relief, and mitigation efforts with unprecedented clarity. We are now entering into an era of artificial intelligence. AI, drones, and real-time data systems are transforming how to manage disasters. This is not a future possibility. It is already a reality in a pilot project across India. This workshop is about scaling these capabilities nationwide. Over the course of the day, we are going to discuss many topics, and some of the important topics are use of open source GIS tools in hazard mapping and exposure assessment, integration of drone and AI into an early warning system, real-time data platform and community-based alert system, challenges in data access, interoperability, and ethical use. Role of startups in creating localized, scalable tech solutions is a very, very important. We expect each technical discussion to yield actionable recommendations with NDMA will carry forward into a policy and implementations framework. NDMA is already actively collaborating with NRSC to operationalize real-time flood mapping and impact assessment for states. And on 16th, we are also releasing Assam Flood Mapping Atlas. We are supporting training program in GIS and drone analytics of NDRF and SDRF. Partnering with academic institutions to develop AI-based landslide predictions models. That is also we are in the way. Promoting startup-led innovations in community-based early warning tools. Going forward to our priorities include building a national special data infrastructure, NSDI, for disaster risk reduction, ensuring interoperability and open data access, mainstreaming GIS use in DDMA and SDMA, developing AI-powered decision power system for field responder. Let me emphasize, no matter how advanced our satellites or our satellites, their success lies in how they serve the most vulnerable population in India. Develop mobile-friendly, participating GIS tool, train local volunteers and panchayat leaders, hazard mapping, ensure inclusion of tribal and remote communities in technological outreach. That is what we are going to discuss now, and we are going to take it further from here. This resilience of India depends on how well empowered our people at the grassroots. Finally, not taking much time, I have 3 points to share with you. Number one, technology is not a substitute but a force multiplier. Satellite, GIS, AI, and drones can transform disaster management, but only when integrated into a local planning and response system. My number 2 point will be policy and capacity building must go hand in hand. We need to break silos, build interoperable framework, and create dedicated capacities across all levels from national to village. And my last point will be empowering the last mile is not negotiable. True resilience is built bottom up. Let our investment in space and science find their true purpose in saving lives and securing livelihood. In conclusion, because every workshop I say some 2-3 lines, and here also I'll say 2 lines by famous poet Javed Akhtar Sahab, and who said, "जमीन पे बोझ बन जाए अगर इंसान तो बेहतर है, जमीन पे बोझ बन जाए अगर इंसान तो बेहतर है कि आसमानों के छतों पर नए रास्ते तलाश किए जाएं." Which means, when it's translated in English, means if humans become a burden upon the earth, it is better to seek new pathway across the sky canopy. And this, share when I speak to you people, remind us what is not the man become बोझ, कोई आदमी इंसान बोझ बन जाए. When old methods no longer serves us, we must dare to innovate, to elevate, and to chart new path, much like we are doing today by harnessing the sky to protect lives on ground. That is the message. Let us make this workshop not only a platform for knowledge exchange, but a catalyst for collective action. I thank all speakers, organizers, and participants, and invite you all to contribute actively. Together, let us build a disaster-resilient India where every tool of science, every byte of data, and every innovation reaches those who need it most. Thank you very much, and God bless you.
Thank you so much, sir, for your insightful remark. Now, we are grateful to have an expert in disaster management and policy with us today. Please join me in welcoming Safi Ehsan Rizvi, sir, Advisor Mitigation at NDMA, to present an overview of the workshop. I welcome you, sir.
As my colleague said, कि अब गिरना नहीं, because she was telling the truth. She didn't fall this time because she was telling the truth. So thank you for calling me an expert in disaster management. In what all? I couldn't even hear all that. Policy, okay, and then also in GIS also. Okay, so I am neither a scientist, and class 10 tak I studied science. I did get good marks, and my physics teacher pulled my ears that why you taking commerce and economics in class 11 and 12. It still hurts, but I think his, I would say, blessings or abhishap came to life when I came to NDMA, and here I started learning all these things. And sorry, it has been a fascinating journey. And I will just bring together a few very simple policy-related things. I must first introduce my colleague, Mr. Arvind Kumar. He's Special Chief Secretary, Andhra Pradesh, and sorry, Telangana. And he is an IS officer of several years of experience. He's been handling disaster management there for about a year. And he and I found each other in college and then in our post-graduation when we are doing our MBA together. So he chose his skills on the civilian side, I chose mine on the police side. So this presentation is here. This presentation is basically not for the experts sitting in the room. It is meant for the state representatives, people who are like me, who do not understand, yes, there is a satellite, and yes, there's a nice picture that comes on Google Earth. People who are working in DDMAs or SDMAs, this is being telecast YouTube or live on YouTube. We will also keep recordings of it, and we will send proceedings to every state and every district so that we can be evangelists for open source GIS usage. Now, this is the basic dictionary as a young student of satellite and GIS, learned from our GIS team that there are three very important words that all of us should know, and that is spatial, spectral, and temporal. Spatial simply means 1 meter resolution, which you hear at times Dr. Prakash Chauhan on television saying it's sub-meter. So sub-meter means 0.5 is going to centimeters, and higher resolutions means 1 kilometer or more than that. So spatial means resolution, means the camera on the satellite is good or really modern or really very modern. Spectral is the bands, black and white versus color. There are some 10, 15, 20, and now I believe there are hundreds of bands. So these are spectral issues that come into a satellite. And the last is how much does it pass over? Once a day, once in 5 days. That is the three basic definitions. We are now running a joint working group along with NRSC and other policy institutions and Government of India to design what Government of India's Ministry of Home Affairs need is for Earth observation satellites. So we are working very closely with Dr. Rao of NRSC and several other experts. So these are the three words they've taught me that this is the fulcrum of everything. Then there are two more very interesting words. One is polar orbiting. So polar orbiting, North Pole, South Pole, North Pole, South Pole. They are basically low Earth observation and middle Earth observation. Largely the remote sensing satellites which can see through clouds, we can see through rain and see through the monsoons are in polar orbits, and then thermal infrared satellites also. The very high, these are all 400 to 1000 kilometers height. Then you have the geostationary satellites. So the geostationaries are the ones at 36,000, and as Dr. Chauhan has very nicely tutored me last night on this presentation, he told me that putting a geostationary satellite up in orbit is a very difficult task. That's why it's done slowly and slowly. So it's a very technical and important task, but that's 36,000 kilometers, and it's used for communication satellites and for MET satellites, where you don't need very close resolution. So this is the basics. This is what we will, as a slide, carrying in our thing, and we'll explain it slightly, just so that the person working in the district understands what this is all. Then there are 7 challenges we found that SDMAs basically face. So SDMAs, you can also read along with DDMAs, that the depth of awareness as to what GIS can do is not available. Then there is a shortage of trained manpower. एक आदमी होगा बेचारा टूटा हुआ डिस्ट्रिक्ट में जिसको कह दिया होगा अच्छा GIS करते हो तो गूगल अर्थ पे करते होगे और क्या करते हो. So there is so much more to it. There is so much you can learn from that. So we want to address that problem. Then what is there is a serious absence of dedicated labs even in national institutions which are new. You may not find these labs as yet. Decentralization of GIS databases is something that Dr. Chauhan and Dr. Durga Rao are working on from NRSC. There's limited funding. As it is, disaster management gets limited funding despite the Finance Commission having provided so many funds, especially on the CBT, the capacity building and training window. However, there is still a limited funding at the district levels for sure, and in some states as well. Then there is need for high resolution hazard database so that the person working on the subject in the district or the state is able to provide a good quality output and real-time data accessibility. If you're asked कि अभी वहाँ पे flood हो गया, वहाँ पे क्या situation है, so how do you get there? This is the general reason why we did this workshop. We don't want to come here and teach the scientists science because they know it. We want them to tell us and our SDMAs how to go forward. Easy solution, one-stop solution is free and open source databases. There are several available. In this presentation, we are just trying to show you that where are they available, some of them. We may not be able to tell you all because it's a longest list, but here is what we can do. What will this give us? It will give us real-time access, diverse data sets will be available to us. We can integrate it with new tech and build institutional capacity. Like if one of us, like my colleagues in NIDM are here, that if they build a proper GIS lab, then the next generation after them and the next generation after them will be able to build on it and make it a strong institution. Promote collaboration, and finally, community-driven development. These are the 7 things. Main one thing is free and open source databases are available. So where are they? Now, here are some of them. They look a bit small on the distant screen, but when we share this, you will be able to see these are the Indian ones. Like you have Bhukosh, which is, I think, GSI, Bhuvan, which is NRSC, MOSDAC is also NRSC, and NDEM is something which NRSC has worked with the Ministry of Home Affairs to give you real situation of early warnings all over the country. Then these are top three, 4th to the 6th American, and the 7th is European, 8th is European. And then these are all open source free ones, like which are owned by private companies like Google Earth and various others. So this is a they're not all, there are hundreds. However, this is where you can start if you are a beginner, and this is, we feel, the best place to start. Then there are some YouTube channels which will teach you how to do this. So there are about 10, we just listed them out. And I noticed that when my team made this, they repeated 3 of the YouTube channels twice. So I had to delete them in the morning when I was prepping. So, but they were very happy with the nomadic owl. I don't know why they like the nomadic owl so much. He was repeated there 3 times. So anyway, that was a very nice collection. Some of them are Indian, some are foreign, some are American, some are European. So you'll find a good mix, but decent courses which you can teach yourself. Now, this is basically for the scientists and just to show that NDMA knows all these things. It's not that we are talking out of a hat. So there are essentially 3 types of satellites. The SAR satellites, which are also coterminous. SAR is the output you get, and microwave satellite is what they call the satellite. Then optical imaging satellites and thermal infrared. Then another listing of what is available in these images. Now here is an image that was given to us by our international partners, the SDC, the Swiss Development Corporation. They're sitting in the corner over there very quietly. So this is based out of remote sensing imagery. So remote sensing imagery is used for this analysis called interferometry, which can tell you that a slope is moving or not. It can give you very, very small movements in a slope, which is very important for landslide and glacial lake prevention, or early warnings and various other things. So NRSC is working very deeply on this subject. IIRS in Dehradun has a full training center. They teach the subject very well. So this is what you get out of remote sensing imagery. Here is an hydrometeorological map, which is of the South Lonak Lake after it had burst. And here is the photo optical imagery of the South Lunar Lake. All of this provided by NRSC from their domestic sources as well as their international alliances. This was a high resolution image picked up by, I think, the
There is a satellite called Khalifa Sat.
Khalifa satellite from
So
UAE.
UAE.
So it was very high resolution, which is why you're able to see immediately after, 3 days after, they send us this imagery. So a photo is also very important, remote sensing is also very important, and thermal infrared is also very important. Now quick last 5-6 slides, not spending time on them. Here are the global optical imaging satellites that are available. The higher resolution ones are free, available for anyone to use. The lower resolution ones, I mean the under sub-meter type of resolution ones are paid. So you can make do with the above 5-meter resolutions. Here are 2 slides which show you which are the free and which are the paid ones. When this presentation goes down to the DDMAs, we'd like all the SDMAs to send it down to the DDMAs. Please use these, experiment with it, learn from those YouTube channels, and whenever you need any help, you can reach out to NDMA, NIDM, NRSC. That's why all of us are available here. This is the second slide. I mean, no need spending time on it. And then the 3 slides on what Indians' satellites are like. India has these remote sensing satellites. Some of them are now retired. Some of them are operational. I like the way they use the word retired. It sounds like human beings. And then you have thermal infrared satellites, and then navigation satellites, which they are now planning to launch, which there are several, all of them are in various stages of development. So that's all we have, and we look forward to interacting with you. Please interact very freely and openly. This is a workshop to learn, and please remember, it is a workshop to basically tell the states that this is all that is available. Please use it. Thank you.
Thank you, sir, for your insightful overview
Very nice,
of
sir.
GIS and space technology in disaster management,
It is good
setting
to
the
have
tone of the today's
a simple
workshop.
class.
Now, we are privileged to have a visionary leader in remote sensing and geospatial technology with us today. Please join me in welcoming Dr. Prakash Chauhan, sir, Director of NRSC, to deliver the chief guest address. I welcome you, sir.
Namaskar, good morning. Respected Shri Rajendra Singh Ji, member and HOD of NDMA on GIS. Shri Safi Ehsan Rijvi Ji, advisor mitigation NDMA, and now is also looking after NIDM as the director or director general. I'm not sure what is the position. Executive director, sorry. Our Shri Arvind Kumar Ji, who has come all the way from Telangana. I'm also coming from Hyderabad, so very warm welcome to you, sir, also in this workshop. And our WhatsApp member NDMA, my own colleagues, Dr. Srivastav, Durga Rao Ji, many other colleagues from NRSC, ISRO family, and all the participants of, I also see some of my remote sensing fraternity colleagues. Sultan Singh Saab is there, and then there are many other colleagues attending this particular workshop. Very warm welcome to you and greetings from my side. In fact, it's so heartening that this particular workshop on harnessing space-based Earth observation and GIS for disaster risk mitigation is being organized by NDMA in association with NRSC, mainly to spread the information about the end use of these satellite data products. And I'm very thankful to Rijvi Saab for giving a very simple, tutorial on basics of satellite technology. So my life has become relatively easier. Thank you very much, sir, for that. As you must have seen, this entire space business is a very complex and complicated business. And for a person who is not into this field, it becomes really difficult to understand what's going on. This is my 35th year in ISRO. And frankly speaking, we even don't know more than 2 or 3% of what is happening world over or within Department of Space in other domains of space technology. So such a multidisciplinary and complicated field is space technology. That's why it's called the last frontier of technological excellence in the world. And you have to be really perfect in the field of space technology. Otherwise, it's also a very cruel world, and it will show you that you are not good enough. And we saw recently when our very trusted, rocket PSLV, which has already flown 61 times, and this time it was about to launch a very important Earth observation satellite meant for disaster risk reduction, a synthetic aperture repeat satellite called RISAT-1B, or we also call Earth observing satellite number 8. It could not deliver into the intended orbit and the mission failed, in spite of a proven track record and very good heritage of launch vehicle systems. So this tells us that in the field of space technology, you really cannot be complacent, and then you have to have 99 point is nothing. You have to be 100% in each aspect if you want to have the successful outcomes. So that's the complexity of the space related aspects. But as राजेंद्र सिंह जी told, a beautiful शेर जो आपने बाद में सुनाया, और उसका लुब्बो लुभाव ये था कि आपको थोड़ा सा ऊपर जाना है, ऊपर उठना है, तो आपकी निगाह जो है वो ज़्यादा चीज़ों को देख सकती है. You can see many more things what we are not able to see while we are on the surface. So that's the advantage of satellites. Sir has very beautifully told about different orbits. So most of these satellites which provides you a good high resolution imagery, like he talked sub-meter or less than a meter spatial resolution, most of them they work in the polar orbiting orbits. We have even in polar orbiting orbits also there are multiple orbits. So there are orbits basically which have different inclinations, which are like if you have a 98-degree inclination, satellite will come only once or twice. But if you incline it more, then you can have at least 6 or 7 revolutions, but you will not cover globe. You can only cover the equatorial part. So like that also there are subdivisions in these orbits also. So essentially for imaging the Earth, we are using these low Earth orbits to get high quality optical data as well as microwave data through which you can see through clouds also, or if you want to do imaging in the night, that also is possible. But we are also using for certain disasters the meteorological satellites, which are essentially at 36,000 kilometers. Why they are put at 36,000 kilometers? Because the velocity which the satellite will move and the velocity with which the Earth is moving in opposite direction. If you place a satellite in equatorial orbit around the equator at a certain position, the relative velocity becomes 0. So satellite will continuously see same place, 24/7. So every 10 minutes, 15 minutes, you can open the camera and then you can see the dynamic systems like cloud movement. So that type of satellites have given a large amount of information and it really changed the way today we do the weather forecasting. Especially, in case of disaster, it has really provided the most desired results in terms of early warning for cyclones. As you must have seen, India is almost a world leader in terms of providing early warning to the cyclone forecast. 5 days in advance today, we come to know through our geostationary satellite and a specialized satellite in low Earth orbit called a scatterometer, which gives you the wind speeds over any oceanic region like Bay of Bengal or Arabian Sea, that when the winds have started curling, almost when it starts initiating, that day itself we are aware that a depression has formed and it is likely to intensify to become a cyclone or a super cyclone or something like that. And this every day, every 15 minutes, satellite images, when they are put into a cyclone forecasting model, very precisely you are able to forecast for next 5 days that at what location this satellite is likely to do landfall and what is likely to be the wind speed and wind direction, so that people at ground, especially sir must be aware when Andhra and Telangana was aware that how a system on the ground exists where people are taken to shelters and then evacuation and all those things happens. So this is a completely operational system in India today. both from space, forecasters, and the administration when it happens. And the result is, today, whenever a super cyclone-like situation comes, the casualty figures are always less than 2 digits, which was never the case. Like super cyclone in 99, Orissa killed more than, I think, 40,000, 50,000 people, and maybe more also. So this is the real case study of the use of technology as far as early warning for some of the slow-moving natural hazards are concerned. So cyclone is a slow-moving natural hazard. It's easy to predict, but still you need a lot of data. That comes from various sources, even from the ground-based source. But there are certain natural hazards which are low in frequency, but the intensity of damages is very high. One such thing is earthquakes, actually. So earthquakes, they don't come daily. Of course, many of them, you can say that if we see seismological records, earthquake less intensity around 4, 4.5, they keep on occurring on everyday basis. But the real devastating one which have a magnitude of more than 6 or so, their frequency of occurrence is less, but they cause large amount of damage. We are still struggling, in terms of finding solutions for early warnings for such earthquake system because of the nature of the science problem. The earthquake occurs deep in the earth crust. Of course, they occur mostly at the continental boundaries where two plates, they converge. But when they will occur and what time they will occur, that's very difficult to predict and model. So now we are going to launch this month or maybe in the June another satellite system which has been jointly built by India and USA. It's called NASA ISRO Synthetic Aperture Radar Mission. And this is also a radar, but it will do a very precise interferometric analysis of deformations which are caused by this plate motion. So let us say if you are living in Himalayas across the fault boundary, plates are going against each other. They are producing a very slow deformation of the crust, which is of the order of millimeter to few centimeters. By using these satellites, you will be able to quantify the amount of deformation which is caused by the strain which gets produced by this motion. And then you will be able to pinpoint or locate that this probably could be a reason where a possible seismic hazard is growing up, and will also helpful in terms of predicting when the strain level crosses a threshold and the slips can happen. So this is a very important satellite. It's one of the costliest satellite ever built by any space agencies. This time 2 of us are coming together. The satellite itself costs more than 12,000 crores. So, and a very prestigious mission. So in June, we are going to have a launch of this with our GSLV Mark II satellite, hopefully in the 3rd week of June. The dates are getting finalized for that. So this will be a game changer as far as, natural hazards like earthquake and landslides are concerned. Apart from that, hydrometeorological, natural hazards like floods. There is a good amount of work which has been done by NRSC, Central Water Commission, and other agencies in terms of providing early warning for floods. We have now, established models for not only one-dimensional flood forecasting, but two-dimensional flood forecasting, and up to certain extent, three-dimension also. So there is something called spatial flood early warning system. So whenever the water is rising in the rivers, when it rises below certain threshold, the embankments will be breached, and the surrounding areas water will start spreading. So this process, if we can model 48 hours in advance based on the weather forecast data, you will be able to give early warning to the villagers or people living around the banks of these rivers that, like, look, your area or your house is likely to get inundated. And with this, we are also able to provide you the flood depth. That means how much amount of water height is expected if this much rain will occur. This model has been operationalized, has been tested, validated for 2 river basins, Tapi and I think Godavari river basin in Andhra Pradesh. And 3 years we have consecutively run and then given operational forecast to the local administrators. The feedback is very positive, and based on that now Central Water Commission is expanding these particular models to other river basins of our country also. So that's the progress as far as spatial flood early warning system in the country is concerned, and Dr. Durga Rao and his full team is involved in these aspects. But as the topics of this particular workshop are concerned, as he emphasized the need of, preventive measures or risk reduction, you need large amount of databases to know which are the areas which are more risky, where vulnerabilities are more and exposure to the hazards are also more. So in that context also, instead of providing near real-time service, space-based historical data also provides you an insight of exposure of various natural hazards as far as the population density is concerned. So what we have done, we have been mapping every year the floods using satellites, both optical and microwave data, and generating what we call as the spatial flood maps for entire flood seasons. So that type of data is available for the last 25 to 30 years over India now. And they have cumulated this data at a grid interval of 50 meter by 50 meter. NRSC has produced now what we call as the flood hazard atlases. And these flood hazard atlases has been produced at a state level also. As Rajendra Singh was telling, that one such flood hazard atlas is going to be released for Assam state, 16th of this June by Honorable Home Minister, when we will going to have a function. Essentially, it tells you the cumulative flood frequency at that particular grid, at a 50 meter by 50 meter grid interval. Now, what is the use of this data? This data is very much useful for any kind of planning activity, any kind of activity which is related to the risk transfer in terms of insurance, and then generating parametric insurance solutions. So, if you are going to make a road in an area which is frequently flooded by floods, you are aware the kind of risk which you are going to face in future, and then you can design your your structures, civil engineering specifications in a way that you can account for that kind of scenarios. If you are going to buy a land in that area, or you are going to build a house in that area, insurance company can charge you more premium because you are now more likely to get into trouble very frequently, so you have to pay more. So it helps insurance guys also, and your risk transfer is also ensured. In developed countries, such kind of products are very common, but in India still we are evolving the insurance industry. So this is one example which I told you. There are multiple such examples. We have now almost 25 years of data of forest fire occurrences in this country. Which are the areas where forest fire occurs because of the forest fires we can monitor from space, and then generate a cumulative forest fire occurrences, and then also identify areas which are prone to forest fires. We are also using this technology not only for forest fire, for agriculture fires. In our country, especially in some northern states, I will not take the name because some of you may get angry, but you know that the crop residue burning is a very prevalent exercise. So using space technology today, we are able to provide very detailed information about the fields in which the crop residue burning is happening. Sultan Singh ji is sitting here. He is using this type of methods to reduce and to discourage farmers to burn, so that some punitive actions can also be initiated based on this data. I am one of the technical member in CAQM, Commission for Air Quality Management. Every time, every month, we are issuing large amount of warnings, and then data-driven approaches. Even in Supreme Court, these matters goes very frequently. So satellites are playing a very important role in terms of also identifying agriculture fire situations and how these agriculture fires are, enhancing, decreasing over a period of time, and how the policies which are, put by government to reduce this type of things are working on the ground. That is another aspects of it. But having said that, still we need to do lot of things. Sir told that there are so many satellites, but as a professional who is working in the field of space technology, I can tell you that we don't have enough. Many times we found wanting, whenever a disaster occurs, we will get a request from the local authorities, please provide satellite data. 2 days back in Bangalore, there were a lot of floods. A lot of people were, affected. I started getting requests, provide me the satellite data immediately of this area. In flood situation, what happens? There are clouds, optical satellites cannot see through clouds. I need a radar. I have only 1 or 2 radars with me. They may be not going over Bangalore at that time. They may be available on Delhi or somewhere else. So, as a country, if we have to provide fruits of space technology, I think we have done something, but we have not fully tested ourselves so that 24/7 on demand basis, if I am able to provide satellite data, that is why is the scenario we have to build in this country, and ISRO alone cannot do that. That's why the government of India has brought in 2023 what is called the National Space Policy, where private sector participation in space is now opened up. There are companies, some of them are sitting in this room also, which are very actively even developing satellites. They are launching satellites, and we are encouraging them. In fact, NDMA is also in discussions through InSpace with many of the private operators that to how to access their satellite products and how these can be integrated in our operational system. So this is another area which is developing very fast, and we will see that this will provide a lot of employment opportunity as well as technology infusion in decision making in the government of India. Couple of 2-3 things before I close. I would also like to inform you that what NRSC has done in recent past, we have also developed a portal called National Database for Emergency Management, and this portal is now is part of the integrated command and control room which has been established at Ministry of Home Affairs. This portal has been ported there, and it has started functioning. In fact, this month itself it was supposed to be inaugurated by Honorable Home Minister, but that function has shifted now next month. What it does, basically it provides you all data by the forecast agencies which are specific to disaster, like IMD. You have to go to IMD site and all those things. CWC, water level data, it is available somewhere else and all, you don't know. So all forecast agency, INCOIS, CWC, IMD, Forest Survey of India, forest fire related data, all data is now integrated and has been brought at one particular portal. Flood occurrences, near real-time data, flood forecast, everything is seamlessly available on one particular platform, and that is what is the advantage of this NDEM portal. For our NDRF colleagues, there are some special functionalities also has been built in, so that when they are supposed to be tasked by doing search and rescue, they can do planning and then they can also mobilize their resources based on this particular portal. So it's a very interesting portal. I will encourage, he has also given a list of that. Some of you can go through this, otherwise Dr. Durga Rao is here, he is also going to talk about it. There is another concept which I thought I must tell you. This is called International Charter for Space and Disaster Services. See, in case of major disasters, various space agencies of the world, they come together. Because as India, I may have some limited assets, but as a world, some 30 space agencies are coming together, and then they are providing their satellites like Khalifa Sat data. You see, we got that is through this International Charter, invocation. So for this 6 months, starting from April to September, ISRO is leading this International Charter efforts, and we are taking a leadership role. Recently, we conducted a meeting also in Hyderabad about this. So our commitment not only to give our satellite data, but also receive satellite data from others is established through this mechanism. So many times when big disasters like Wayanad tragedy happened, we invoke this charter and then we start getting a lot of satellite observations from other sources also, which are either in commercial domain or typically not shared with ISRO community. So this is another important thing which as a disaster manager you should be aware. And then ISRO is the nodal agency to invoke. You yourself can invoke charter through ISRO. You can tell us that there is a situation, then this can be invoked. Then apart from that, as I am telling you, I talked about lightning is one of the another important thing. Lightning, maximum amount of casualties are happening in this country, not because of earthquake, not because of floods, not because of forest fire. It is happening because of the lightning. And we have set up a lightning data, collection mechanism in this country. 48 lightning, sensors have been deployed all across India. We get lightning data, which is after the lightning happens, but now we are using this knowledge for doing two things. One is to identify district and sub-district which are most prone for lightning. Many of you may not be aware that there are districts in Bihar or in Chhattisgarh or in Odisha. They are the most prone of lightning. So if they are prone, that knowledge is very important, for having mitigation measures on the ground, whether to put more lightning arresters or stuff like that. But we are using this data along with other satellite data to now do a nowcast for lightning 2.5 hours in advance, and that type of models have already been developed. This season onwards, we are going to start doing what we call as the experimental forecast for providing very precise and specific information about lightning, because it's a very fast phenomena. It happens in milliseconds, and time for escaping is also very limited. So advanced warning for such high frequency and high intensity events is very much needed. So that's one aspect, but I think a lot of work as a country we have to do as far as mitigation of lightning is concerned. Then heat mitigation is, as we are getting into climate change, and then every year we are seeing that this year is warmer than the previous year. Heat mitigation is very important, especially in urban areas. So ISRO with French Space Agency is now planning a satellite. It's called Trishna. It will provide you temperature maps of Earth at 50 meter by 50 meter grid interval. So that means that we will be having a precise temperature information of the Earth's surface at a very high resolution. And if I know that certain buildings are emanating or emitting a lot of heat because of the kind of material they have used, we can suggest them that what could be a mitigation strategy so that these buildings emit less amount of radiation. Either they can do roof paint of the roofs. Roofs can be painted with a thermal coating, or there could be more plantations, because we have seen with the satellite images, wherever you have trees and where you don't have trees, there is a difference of 4 to 5 degrees immediately. So that is the importance of planting trees. So heat mitigation aspects based on scientific data can be addressed once we have this much granular, high resolution temperature imagery of the Earth's surface. I will not take much time, but I will say that this particular workshop is a real wonderful initiative where open source data sets and discussion about it and accessibility of these data sets are going to get discussed. Of course, there are sessions on artificial intelligence and information extraction, but that can only happen when you have data. So data is the most important thing, and for that, I would like to also urge through this forum that you should basically advocate for launching more and more space-based satellite systems by Government of India or by private sector, so that the dearth of the data is not felt when it is required most. So with these words, I wish this particular workshop a grand success, and I am sure that recommendations of this workshop will go in long way in terms of addressing disaster risk reduction initiatives of NDMA and making India a safe and resilient country for disasters. Thank you very much.
Thank you, sir, for your enlightening words and highlight the transformative potential of space-based technology in disaster risk reduction. Now, I request Arvind Kumar, sir, to please deliver a few words.
Morning, everybody. I'll just quote few instances from the state's viewpoint and how these technologies are extremely important for us. For example, first is flood, as Dr. Prakash was earlier mentioning. Right now, it's the late harvesting of Kharif crop, and the IMD predictions have become so accurate that we are able to inform the districts and through districts at the panchayat level days when they should not purchase, and they accordingly inform the farmers. Crops are not brought, otherwise in previous years they were left open and they used to get damaged. So now they are getting covered in tarpaulin, and during the period when heavy rains are there, it's like a holiday so far as crop purchases are concerned. Extremely useful, and the predictions are near perfect so far as rain predictions are concerned. Heat also, earlier he was mentioning heat mitigation. There's a World Bank study of October 2024 which says that early warning systems for heat stress is extremely useful in preventing heat-related casualties. The cost-benefit analysis is almost to the extent of 50 times. So that's again, we have used extensively in this summer, and again with the help of IMD, we are giving district-wise predictions on yellow alert, orange alert, and red alert, advising Manrega workers in rural areas to either take a break during the peak summertime, that 12 to 4 period. Likewise, construction workers. So use of technology in terms of preventing casualties is extremely useful. Third immediate kind of instance which comes to my mind is there was a tunnel collapse in our state, Telangana, in February, where an underground tunnel, which is an irrigation tunnel, at the end of 14th kilometer got collapsed, and 8 workers got kind of trapped in that. We contacted NRSC, GSI, NGRI, National Center of Seismology, Ministry of Earth Sciences, and National Institute of Rock Management. Simple use of technology, the ground profiling, ground penetrating radar, GPR, which is used by by NGRI, could actually tell us the exact location when the slush and water was there, that from a distance from the end of the tunnel, 2 meter and then 3 meter depth, there is a aberration. They don't call it a body, but there is a disturbance. And 2 of the bodies could be traced because of the use of GPR technology. The rest were at the end of it, and that's GSI told us not to go there. But extremely thankful to NRSC, GSI, NIRM, NGRI. In fact, we have formed a technical subcommittee to go ahead on this tunnel, because we have already done 14 kilometers. From the other side, we have done 9 kilometers. And in between, there is about 5 kilometers left. It's full of rocks above. There are 500 meter depth of rocks are there. So how do we go ahead? What technology should be used? It was right now, what they were doing is tunnel boring machine. But now the technical advices that we should do drill and blast method. So the use of technology at the field level is extremely useful. In fact, earlier what Safi was mentioning, that at the district level, we are still kind of the data dissemination, awareness, and accessibility to data is kind of limited. And that's where I think if we work together, and thanks to NDMA, the kind of leads it has taken in last 2 years, we are working in great kind of collaboration and cohesion as a team with NDMA. I can see in my experience in disaster management during last 2 years, what it was 2 years back, last year, and this year, our preparedness for floods, to how to tackle it, the flood manual we have prepared with the use of technology, and how it's going to save the lives at the field level. I think that's the real benefit of these use of technologies, and I think we are in for good times the way things are happening. Thank you so much.
Thank you, sir. Now I invite Dr. Kajal Joshi, Senior Consultant GIS at NDMA, to deliver the vote of thanks. Please join us in welcoming her.
No, you can quote it. No problem. It's already an approved project. Work is
Very good morning to all of you. Respected chief guests, honorable dignitaries on dais, esteemed speakers, distinguished guests, and dear participants. It is indeed a privilege and honor for me to express my sincere gratitude on behalf of the National Disaster Management Authority and organizing team for this wonderful workshop on harnessing space-based Earth observation and GIS technologies for disaster risk management. First of all, I would like to extend our deepest appreciation to our chief guest, Dr. Prakash Chauhan, Director NRSC, for his inspiring address and for highlighting the strategic importance of space-based technologies in enhancing our disaster risk management and disaster resilience framework. Our sincere thanks to Sri Rajendra Singh, member and HOD NDMA, for his thoughtful words that gave us a strong start today and reminded us how crucial scientific thinking in disaster management. I also express my appreciation to Sri Safi Hassan Rizvi, Advisor Mitigation, NDMA, for providing a comprehensive overview and for his continued leadership in bringing geospatial applications within our mitigation strategies. I would like to acknowledge the presence of all the dignitaries on this dais, senior officers from NDMA, NRSC, and all our esteemed colleagues who have joined us today in person and virtually. A special word of thanks to our esteemed collaborator from NRSC for partnering this wonderful workshop with the NDMA in organizing and support for this workshop. Your support and technical leadership are valuable in bringing together the stakeholders from government, academia, industries, and innovative hubs. To all the participants, scientists, researchers, technologists, policy experts, and young professionals, thank you for all your enthusiasm and commitment. Your active involvement and participation throughout the day's session will be crucial in shaping actionable insights. I look forward to a day of rich discussion, meaningful exchanges, and collaborative moments. Let this workshop serve as a catalyst for integrating geospatial intelligence into every layer of our disaster risk management efforts. Thank you all once again for your presence and contribution, and I wish you all a great and productive day ahead. Thank you.
Thank you, ma'am, for your kind words. May I now request Sri Rajendra Singh, member and HOD at NDMA, to kindly present the mementos to our chief guest and Arvind Kumar, sir. Then join. Already photographs, sir. So comparing the
Thank you, sir.
Now we want to release the acknowledged compendium of NDMA's 6th Coder Workshop on Earthquake Risk Reduction, held on December 6, 2024, which was jointly organized by NDMA and the National Center of Seismology.
So we try to do all these workshops jointly with the scientific institution that leads the thing, so that jointness can come through, states can be a part of it. So earthquake was number 6, we are now at number 13. So please wish that we reach 100 very soon.
Yeah, thank you.
Ladies and gentlemen, it's time to recharge. Tea and snacks are waiting. Please be back by 20 minutes. Fresh and refreshed, ready for our next technical session. Don't make us send a search party. Move into our heart. Abhi? Ladies and gentlemen, as we move into the heart of our workshop, let's reflect on the dynamic challenges need India face in disaster management. From flood sweeping through our river basin to landslide in our hilly terrains, our nation's risk landscape is a diverse in its geography. While satellite imagery and early warning system provide critical foresight, it is the integrate of GIS and space-based technology that empower us to act swift and effectively. Thus, dear friend, it's necessary today's workshop. We are here to explore practical, scalable solutions that harness this technology to strengthen disaster preparedness and response. Our first technical session focused on uses of open source GIS platform in disaster management. Now, when we think of open source, we might imagining free softwares and endless possibilities. But today, it's about accessibility, collaboration, and building resilience system for disaster management. This session will explore how open source GIS platform can transform the way we prepared for and response to disaster. We are delighted to have this session moderated by our Safi Ahsan Rizvi sir, Advisor Mitigation. The esteemed presenter and discussion include Dr. Durga Rao from NRSC, Dr. Manamendra Saharia, Associate Professor at IIT, Sri Prashun Kumar Gupta, Scientist at IIRS, Sri Krishna G. Lodha, Founder of Rotten Grapes Private Limited, and Sri Rohan Verma, Director at MAPA India. To know how about our moderator and speaker, just scan the QR code on the back of your ID badge. Their work in geospatial technology is truly inspirable. A big warm welcome to our moderator and panelists as we kick off this meaningful session.
Hi. Oh, okay. Hi, go. Dr. Saharia. Water. Which of the water is good? Replace the bottles and the glasses. ये नहीं change हुए ना? Water bottles और glasses change हो गए. कहाँ पे कर दे? We are waiting for Dr. Saharia. Is he here? Where? Ashok, please look. Dr. Saharia. Kajal, can you raise your voice, which you normally don't, and tell everybody to come in? She's very soft spoken. Ah, sorry, it's a bit tight. Okay, thank you everybody. So we won't take time. I want to do this in about 60 minutes. So what we have is, Dr. Chauhan had to leave, so I am sitting in for him. Mrs. Sri Lakshmi couldn't make it, so Director of NRSC, Dr. Durga Rao, is here. He will make that presentation, and then we have one from Dr. Saharia. So request to Dr. Durga Rao and Dr. Saharia, please keep it to 10 minutes each. The idea is to get our panelists to make comments and to open this up for discussion. And the whole focus is on usage of open source GIS platforms. Usage. So on that basis, we want to do this 1 hour with some decent interesting inputs from everybody. Over to Dr. Durga Rao.
Respected Advisor NDMA, Raju Sab, and all other panelists and presenters, and respected Arvind Saab and all senior officials from various state disaster management organizations. So, good morning to everyone. So I am the opening batsman for this workshop. Okay. First time we are asked to make a presentation on geospatial services in disaster risk management. Generally, we make presentations on space technology, role of space technology in disaster management, okay, and modeling, mapping, etc. So, so what is the role of geospatial services in disaster risk reduction? Geospatial technology is one of the advanced technologies in the disaster risk management, along with other technologies like nowadays we call AI, smart sensors, early warning studies, etc. Okay. Now, I'm not going to discuss any basics of GIS. Okay, time is very short. So, how these technologies can be used in disaster risk management, I would like to discuss with the background of our NDEM, National Database for Emergency Management, which is a national level major dashboard in the country, geospatial dashboard in the country for disaster risk management. Now, coming to the situation level awareness when there is a disaster, okay. First, people will ask where it happened. Okay, even we also ask. Somebody asks satellite data, we will ask, can you please share the latitude, longitudes? Okay, so where it happened, when it happened, how it has happened, okay, and any other information. Okay, but if we can refer all these details with reference to a location, okay, on the map, so then it means it is nothing but a geo-positioning of the disasters. So this is very much important for emergency management. For NDRF people, if they want to go for relief and rescue operations, they should know exactly where they have to go. Okay, so GIS platforms can provide a solution for that. And another thing is processing of the spatial and non-spatial information to establish situational information. That is also one of the requirements for the situational awareness. Now coming to the role of GIS, the collection of spatial and non-spatial database, integration and analysis. So when there is a disaster, we get lot of information from multiple sources. Okay, we have to collect the information, integrate, analyze, and filter it. You do the quality study, quality analysis, everything. Finally, generate the outputs which are useful for the public, for the disaster management officials, for the actions on the ground. Okay, so and provides effective means of data distribution and handling, and estimation of redundant database. So when we get data, we get lot of duplication of the data. We get a lot of wrong information also. Okay, so that type of information we have to filter it. That can be done in the GIS. And capacity to integrate information from many sources, and complex analysis query involved in the geographical reference data to integrate the information, and maximize the efficiency of planning and decision making. So the main objective of GIS in disaster risk management is collect the data, the spatial data or non-spatial data, integrate, analyze, okay, and you will have models inbuilt, okay, you have decision support tools inbuilt, and finally give the solutions for the decision makers in the geospatial platform. That is the main objective of the GIS in the disaster risk management. Okay, coming to the National Database for Emergency Management, which is the, I can say, the biggest geospatial platform in the country to address the disasters in the country. Okay, in all phases, response phase, mitigation phase, and early warning phases, and addressing all natural disasters, floods, cyclones, landslides, earthquakes, forest fires, etc. Okay, not only our space-based products, we disseminate services from forecasting organizations like Central Water Commission, India Meteorological Department, DGRE, INCOIS, etc. So now you can imagine when we are, it is a unique platform, national platform. Okay, this is the GIS dashboard, NDM dashboard I'm showing here. Okay, so when we are collecting the information from multiple sources, okay, addressing all natural disasters in all phases, you will have huge database. Okay, so you need different softwares, different algorithms, different tools to analyze the data from all sources and to get the solutions for the decision makers. Okay, coming to this NDM dashboard, only screenshot I'm showing. You can go to the NDM dashboard also. I have given NDM dashboard link in the first slide, ndem.nrsc.go.in. Okay, so this is the dashboard. It looks like. Okay, this is the pan-India disaster scenario on any given day. Okay, what are the disasters in the country? You can visualize in a single stroke here. Okay, all disasters geospatially represented. Simply zoom it, click it on anything, any forest fire or landslides or any earthquake or any information about floods, anything. If you open this dashboard in another 1 month, it will be cluttered with a lot of information, because nowadays, right now, it is not a disaster season. Still, a lot of things are there. Okay, but next month, if you see, a lot of information will be there. Okay, so that much information we have to analyze in real time and provide the solutions. It is not a small thing to do. Okay, now apart from this space data, our satellite-based information on floods or cyclones or forest fires or landslide, whatever it may be, apart from that, apart from the services from the forecasting organizations, in the background, we have about 36 spatial layers in the NDM dashboard. We have raster database, sub-meter to 5-meter resolution satellite data sets are there. Okay, we have base data like state maps, district maps, taluka maps, rails, roads, drainages, canals, etc. We have infrastructure information. Okay, and you can see so many information layers are there. Similarly, thematic layers are there. Land use, land cover is there. Soil maps is there. Digital elevation map models are there. Mining information is there. Water bodies information is there, etc. You have some non-spatial database also, like socio-economic data, census data, health data, okay, etc. So the platform is full. It is very well rich of the information, spatial and non-spatial information. Thing is, for the complete country, we have a geospatial database at 50,000 scale. For 350 disaster-prone districts, we have database at 10,000 scale. Okay, and for 5 major cities, we have database at 2,000 scale, like Chennai, Delhi, Mumbai, for all metros particularly, Bangalore, Hyderabad. We have 2,000 scale maps. Okay, so that much database is inbuilt in the NDM dashboard. Actually, it is a state-of-art infrastructure facility available at NRSC Shadnagar campus. Okay, so it is worth seeing place for disaster people. You can come and see this infrastructure particularly. Coming to, maybe my eyesight is not proper. Okay, technological utilizations. Okay,
Spectral issues.
Oh, sir, I have reading glass only, sir. Now I realize that I need glasses for, I have to change my glasses. Now, technological utilization, okay. I'm not going to speak anything about space technology and disasters. I'm going to speak about the geospatial services only, okay. So in this dashboard, many things are developed using open source platforms only. Okay, like QGIS, it is used for database management with plugins. Okay, and ZDAL plugins, and we have GeoServer, we have map servers. So these are used for the analysis of publishing the raster data, vector data in different forms and for analysis purpose, etc. We have PostGIS, particularly used for data organization, route analysis, network analysis, space analysis, spatial analysis, and we have a leaflet. it is for particularly map rendering, zooming, zoom out, okay, and for mobile apps, okay, for visualization purpose, etc. See, these are the open source softwares we have used in our national database for emergency management. And the beauty of this system is, in real time, you can analyze. Let us suppose I am displaying runoff map of the country today. Okay. If somebody wants to know the runoff of the 15 days, simply you can query that. I want runoff, cumulative runoff of from 1st of August to 15th of August. Okay, you will get. Okay. Now we are building models for the state level information also. If somebody wants to, I want runoff in Telangana only. Okay, from this date to this date. What is the runoff? This runoff is computed using the models for which IMD rainfall data is used. Okay, using IMD rainfall data, we are running the models and runoff maps are generated. So there you can do the spatial analysis. Okay, all type of spatial analysis can be done here. Network analysis can be done here, and 3D analysis also can be done in the platform. See, now coming to the main open source, see how we are doing vector data, raster data, and services by the forecasting organizations. We are receiving through different forms. We are receiving through APIs, some through FTP, some through web services. So these are integrated in this geo server, map server, and leaflet. Finally, we are disseminating the products to the end users. Okay. Coming to the geospatial analysis for disaster risk reduction. Okay. So the important tools I am going to discuss in this. There are n number of tools. Okay. But in important tools what are required, like geo-referred news, decision support systems tools, okay, incident reporting, interaction tools, IDRN tools, recovery plan, resource management. These are the widely used by DM officials in the field. Okay, so that I have selected few tools only. I am going to discuss on this. Coming to the geospatial database, particularly disaster watch. Okay. In 2003 and 5, during that time, 2 scientists used to work on disaster watch. Okay, their job is collect the news, collect the information on the disasters from various sources, newspapers, okay, or TV channels, or social media, or from CWC sites, IMD sites, and everything, and integrate, analyze, and provide the report, disaster watch report, by maybe by 11 o'clock or 12 o'clock, like that, like twice in a day. Okay. Now what we did, we have completely automated the system. Okay. Using AI and deep learning algorithms. Okay. Now every 3 hours, disaster watch is generated. Okay. So we are taking information from about 150 newspapers, okay, TV channels, social media, and CWC sites, IMD site, all forecasting organizations, I can say. And we are integrating, and AI techniques, whatever we used for analyzing the data from multiple sources, whether it's correct or not. So I will give one example. What is the role of AI here? When we started this work, we got one news alert. Delhi is flooded with tomatoes. Because the flooded word it picked up, but news is tomatoes. Okay. So then we realized that no, something we have to do. Then we started using, similarly, there was a news article, bomb in the cap. That is the heading. Okay. But the content is the Glacier Lake. Okay. So considering this, because the news media, they have different headings, attractive headings, so very difficult to catch also. So considering this, then we used AI techniques, okay, and deep learning techniques to filter the data and to extract the data. And moreover, the data extraction also, maybe there will be flood in Hyderabad. Okay, they will some newspapers they will write 1 page write up. Some people they will write paragraph only. But we have to filter the data. We have to select only the key points and give it to the disaster management officials what they require. So we have developed this. Now, without support of any scientist, it is completely automated. Every 3 hours, people get the disaster watch. Okay. Coming to the incident reporting, this is another tool what we developed mainly for like NDRF people, those disasters which are not reported in any paper. Okay, like some NDRF official is there, field personnel is there. If you notice any disaster, using mobile app, he can do the incident reporting. He can do it. Okay, then immediately his boss has to endorse it. Okay, once he endorses, then the activation will start. Okay, then the data, then we get the message, then we provide the data, and people start sending the data from different organizations. Okay, and the complete chain is, then it will go to rescue teams. Okay, relief teams. So how to act on that for relief management, rescue management, everything, and they can upload the field information, everything. You can see here from this app, damage assessment they can do. Okay, once any flood map is prepared by satellite data, once we upload it, you can see here how many villages are affected, how much population is affected, and you can see buffer analysis at any given village location, how many hospitals are there, how many relief rescue shelters are there within 2 kilometer radius, 5 kilometer radius, 10 kilometer radius, like that. Network analysis, like if I want to rescue a person from one village to another relief shelter, okay, how to go? It may be shortest route, it may be different, but he has to go by bypassing the flood area. Okay, so flood will be the impedance map. So bypassing the flooded area, you will get the network evacuation plan also. Okay, how to evacuate the areas from that place to different relief shelters. All these are the decision support tools integrated in the NDM portal, like interaction tools. Okay, you can send the emergency alerts, emergency maps, services, okay, to the user organizations. And IDR and India Disaster Resource Network. Actually, it is a non-spatial database. We got it from NADM, okay, National Institute of Disaster Management, and we geo-referred it. Okay, non-spatial database, they give this many boats are available, these many vehicles are available, these instruments are there for the relief and rescue operations. They will give some postal code, okay, some location where it is available. We convert it into geospatial format, and once we convert it into geospatial format, you will get a map like this. The table is converted into a map. Okay, so that anybody can, by clicking that, they can know where this information is available. They did not go for any other maps. This is the relief management particularly. And post disaster recovery, I think this is the last but one slide. Post disaster recovery also, this PDN also very important. The conventional approach is fill the tables, Excel tables, okay, how much damage is taking place for different, about I think 14 sectors. And tables are available, and damage to the buildings, damage to schools, hospitals, roads, railways, etc. And the Ministry of Home Affairs generally they collect this information for the relief to the concerned state governments. Now that information it can be converted into a map format. Okay. Now you can visualize each district how much damage happened, in each district how many buildings collapsed, how many roads got damaged. In the map format also you can visualize. Okay, there are some map tools also. Okay, you can swipe, you can do the swiping, you can do the querying, you can add the images, you can add, subtract, you can draw the profiles. Okay, if you want to know the slope, anything. So this information also can be extracted. So this is my last slide. 3D analyst also there. So spatial analyst, network analyst, 3D analyst. These are the major analyst, particularly in GIS terminology. Okay, all tools under each analyst there are many tools. All tools are available in the NDM dashboard. So now we are developing 3D analyst tools. Okay, so people are more interested now in 3D. So we want to visualize the flood in 3-dimensional images. So this also we are developing. So thank you very much. So time is limited. So
thank you. Thank you, sir. Thank you so much. And we'll call Dr. Saharia now. Dr. Rao has restrained himself to an exceedance of only 10 minutes. So
I've taken more time, I think.
this word exceedance I have learned only from the scientists in this room, जो ज़्यादातर MET के ऊपर काम करते हैं. But Dr. Saharia, over to you.
Yes. I'll just wait for the PPT to pull up. So good morning, everyone. Good morning, Rizvi sir and all my NDMA colleagues. Thanks for inviting us, and we are from IIT Delhi. Is this working? Okay, all right. Well,
IIT has carried a virus with it.
hopefully not. So, good morning, everyone. I'm Manavendra Saharia. I'm an associate professor in Department of Civil Engineering in IIT Delhi. And obviously, the topic is open source GIS platforms and disaster management. Now, our NRSC colleagues has presented such a detailed presentation, so it's hard for me to, so there will be some duplication. But I'm not able to go to the next slide. Okay, fine. So I think it's kind of a provocative slide. Whenever we kind of visualize GIS, we always visualize one guy in front of a computer or a girl in front of a computer and making maps. That has been the vision of GIS for probably 30 years till 5 years back, right? But now GIS itself, that's why we say the old school of doing GIS is dead. And now there is a new way of doing GIS where it's cloud native, where it's ML, where it's machine learning native. So the whole business of map making itself has changed is that, and what we should consider today probably for discussion is, what are the new things we need to do in terms of building databases that are ready for the future? Because we are no longer building just maps. So this is just a slide that showcases some of the GIS touch points in the disaster cycle. Obviously the main categories are the mitigation, preparedness, response, and recovery. There are different topics within those areas like zoning, risk maps, forecasts, scenario models, inventories, live dashboards. All of them have been working for quite some time now. There are different open source tools that are available for doing it. Obviously, there are commercial packages as well. But there is a distinct benefit for always open. I really appreciate the previous presentation focusing on open source, is that there is a big benefit for open source, and somehow people always think that open source is just because it is free. It is not because it is just free. It is because it's also better in many ways. Licensing fees, these are all money related, and there is no vendor locking. But from my experience, short experience that I've seen, especially in academic projects tend to die the moment funding stops. And all the outputs that have come out of it, dashboards, apps, they are all dead within 6 months of the project has ended. That is because the person has bought some commercial software and you have bought a 3-year license, and by the end of the project there is nothing to transfer, or you'll probably run it for 1 more year with some extra money, and the user agency cannot continue. So it's not just a monetary benefit, it's also a continuity benefit for the government. Now there is auditability and transparency. This is where I think it's very important, in that we are able to investigate what are the models that are actually going into these softwares. I can talk from my world. I work in water resource. So for example, if we are using some kind of hydrodynamic model, so what exactly are the assumptions baked in? Because that will have an implication of what are the flood risk maps that you are reporting. Because different models work very differently. You may categorize them as hydrodynamic models, but they don't work all the same. So the results may be drastically different. So it's important to have full transparency in the models. That is only possible in open source. So the future of GIS is also, I will not talk about QGIS and GRASS because that has already been covered, but there are new tools, new databases that have come up like ZAR. So ZAR is a new format that is now extremely popular in the past 1 year or so, because it is cloud native. Because earlier when you'd have to download a database, you'd essentially have to download the entire database, and then, for example, you will download a 2 GB shapefile or something, and then you will start working on it. Now that is not possible with satellite data, that is not possible with new kind of databases that are in terabytes and even in petabytes. So oftentimes when you want to query only for a small area and probably only for a subset of the variables. A data set might have 25 variables. You don't need all of them, maybe you need only 3. So there have been other, like stack APIs have been in existence for 10, 15 years now, but ZAR is the latest one that is becoming very popular because it is cloud native, and most importantly, it is machine learning native. The data sets that have been stored in CSV files or shape files, they are extremely hard, near impossible to work with machine learning algorithms. But to work with ZAR for new tools that makes it useful for the future, as well as things like DASC, which are parallel compute for parallel computing. So what I want to talk about is the future of GIS is not software alone. It is not developing a map. The future of GIS is workflows. Investigating where the workflow is entirely repeatable and you're able to investigate all the components of that workflow. So I will just, in the interest of time, I'll just show 2-3 applications within 5 minutes. And everyone kind of who has worked in GIS now has worked on Google Earth Engine. And it's not the only engine that is available right now. There are tons of engines available, and people are also developing in-house as well. But the power of cloud computing that is easily available to everyone right now is easily available is Google Earth Engine. And the benefit is that you can get access to petabyte scale data sets without having huge storages on your own. And you can analyze a large volume of data. You can look at all kinds of like trends, differences. You can develop new models, new methods without having to download and have a very powerful computer of your own. So there are 3 tools that we have publicly launched. One is the National Landslide Susceptibility Map, Indian Landslide Susceptibility Map, which is a 100-meter national ensemble data set of landslide susceptibility. There is an infrastructure data set map that we have released just 3 weeks back. This is where we have mapped all the roads, railways, and the buildings of India for landslide susceptibility, and there are some numbers that I can project maybe later on. And then we have released the Indian soil loss maps. So these are, again, 250-meter scale maps at a national scale that looks at the soil loss maps and also all the components. So these are only possible because we have access to this kind of cloud computing. This is actually that national infra roads, railways, and buildings data set that we have released 3 weeks back. And you can, 9.13% of roads, 1.37% of railways, and 5% of buildings are vulnerable, highly vulnerable to landslides. And these are some ongoing works that we always do. But what we want to highlight is that all of it is possible. All of it has been done with open source GIS workflows only. This is a new observatory that we have launched. This is the Amrit Sarovar observatory, where you can see the combination of GIS with machine learning. So one of the problems is, Ministry of Rural Development faces is they build these NREGA ponds around the country, thousands of them, and there is no way to monitor them at scale. And the satellite freely available data sets, they don't work well with small ponds. The ponds, if they're less than 1 hectare or less than 2 hectare, they cannot be captured by free satellites. So we have developed a new machine learning algorithm that only works for small satellites because we have trained it on small ponds across the country. And we deployed the tool. Now it is available on amritsarovar.iitd.ac.in. Feel free to play with it. And if you find any issues, please let me know. And we have the developers with us in the audience, so we'll bug them. But we just want to highlight that these are only possible because of the open source availability of data sets. Now, this one is gone. So I just want to, interest of time, I'll put a few questions maybe for discussion. One discussion is that we can have is what kind of new workflows, like how do we actually standardize workflows? So whenever we say that, let us produce a flood map, there is no standardized way to produce a flood map. NRSC will do it in some way, we will do it in another way. Other agencies and students will also do it in some other ways. So how do we actually share our workflows? Right now we are sharing our data sets. We are sharing even software, but we rarely are sharing our workflows. So there are ways of sharing the workflows, and this is something that I think the community needs to embrace and going forward, and I think we can have a discussion on that. And secondly, how can we retrofit our existing databases for an ML native future? So increasingly we have this terabytes and petabytes of government data, but in reality, very little of it is actually used in machine learning at all. And that is because the data sets itself are not really compatible with machine learning. So what are the kind of retrofitting that we would have to do in terms of going back in time and fixing these data sets and making them compatible for machine learning going forward? So these are the 2 questions I put forward for discussion to the audience as well as the discussions. So with that, thank you so much, and I'm looking forward to it.
Thank you, Dr. Saria. That was excellent. So from Dr. Durga Rao and yourself, these are 2-3 very interesting issues that have come up. The word retrofit was taught to me by earthquake specialists, and I assumed it was only for buildings. Now you've told us that we need to retrofit all our existing databases, GIS, and put them on the workflow processes, which includes cloud and ML. So there are too many words which I'll have to absorb. It will take me some time. But for all you specialists, let's go to the private sector first. I would like to ask Sri Krishna Lodha, and I believe none of the startup guys are doctors. They are all Shris or Ms. MSs. So the question to you is that what is the kind of takeaway you have from open source data? Like Dr. Saria mentioned, at the moment it's a paid access, then you lose it when your funding goes.
Yeah.
So what is your experience?
Yeah, thank you. So what I have experienced with open source is, when I go to conferences, I see that there are pro open source, and then there are opposite side of this spectrum as well, who will put the same things that we talk about, that you're not bound by, let's say, a single provider, and you're not paying any fees or something like that. We say that as a pro, but then there will be people who will say it as a con, saying that okay, if there is no vendor who will be guaranteeing this, then let's say after 3 years, if the people who developed it are no longer there, who will maintain it? But I think that's where the opportunities for startups like us jumps in, because we have been open source agnostic from day one, and for a lot of our clients, it was a tough decision for them to take, because when it comes to geospatial data, privacy is the major thing, and their first question is always that how do you maintain the privacy of other I would like to call it as a paid tools, who make sure that your data is always there, the software is always working. And I think that's where having more education on the open source technologies that exists during the during your learning years makes a big difference. As Saria sir said clearly, that formats like ZAR, stack APIs are nowadays being used and being called upon so much. But then there is still a lot of difference with a lot of, I would say, path that we have to reach, where we can actually put those in the production workflows or use it with much more confidence. We have been using ZAR, we have been using GeoParquet for a long time, but still it becomes difficult to convince. So I think somewhere we will have to work with people who will be interested into taking that risk of trying this out and be sure that it works. And it really works. We have seen that from very close. So
Okay, great. I'll come back to you at least 2 more times.
Please.
Yes, Mr. Verma, what is your reaction to what he said about the fact that when you go into businesses, there is an issue between privacy and open source? So how do you tackle that, especially given that there are always ways of being very secure on the cloud also?
Good afternoon, everybody. Yeah, I guess from MapIndia's perspective, we've spent 30 years servicing all sorts of enterprises, whether in the government or defense or in the private sector. And these are kind of mission critical applications, including, I guess, in the disaster area. We do leverage a lot of open source. But I think maybe the difference between us and a kind of pure play open source technology open source organization would be that we also bear the responsibility of delivering outcomes to the customers who are dependent on us for good governance, for disaster response or preparedness, etc. So we have to harden those open source technologies or open source data with the indigenously developed and flexible kind of from both a commercial and technical and openly compatible technologies and business models, both, so that at the end of the day we can deliver a solid outcome. Because in dogma or in philosophical things, if we get into, but a disaster happens and people die, I don't think that argument holds. At the same time, I also believe that we can't, as a country or population, be dependent on foreign, expensive and locked-in platforms, whether commercial or even in some cases supposed open source. I'm saying usually open source, I'm also a big proponent of. So, but definitely not a proponent of foreign, very expensive locked-in platforms, clearly. So I think the balance that MapIndia has tried to do with a full suite of digital transformation software as well as data that we have collected for 30 years. And for example, data that we partner with ISRO for. We're quite grateful that Bhuvan and RSC has partnered with us for the last 10 years, given us the opportunity to kind of co-integrate their platform and our platform. So, so I guess my response is, it's very important. This is the most serious topic that can happen, to be prepared and respond to disasters effectively to save population. We have to, as you rightly said, follow the open source plus hardening, which we kind of say commercial open source, but indigenously developed, flexible and open. And for those reasons, we don't tell our customers that, you know, you must use our system in our cloud, which is hosted in some place. We have flexible models of deployment. That means in-premise, secure within their location, or hybrid, or multi-cloud, etc., etc. So I don't know if that helps.
Yeah, that helps, but it confuses me a little bit more. So I shall go to the safe government side. Your Dr. Gupta, Mr. Doctor hona chahiye. So Dr. Gupta, how would you react? So the question here I am driving towards is, eventually we will discuss this retrofit part, for which we request Dr. Durga Rao to say something. But before that, if you can say, how do you react to the fact that the private sector, they pride themselves in the fact that they are quick, they are fast, and their services are better, whereas normally people say government services are slow, they may be very secure, they may be giving importance to privacy, but you know, they are slightly slower and not that efficient. So how would you react to that in your experience with the private sector and public sector?
Thank you. So it's a very interesting question. It's very difficult to answer to. Let's take, since we are at a platform where we stakeholders of disaster management are involved, let's take disaster management as a case study. You need quick responses, you need real-time inputs, and which is not the strong point of government bodies. So we take the best of both worlds, and the kind of reach government institutions have, because you cannot, I mean, it is opinion that for effective disaster management, you have to go down to the grassroots, to individuals from where they are building their houses to where they are living, and any infrastructure planning or any activity that they do has to be brought down to grassroots, to school level, to individuals, which can be best done by governments and the kind of reach government bodies have through different government schemes and all that. So I would suggest that we have to take a middle path where we take the quick response times, the active inputs from the private players, and the reach, the kind of depth expanse that government services have to individuals. Apart from that, I would just like to add that from the IIR's perspectives, we have a unit of ISRO which is more involved into research and capacity building in all the areas that we are discussing today. We have currently we are doing a very good, very big capacity building program for NDMA. But apart from that also, from starting from a flagship program of ISRO for school children called Yuvika, we are training school children at class 10 standard, school teachers, professors and universities through NNRMS programs, and then our regular masters and diploma degrees on all these aspects. And I would very happy to tell you that we are almost the most earliest adopters of open source. Way back in 2007, I remember we introduced open source in our curriculum, and everything that we do in almost all of our courses is based on open source software. And I have so many students who have passed out from IRS in this crowd, and they're all they gladly come up to say that, sir, because we were taught open source, that we could now thrive in our careers. And so yeah, we have to find a common ground where we take the best of both worlds. And
Thank you. So this training modules that you have, are they on an e-learning website or a YouTube or something?
Right. So we have both kinds of programs on campus where our trainees come there. And anyway, so if you are a government department who have a very specialized requirement, I don't want to learn everything about GIS and remote sensing. Just tell me how you could use remote sensing in a flood scenario. So we customize programs from 1 week, 2 weeks, depending on.
So you already have someone existing in the open source?
So let me come to the next one. That is our on-campus programs, and then we have our distance learning programs. So some of them are general, like 3-month certificate courses, when again we have 1 day, 5-day programs where are customized, and these are on our YouTube channel. There's an IARS distance learning program YouTube channel, which is quite popular, and they conduct regular courses on different disasters, and a lot of content is there. So if you could just Google it up,
great.
You will find relevant.
Dr. Kajal, please add this YouTube channel of IIRS in that list in our presentation before we put it out. That's important. Put it in the top. Okay.
Thank you so much.
Okay, Dr. Rao, to you now on the retrofit question. So you think all the large databases that you have, which are used for GIS, like the landslide and flood one that Dr. Chauhan mentioned, do you think there is a need to add or subtract or put them on the cloud? What's your reaction? You're looking very serious.
No, sir. See, nowadays, whatever, according to new geospatial policy, according to the policy, whatever geospatial database is available with NRSC, it can be shared to the users, it can be shared to the organizations, okay, and for a better use. That is one point, sir. And for updation, any data, okay, we have to update at periodic intervals. For example, we have developed flood hazard atlas, sir, okay, of 6 major states, okay, because those are most frequent flood prone states. So at least every 5 years you have to update it, okay, because nowadays the floods, the disasters are changing its shape, okay, its pattern also. So anything, even topography also, if I have LTM digital terrain model of Brahmaputra today, maybe after 5 years the digital terrain model topography also is changing because of the river migration, sedimentation, etc. Okay.
So is that
any database requires updation?
So is that possible on a slightly an automated fashion, that all the fresh data that keeps coming in gets into that whatever algorithm it is, and it keeps updating the output? Is that possible in an automated fashion?
Something can be done in automated fashion, sir, but something need to be semi-automated.
Okay, you'll need some manual
some manual
intervention.
interventions also.
Okay, so Mr. Lodha, what is your assessment in the private databases that you guys handle? So you started what, 15 years ago?
We are quite young. We are 6 years old.
They are 6 years old, which is great. So at 6 years, when you were at 1 year and now you're at the 6th year, so you must have some original databases. So have you done retrofitting?
Yeah, so essentially what I see from my experience is that when you use open source, it's an additional thing that you have to always consider, that the data is always secure, data is always available, and the uptime is as much as possible, which is certainly like something that client also has to agree to, and which is reasonable. In our case, what we have figured out is that when you use, when you go to cloud platforms, it's much more easier for us to kind of like build the entire pipeline of making sure that your databases are being replicated, they are being backed up every now and then at the same time this has to be done in such an automated way that you should not have to look at it again. You always know that there is a fixed timeline of taking this database backup, and certainly it depends upon the severity of the data or the importance of that data itself. So what we have figured out is that no one can ever say that whatever we have built is going to be 100% secured. It's not going to be hacked, neither it's going to be cracked by. But what best we can do is that accept that this is how the world works and try to find out whatever the best you can do. So yeah, for us, taking those steps initially, understanding the requirements, and then figuring out the plan of making sure that the data and the privacy is always going to be maintained is our step one whenever we start the process. So that's how our even the documentation starts. So the first step is always to secure the data, understand with the client, and let them know that you cannot have 100% guaranteed secured server ever. Like companies like Google, companies like Meta, they also will never say that, okay, whatever information that you have is like 100% secure. You always hear this, like, you know, leaks have been done, like millions and like, you know, 100K credit card data has been stolen. So nothing is secured, but the best you can do is like make sure that you have that contingency plan in place. So that's what our take has been.
Okay, that's very interesting. And given that you're a 6-year-old company, you must be making some profit. So there must be a CSR also.
Yeah.
So, I mean, what are you doing for the public good?
Oh, that's an interesting question. And I would like to start answer by clearing one thing from everyone's mind. And this is something that I have a hard time telling people, is that open source does not mean free at all. Because when you use open source, you're kind of like in a community where it is expected that you're using it and you're kind of making some kind of changes to it to make it better for your use case. And it is expected that you will give back of something like that to the community again. For example, I'm guessing everyone who is using open source knows the name GeoServer. But probably very few people will know that they were struggling a lot in past couple of months going from GeoServer version 2 to version 3, and they did a crowdsourcing funding raise of 500, like €500,000. It was such an amazing thing for me because I was now able to give it back to the community of the GeoServer. I know the contributors of GeoServer. I have hanged out with them a lot, and what I see is that these guys who have created these kind of things, they're like truly passionate about it and truly, you know, they want to make the difference. Wherever we can do, we do a programming kind of like a contribution. So we contribute to packages like PyGeo API, Django, Postgres, and then there are a lot of Postgres based extensions as well, which makes our life very easy. Because we have used it, we feel that it's our, you know, kind of like a responsibility to give back to the community. And it doesn't have to be programming. Like even if you have built something on top of some kind of open source tool, let's say a workflow that you build for, let's say, disaster management on QGIS, you can also open source that flow, and that flow will be used by many people and they will actually contribute back to it. So I think if you use open source, you can think about it in a direction that how can I give back to this tool for the time that is the tool has saved for me, for the cost that the tool have saved for me. Apart from that, I also do YouTube. So I started doing this because when I started learning programming, it was very hard to find content about open source geospatial. So I decided to do it. And we have been doing it quite well. I do it for the fun. Again, like it's back to the community. I write blogs, I make technical videos. And then on my personal capacity, I do trainings as well, like corporate trainings, again, GeoServer and things like that.
That's excellent. You're giving back a lot.
Yeah.
And in the longer run, if you could just open up some of your older GIS maps for use by common people.
Absolutely. So we are working on a product known as Vista Map, which is kind of like the tool that we are building for people who wants to use GIS, but they don't necessarily want to get into the hassle of, you know, managing these data sets and all. So the first thing that we are going to do is that we are going to give free kind of like signups and free accounts to all the universities and all the contributors who are creating data. So like last month, I was in Goa attending a meeting where a lot of like individuals are generating data sets across the Goa. And now they're struggling to find out the way that how they can share this data back to the community. So we essentially just onboarded them, gave them the free account so then they can put as much data as they want. In the same manner, there are a lot of international companies like Source Cooperative is one of them who are providing a free access. So if you are creating a data and if you are interested into opening it out to the world, you just reach out, they'll suggest, like they'll get your free account, you start putting the data. So what I'm trying to get at is that there are a lot of opportunities and there are a lot of platforms available. It's just that we'll have to take the step.
Excellent, excellent. So Mr. Verma, we have open source antagonist next to you, and you are an open source protagonist, and the government loves a fight between the private sector. So can you please fight a bit and add some fun to this discussion?
Yeah, and sir, you had asked this question on CSR. So I actually have a few slides on Andhra floods from last year. If you permit me, I'll show it.
So the thing is that we finished at 12:10.
Acha,
So what
theek
we'll
hai.
do is
Okay.
you say what you have to say.
Mm.
Then when we are going back for final comments to Dr. Rao,
Sure.
then you can quickly come up and show that.
Ha,
slide.
theek hai,
Ah.
sure. That would be great.
Yeah.
So, I mean, sir, like just to on this Andhra floods that happened, immediately, I mean, we were asked by government, and then immediately, I guess about 20-25 people got into action, and all the way from drone data capture to drone image processing, AI on video, the whole geospatial visualization of a 2D and 3D map of that affected area, to the flood analysis, to also providing all the disaster related authorities or the field officers and in the back office these mobile apps where they could also self-report, to even giving citizen alerts, citizens alerts. So because Mapple's app is used by 30 million people, and Mapple's maps go into about 10-20 million vehicles over the last few years built in. Plus our APIs are used by hundreds of organizations. So being able to percolate this information to citizens as to where the issues are, to get citizens to report back what issues. I mean, there were so many issues they were facing, of like cow rotting on the ground, you know, all of that was happening. So, I mean, this all happened as CSR. It was able to, one was able to leverage that, this entire platform that has been built over 30 years of data plus software. I mean, it's just my contention that it was too late to ask for it at that time.
Okay.
It should be in place as an infrastructure already. So that in case disaster happens, okay, we were able to solve some part of the problem.
Excellent.
So open source or not, we have to be prepared and we have to solve. I think the government has very strong will and is very digital transformation focused. I think leverage the power of public and private sector. I think we can be a phenomenal
Excellent
country.
one. So you could just quickly show your one or two slides. Dr. Rao, what I'd like to ask you is that so much has been done in the private sector, public sector, open source. Have you ever put all this together to benefit the ministries in some kind of a plan or program that NRSC does?
So this particularly the open source from MapMe India, okay, we buy point of interest data every year, okay. They update the point of interest data every quarterly on payment basis only. So that is integrated in NDM dashboard, okay. Other than that, open source data, we develop lot of database, particularly for the disaster management. The cost benefit analysis is something different from other activities. Like one example I will give. What is the cost benefit analysis of BrahMos missile? Okay. Nobody can answer it.
They can only laugh.
Okay.
Smile.
Once it is used, then only will have benefit. So disaster management also, the benefit is very huge, okay. But the private organizations, those who are entering into that, they will see cost and benefit when they want to enter into this disaster management domain particularly. So we also tried our flood maps we are preparing, our people, scientists are involved in that. So we also tried to explore the possibility of involving private agencies in preparing the flood maps.
Okay.
So nobody has come forward because of the cost benefit analysis.
Okay, okay, interesting. Good point. Yes, yes, Mr. Verma, quickly, one or two slides. Huh?
So I mean, just I was just flipping through it. So, like for example, you're seeing this video footage from a drone with the flooding, and then overlaid on the 2D map with some flood analysis, and then here this was kind of before after interactive map also you're seeing, and the video footage also you're seeing. So you start seeing, and also as the drone is flying. So that gives somebody kind of this, in the battle, on the war room, you get a sense of what's happening and who's affected. And then this was kind of conjoining the high-res orthoimagery from drone, with all sorts of other data. Because of this 3D stuff, this 3D digital twin stuff that we would have, you could start seeing, which could be affected, which buildings could be affected. Similarly, these kind of dynamic virtual tours. And then like video AI, so like really seeing, so there are different classes of objects, whether rotting kind of dead animals or garbage dumps, things that post-flood cause problems, or like broken electric poles. And then this live CCTV footage.
Great.
So anyway,
Thank you. So for last words, Mr. Gupta, if you have any final words to summarize all this, then we'll go to Dr. Saharia for a final analysis, then we close.
Actually, you've asked a wide range of questions, but overall what I see is there's quite some scope in using open source for disaster management per se, and as one of our panelists did tell, that contribution can be in any form. It could be through teaching, it could be through development, it could be through simple using it. And we at IIRS, we've been developing quite many plugins and quite many tools and apps and dashboards using all these open technologies for both teaching and research purposes, as well as supporting disaster management bodies. Before I came here, I interacted with a lot of my other colleagues, and I came to know that we are supporting Uttarakhand State Disaster Management Agency in many things recently that they developed, and the forest fire alerts, and a very big program called GeoHIM, where the entire Himalayan region, which is prone to several such disasters, we are trying to provide technology-driven solutions which are completely based on OpenStack. So yes, but finally to deliver it, and then the apps, the web applications that are being developed are also using open source web development tools, Drupal and these stuff. So yeah, there is the idea behind open source, the concerns behind open source being raising privacy issues and all. These are valid to the certain extent that depends on how you deliver it to the user. If you open it on a non-authenticated platform, it will obviously cause issues. People will, India being such a big country, it will cause issues. But again, cost-benefit analysis of the advantages of open source vis-a-vis other such solutions is very big.
Yeah. Great. Thank you. So, 10 seconds, yes.
Yeah, thank you. So I just wanted to make an announcement. So people who are really interested into open source essentially. So there is this international conference which is known as FOSS4G, Free and Open Source Software for Geospatial, which happens on a global level. And I'm really fortunate that essentially I run one more community known as GeoBharat, which is again open platform for geospatial individuals. And we bid it and we won it for 2026. So FOSS4G FOSS4G Asia will be happening in January of 2026. I'm fortunate that it is happening in Nasik, which is my hometown. So people who are really interested into understanding where the world is with open source GIS, essentially what people are using, please feel free to visit us during conferences. You will see a lot of talks and workshops happening from people across the globe. So yeah, that's all. Thank you.
Yes, Dr. Saharia.
So I think just the I think I can use this. So wide range of things were discussed. I think the future definitely will be using more open source because I think that's just the way it is going in all software frameworks. And I think increasingly we will see software becoming much cheaper. I think in the past 2 years with AI, things have really changed how software is developed. So I think rather than having gigantic software that does everything under the sun, we are going to see more and more specialized software that does one or two things really, really well. So I think we are going to see some applications of that in very specific domains: disaster management, intelligence gathering, water resource management, all kinds of different fields. So, and of course, commercial players will always be there. They will, but I think open source applications are open source with service level agreements, as we call them, SLAs, where they will be mandated, where the partners will be mandated to provide 99.9% overtime, uptime, is something that we will see more and more happening in the geospatial world. I think from the academic side, we can say that there is a lot of emphasis from our side, at least, in teaching open source GIS in our classes. We always teach open source. I mean, I personally teach Python and of course geospatial related Python. Then there are other people who teach QGIS as one of the main platforms for running GIS related workflows. And going forward, I see a lot of potential in ML native workflows, where geospatial kind of becomes subsumed with machine learning, and they do not exist as like completely different areas, but they will kind of become one, where machine learning will kind of enter into every component, from dataset generation to model running to producing analysis reports, where Google just released the geospatial reasoning model 2 weeks, like a month back, right? So that is where I think you'll see within 6 months that this area is going to get really hot, with all the big companies also becoming big players in this. And geospatial reasoning, where ML based GIS is running the entire workflow, will be the mainstay in the next 10 years. That's what I foresee. Thanks.
Great. Thank you so much. Thank you for everybody for attending this panel. And Sushmita?
Yes.
Yeah.
My heartfelt thanks to Sir Safi Hassan Rizvi, sir, and our esteemed presenter and discussion for such an insightful discussion on open source GIS platform. Now, may I request Sri Safi Hassan Rizvi, sir, to kindly present the mementos to our presenter and the panelist, and join us for a group photo.
Going to be doctor. No pressure. Next time we call him.
Guys come to hire this.
Photograph. Sir, idhar aake photograph. Thank you.
Moving forward to our next technical session, exploring integrated emerging technologies, AI and drones with GIS for disaster management. If GIS is backbone for spatial analysis, AI and drones are the wings that takes it to the new heights. The session will unpack how these cutting-edge tools can enhance real-time decision-making and response during disaster. This session is moderated by Dr. KHP Durgarao, Group Director, DMSG NRSC. Our distinguished presenter and discussions include Sri Nile Nishan, Scientist D at NESEC, Dr. Rajesh Kumar Das, Project Scientist at CBRI, Sri Pradeep Pandurangi, Senior Product Manager at IdeaForge, Sri Satyavata Sataprati, CEO of Bonviero, and Dr. Arunima Chandra from Garuda UAV. A big welcome to our moderator and panelists as we kick off this meaningful session.
Good afternoon to everyone. Welcome to the technical session 2. It is an integrated emerging technologies, AI and drones, with GIS for disaster management. Okay. Nowadays, everybody talks about artificial intelligence, use of drones, use of smart sensors, deep learning, 3D printing, many things in disaster management. Okay. So maybe in future it will make our life easy in handling the disasters in the country. Okay. So now I request Shri Nilay Nishant, scientist, NESEC, to make a presentation on the, what is your title? Applications of emerging technologies in disaster.
Thank you, sir. So today I'll be, good afternoon everyone. Today I'll be delivering a talk on applications of emerging technologies in disaster management support for Northeast India. So I come from Northeastern Space Application Center. We look after the various activities related to space sector in the Northeastern region and also support for the disaster management support for the Northeastern region. So if we talk about the disaster scenario in the Northeastern region, it is prone to many disasters such as flood, thunderstorms, earthquake, landslides, forest fires, and many more. We keep getting them on a recurring basis. And if you give some statistics, around 39.5% of the entire region is flood prone, and which accounts to almost 9.4% of the entire country. If we see for the last 5 years, we have around 1,000 plus landslides which have occurred, and around 8% of the entire region is landslide prone. Thunderstorms, lightnings are also causing a major havoc in the place. And also, if we all know that Northeastern region lies in seismic zone 5, and we all experience frequent shocks of earthquakes also. Regarding forest fires, in the past 2 decades, we have had almost 6.9 lakh forest fire incidents, and around 4% of the land is around forest fires prone. So this is on the basics of basic statistics about the disaster related scenarios. To combat all these disasters, we definitely need some sort of an intervention of emerging technologies. Something like artificial intelligence, cloud native geospatial workflows, integrated with ground level information coming from IoT sensors and UAV informations. And we can also leverage information about some high scale mappings and digital twins. So taking all these things into account, Department of Space actually approved in the year 2012 the formation of Northeastern Regional Node for Disaster Risk Reduction. Here, there are many operational services that support the various state disaster management authorities of the region, and there are a few R&D initiatives that take place also. Few of the operational services include the flood early warning system that has been operationally being implemented in collaboration with Assam State Disaster Management Authority since 2012. For the past 2 years, this services has been extended to the state of Arunachal Pradesh, Meghalaya, and Tripura on an experimental basis. In addition to this, we also have some Northeastern Forest Fire Information System and UAV-based services. In case of R&D-based initiatives, we are doing an earthquake precursor studies and TEC-based precursor studies and lightning early warning systems. And need-based interventions as and when any disaster strikes has been implemented and carried out through this node. There's a dashboard called as nerdrr.gov.in, developed using fully open source tools and technologies, which leverages open data standards, and anyone can fetch the APIs from this dashboard and integrate into your services also. Now, coming on to the important component, that is the topic of today's GeoAI and its capabilities. So what is GeoAI? At the first outset, if you look at GeoAI, you'll feel like it is just geospatial data combined with artificial intelligence or machine learning. But there is also a third component to it. The third component basically looks into how to deploy it at a scalable level using machine learning, using cloud computing techniques. If you see the basic capabilities of the Geo AI. There are many, but I'm just highlighting a few here. The first one, as you can see, is something like an object detection, where you actually identify the object in the form of a simple box. Here it is just a simple road monitoring that has been done, deployed on a dash camera. And this type of learning is also called as a federated learning, where the learning is happening on the IoT sensor itself. Then the second one is called as the semantic segmentation, where we are actually able to delineate exact bounding box of the buildings. Then the third one here is basically the change detection techniques. So these are some of the basic examples that can be executed using Geo AI. Then how can it actually support any sort of a disaster management support activities? So we can go for something like a rapid damage assessment with AI-driven EO analytics. We can provide some value addition to any sort of a early warning system that is already existing. And we can take some long-term data and generate some sort of vulnerability maps and provide some sort of an optimized resource allocation plan using some AI models. Now, we have a fair share of operational models and some experimental models that have been developed. One of the operational models that has been developed is called as ACNet, and it is being utilized to generate land use, land cover information at an annual basis using open series of satellite images. So for the entire northeastern region, every year we are generating land use, land cover information. So any sort of disaster mitigation activity that you want to plan out, you need the latest land use, land cover information. And that is where you can identify this, and this is freely available in a portal called as Northeastern Spatial Data Repository, nesdr.gov.in. You can go there, register, and you can download these sort of data sets. Then the next component is something which is related to health sectors, and here we have partnered with ICMR, and we have generated a health disaster map, that is malaria risk map for the entire state of Tripura, where the health volunteers were actually going to the ground and collecting the incidents, malaria incidents. Around 15,000 locations have been ground locations have been collected and plotted. For the various parameters have been plotted, and they are mapped against various contributing factors for which could contribute to the malaria risk, and this has been generated for the entire state of Tripura. Then for the flood inundation mapping, we also implemented some AI techniques, and we were able to extract the AI model. And for the state of Tripura, in the month of August 2024, we experienced around 288 mm of rainfall. And after that, the whole Tripura was flooded, and this was the mapping that was done, and this was shared to the State Department. We also did some experiments on the newly available geospatial foundation models. Something like Prithvi EO2 is available, clay models are available. So we are using them, and we are trying to implement it for some landslide detection, and we are also getting some very encouraging results with reference to that. Now coming on to something which is more current on the line, which is like the generative AI, the days of ChatGPT and Gemini. Now what happens is many of these data sets, many of these models are trained on generic data, like they're trained on Reddit pages and generic pages. What happens if you want to leverage this power and point it to your database? This kind of a framework is called as a retrieval augmentation generation. Now this helps us generating agents. This is called as an agentic workflow. We can have two types of agents. In this case, we have implemented two agents. One is a query agent, another is called as a mapping agent. Query agent basically helps you query the geospatial data, and the mapping helps you display this data on the map. So there is this video I'd like to play. Can you just play it? Just go, yeah. So this is a quick video. It shows you the workflow of how you are actually querying, just asking how many health facilities are there in Assam, and it automatically plots all the health facilities there in Assam. And then followed by that, we can also ask probably show me health facilities in Jorhat district. So it is actually using GeoAI queries and actually plotting those information on the map. So this is like another thing is we also had the alert level information. So we are also able to see how many alerts are there in the entire state of Assam, so 18 alerts. And it also has some sort of a reasoning capability. So if you ask him, is it safe to travel to Jorhat right now, or any particular district of Assam, if there's an alert there, it gives you a relevant answer telling that probably there's an alert, there's not a right time to go. Next is a very important technology, that is UAVs, because northeastern region is covered most of the time with clouds. And because of the difficult terrain, the interpretability of microwave data also becomes a little bit of a challenging task. That is where the UAV intervention comes into picture, wherein we do have a certain number of drones which are available. And one very interesting thing is we also have a VTOL, that is a vertical takeoff landing. Because in a hilly terrain, you don't have a good runway for a high endurance flight. For a high endurance flight, you need something like a fixed wing kind of a system. So this system can actually take off vertically, then the propellers move forward, and then you can have a proper horizontal propeller, and then you can do a horizontal flight, and then further you can land vertically. It is something like a Sea Harrier, what we see on the Navy ships. With the UAV data set, we get different kinds of products. Some of the important products that we get is like the 3D point clouds, DSM, and orthophotos at a very high resolution. So these are some of the exercises.
One more minute.
Sure. Some of the exercises that have been carried out. This is like a Silchar embankment breach that was happened in June 2022, and this is a very popular Dima Hasao Harangjao railway line. Northeast Frontier Railway had requested us to map the entire disaster that has happened here, and we can see here around 112 landslides were identified, and totally 17 debris flows were mapped using UAVs. And you can see how the embankment breach in the Silchar region had actually flooded the whole region. So this is a small video where you could actually right, no, right, play this. So there is a small fly-through of the entire region that we had mapped, and we have provided this information to the Northeast Frontier Railway. There's a 50-kilometer stretch mapped within 5 days, and this is what we had actually completed. This is a complement to what has been actually discussed in the previous session. This is like my second last slide. So here in what we are doing is we are actually leveraging those cloud native geospatial workflows and trying to leverage the WMS stylings, the actual protocols of WMS, and trying to implement in a WebGIS framework. Now again, as discussed in the previous session, the challenge lies not in implementation of standard operations like band math operations, but on the more complex, more advanced machine learning operations like CNNs and vision transformers. So these are some of the case studies of that. And I think I'll stop here. These are some of the trainings that we do. All trainings are done in open source, taking into account open source technologies and tools. And since we are talking about resources, I also have uploaded a basic set of tutorials if anyone wants to get into ML or DL into my GitHub page. So I'll be happy to probably share it with the organizers so that every one of you can use it. Thank you.
Thank you very much, Mr. Nishant, for an excellent presentation on applications of drones and AI in disaster management, particularly in the northeastern region. Now the next presentation will be on will be by Dr. Rajesh Kumar from CBRA.
Okay, good afternoon. This is Dr. Rajesh Kumar Das from CSR CBRA Roorkee, and I will be talking on one tool, that is UAV for one disaster, landslide. And the topic of my presentation will be integrating drones with GIS for landslide disaster mitigation. Yes, GIS is a tool, and it is basically used for capturing, storing, managing, analyzing, and most importantly visualizing spatial data. And there are many stages and phases of a disaster, mostly pre-disaster, during disasters, and post-disaster phase. This tool can be utilized in pre-disaster and post-disasters, but the utilization of drone during the disaster, that is during the landslide, is often limited because the prediction of timing and location is often uncertain. So the very fundamental use of drones in landslide studies is preparation of a landslide susceptibility zonation map, for which we need to have identified the factors which are responsible for occurrences of landslides. We prepare thematic layers. We prepare landslide inventories. Nowadays it is available Bhukos and Bhunidhi portals. And also these landslide susceptibility maps are nowadays available in NRSC and GSI portals. So coming to the application of drones, yes, it has already been a century ago the drones was discovered and utilized in military purposes, but in last 2 decades it has been utilized in disaster management. And there are many types of drones depending upon the weight, depending upon the rotors. We can have different types of drones, and we have one quadcopter drone at CSR CBRI, and we are using it for landslide studies. Yes, GIS is a tool and drone is a platform for capturing data. We need sensors and cameras. We have different cameras. We use RGB cameras for orthophotos. We utilize multispectral cameras for preparation of NDVI and NDWI maps. We employ drones for monitoring landslides. We fly drones repetitively for different time periods, and we analyze the data using GIS platform, and we get the movement. Mostly by dem of difference, we get the vertical movements. This is the orthophoto of Joshimath, where we have deployed drone for mapping of cracks and represented on the GIS. Let's have an example of application of drone in post-disaster phase. Yes, it can effectively use for response and recovery, but I am talking from research point of view, and I will be talking on back analysis and event reconstruction. We have drone studies. I received this drone imagery from NDMA PDNA team. Then we did the pre-event and post-event analysis. We have elevation maps. We prepared slope maps. We studied detailed profile of the debris flow. We have the release zones. We have different damming locations. We have entrainment zones. And then suitably, we used one Swiss tool, RAMS, for modeling this debris flow. This debris flow gives an information on the debris flow mechanism and dynamics. And also this similar approach can be utilized for futuristic predictions. We can have new release areas mapped by drones. We can use GIS. We can use RAMS to model the debris flows. Similar way, we can have also this same approach can be utilized for other mass movement processes like rock falls, rock ice avalanches, and snow avalanches. Here few examples of the simulation studies. The arrow mark indicates the flow direction from top to bottom. It reaches the Chalier River. Coming to the conclusion in a brief way, GIS can be utilized effectively with drone, but it should be ground validated if possible, and it needs human intervention. And also its accuracy depends upon the expert interpretations. Yes, implementation and integration of emerging tools, technologies can be utilized for hazard prediction and planning of mitigation. Yes, at last I can say GIS is not the destination, but it begins the journey. Thank you.
So thank you very much, Dr. Rajesh, for your nice presentation on drone applications in specific, mainly in hilly terrains. So before going for panel discussions, so I would like to invite some questions from the audience also. If somebody has some questions, specific questions.
Sir, regarding drones, when we are doing a drone survey, what are the legal obstructions we can face? Like where we can fly, what is the elevation, what are the licenses needed for that?
Yes, the very first thing is to fly a drone, you need a remote pilot license. if you belong to a research organization, you don't need it. Apart from that, the maximum flying height for a drone in Indian subcontinent is 120 meter. It is quite difficult because there is an elevation difference of almost 300-400 meter in landslide in the steep terrains of Himalayas, but we have to follow the rules. Apart from that, we are facing a lot many problems regarding vegetations where the trees are 30-40 meters long. So we have to fly the drone just like 80, 90, 100 meters. Second, we need a crystal clear weather. If the weather is somewhat below average, we cannot fly the drone, even it will not start. Apart from that, we have many restrictions. We have red zones, we have yellow zones, we have green zones. We cannot fly the drones in the red zones near the airports, near the army base camps. We cannot fly at an elevation 120 meter in the yellow zones. So there are very limited space available for drones. And the recent problem is in the hilly terrains, you cannot get a good space for your base station. So you have to start your flying from the road. And once it is Chardham Yatra or something kind that, then you don't get a space for landing and takeoff of your drone. Apart from that, from international boundary, 25 kilometer buffer, you cannot fly your drone for security reason. So if you go to Pithoragarh after Dharchula, you cannot fly your drone. If you go Gangotri, you cannot fly your drone. So many of the places you cannot fly your drones. So these are all the limitations of drones. But yes, there are many advantages. The first one is the very high resolution image. We can get 1 centimeter resolution. We can use it for interpretation, we can use for secondary purposes, and you can use for anything else. Thank you.
Sir, I have a question.
Sir, one, I'd like to compliment, sir.
Yes.
Whatever sir has stated, it is all available in digitalsky.dgca.gov.in.
Yes.
So all the zones, everything are made
Drone rules 2021,
yeah.
it is.
You mentioned about accuracy, right? Accuracy, there are problems in accuracy then.
Hello.
Yeah. So you mentioned about accuracies. No? What are the factors which affects your accuracy of them, especially for this this drone?
Generated by drone.
Drone. Because you are generating, you told 1 centimeter you are able to generate, right?
Yes.
That is the resolution you told.
Yes.
So accuracy, what are the factors which affects?
It depends upon the camera. First, second, we fly at a very low height because 100 meter, 120 meter is not a very big height. It is strongly dependent upon the camera quality, and often we get 1 centimeter, 2 centimeter dams. And I also check the sensitivities of the flying height with the resolution, but there is not a big difference. I fly it from 40, 50, 60, but there is a difference of just 1 or 2 centimeter from 50 to 100 meters. So there is not much, but the weather must be good, should be clearly interpretable, and if there is no obstruction like vegetation or some clouds, then we get a very good quality of dance.
Thank you. Thank you, Dr. Rao.
Just add to that accuracy question, drones that have PPK technology,
Yes.
they generally give survey grade accuracy.
Yes.
Which is 10 centimeter in XY.
Yes.
And 20 centimeter in Z.
Yes.
Which is what Survey of India has put for all the projects that are happening.
Yes.
And of course now Survey of India is constantly expanding its course network, which
Yes.
is really helping us get accuracy in various places and having lesser control points, checkpoints.
Yes.
Right, so that's also a big boost to drone mapping as well.
Yes.
And finally, when there is vegetation, now there are LiDAR sensors available.
Yes.
So now actually, and later on probably I can show some slides of actually solving the mapping of hilly, mountainous, vegetated terrain.
Yes.
And getting the actual ground data, right, with the sensors that are available. So I think as we go ahead, we can discuss more about
Yes.
it. Thank you.
सर मेरा एक सवाल है इधर इस साइड दिस साइड
Yes, madam.
अभी कल नहीं सॉरी परसों बहुत तेज यहाँ पे थंडर स्टॉर्म आया था.
हाँ.
And after that there is a lot of damage. Tree uprooted and somewhere building collapsed. So just tell me whether that in that situation and the 2 days we were struggling to get the data. How many trees fall down, how many branches fall down, how many buildings fall down throughout the Delhi, entire Delhi, and whether they are removed or not, all those things. So my question is whether we have to, in that scenario, how we'll get the quick solution, whether we have to follow the satellite image or the drone solutions. So the two spanning 2 complete day is a good number of time, good amount of time, if there is any solution to get the quick answer for all these problems.
So you want to
What would you suggest?
You want to do the damage assessment? Yes, exactly. I have not worked in this domain, but my work is limited to application of drones in landslide. But I hope my panelists will help me.
In that point of time, I would suggest that after the disaster or after the hazard has occurred, then you can fly a drone if the weather is right or if the wind speed is according to the flyable condition. But during the hazard or during the condition that is going on, drone is not recommended.
At the same time, I cannot get the satellite image quickly.
Yeah,
and by the time the people of Delhi will suffer a lot. So I'm looking for a good solution if anybody can suggest.
Ma'am, you approach me for high resolution satellite image and we will deliver within time frame, ma'am. Not a problem.
So please contact me for that.
Okay, thank you very much.
So I have a question, sir.
So you have a question?
Sir.
Please.
Thank you, Dr. Rao. Actually, I wanted to ask a question to NISAC. Like you spoke about your Tripura experience.
Please switch on your mic.
Hello? Yeah. So, like you spoke about your last year's experience in Tripura, where you integrated AI and the flood modeling, and both for the probabilistic hazard assessment point of view, and then also for recovery point of view, for response point of view. So, I just wanted if you could explain it a little further, and also were you able to integrate AI into the fluid system, which you explained in your first slide, like for Assam and other parts?
Sir, your voice was not properly clear.
I don't know. I hope it's working. So I just wanted to ask, could you further explain about your experience in Tripura, where you explained about the flood, the integration of AI into the flood modeling, the last year of Tripura floods which you spoke. And secondly, were you able to integrate AI into the FLUIS model, which you showed in the first slide? Okay. FLUIS.
Okay. Regarding the first question, the whole process of flood modeling is a combination of getting data from Google Earth Engine, pre-processing it, implementing some ML models onto it, and doing some flood inundation modeling. So that has been automated using AI plus standard mapping techniques. That is with reference to the first question. Regarding the flood early warning system, currently it is not an AI-based system. It is a physical-based model system that basically works on HEC HMS model, and based on that we are delivering it to Assam State Disaster Management Authority.
Please. Last question.
Yeah, my
Last
question to Nishant. Do you have the built-up area coverage for the northeastern region with a good resolution? Is there any such kind of data available in your organization?
Sir, currently it is available at 1:10,000 scale.
Okay, what is the vintage of the data?
It is basically available for the last year also, like last 2024 will be available.
Do you have any specific state data fully available? No, within the northeastern region.
It is entire NER. Entire NER we have.
Okay, thank you.
So thank you very much. Now,
Sir, I have a question for you, sir.
For me?
Yes, sir. Yes, sir. Sir, actually, Director NRSC had suggested that you have developed all the flood maps and all the atlas and all, and also the fire, forest fire things and all. So, is that data, that the flood prone areas that you have built, is that available only in print form, in the image form, or is it available downloadable in a GIS format? That is my question, sir, to you.
so it is available in digital form also. In print form it is available. It is available in GIS form also. If anybody requires it, they can send a request. Okay. And please don't ask complete state like that. You give your area.
So, but I want to, because I need to do the speculative tasking, for the flood zone in, let's say, SAR or thing. I need a full state-wise data set just to, because, normally what happens is all the
You are from which organization?
Sir, I am from Micronet Solutions, sir. So we provide data to all the agencies, sir, all the government bodies and the semi-government bodies. So that's a challenge, sir, whenever people come and ask us that, okay, do you have SAR data over this area? But then there is no pre-data to do that. So we are contemplating.
See, as per the geospatial data sharing policies,
sir,
okay, we can share it.
Okay, thank you, sir.
If you are eligible. Okay.
Thank you, sir. Thank you so much.
So now I think questions from audience are over. Three of the panelists, they are mostly specialized in drones particularly. Okay. Now I have one question to Mr. Pradeep. Okay. When there is a flood, okay, we get the satellite data. Once satellite data is available, we have to give the process it, prepare a flood map, do the damage assessment, and disseminate to the state and central DMS organizations within 3 hours turnaround time. Okay. So in case of drone, so how much time it will take, okay, to do this type of exercise, and what are the limitations also? Can you please explain?
Thank you, sir, for the question. So with drones, as already mentioned by the presenters, the data is high resolution. That means the data is also heavy, and there is a lot of post-processing time as well. And one of the key messages that actually I wanted to give in this forum as well is that a lot of work with drones should actually happen on the prevention side of things, right? So obviously satellites are great for covering large areas and identifying the high-risk locations. Once those high-risk locations are identified, we should have already, before even a disaster happens, we should be mapping those areas. For example, cities now. All of our cities are facing flooding issues, right? So at that planning stage and the prevention stage is where drones can help. So there, the turnaround time for these high-resolution models will not be a concern. When the disaster has already occurred, what we can do is we can use drones for video-based solutions where there is no turnaround time required. You just take the data. You have good network. You'll be able to send it to the cloud and do analytics and geotag, what we call geotagged videos. Right? Once you have geotagged videos, it was shown also in the previous session, how we can use that once the disaster has happened. But I think there should be a larger program. Like for example, SOI has done a program for village mapping. Now there is a Department of Land Records is doing a program called Naksha, 3D mapping of all cities, right? Can that data be shared and used across agencies to do all of these analytics, to go to the details of, okay, this area is susceptible, what should be the preventive measures over here? I think that is really the key. And once the disaster has happened, okay, of course, if the model is readily available, you can plan escape routes, or you can plan all the mitigation steps, right? So high resolution mapping data from drones is actually much more effective and should be used on the preventive side of things. And I think there should be a national level scheme or something that takes this into account. Similarly, what's being done by Department of Land Records, Panchayati Raj, and I think there are learnings there where drone-based mapping has already proven that can be done at scale. And I think today the ecosystem exists, both on the number of type certified drones, the number of GIS companies that have experience with this already. It's a question of finding the right problem solution fit and making the right scheme available at a national scale. So that would be my submission.
Thank you. Now my next question to the Madam Arunima. Generally, when we, in case of disasters, we get satellite data. Okay, if non-availability of satellite data, if disaster is very big, like tsunami type. Okay, we have aircrafts, we fly and get the high resolution data, and the flying height is decided. It should be stable for platform, and the data can be mapped. Okay, so this drone data, when we fly, when we acquire the drone information, how the platform is stable. Okay, I'm not interested in the seeing the images. Okay, I'm interested in the damage assessment, how much area is affected. Okay, in each district or in each, if it is city, in each ward. Okay, how best drone can be used in such cases?
Sir, as previously discussed, that drone flies in a particular wind speed. Like for example, if you are in a tsunami hit area, so until and unless wind speed is stabilized, we cannot fly small drones or VTOL or anything like that. So for that area also, we do have a solution, that is the helicopter based data collection of how much area is destroyed or how much area has been affected. So we generally fly it at a level of more than 800 meters to 1000 meters, and then we can capture the data, because helicopter is quite stable in a windy area also.
Okay, thank you, madam.
Just I wanted to clarify that recently we have a lot of drone attacks and we neutralize those things. So whatever you have said, it is not implemented there.
That is a different perspective, and this is a completely different perspective.
I think the drone is a very speedily growing things, and we cannot say this we can do and this we cannot do. We have to.
So I think so my panelists will help out in that.
Yeah, I'll help out. So ma'am, that is a security question. The Ministry of Home Affairs is fully aware of that. There is a drone policy of Government of India in which the security side and the civilian side are discussing it. So I don't think that's a relevant point to discuss here. So maybe we can carry on with the civilian side of the work.
Yes. So let us focus on disaster applications mainly. Okay. So, there are many questions on drones only. My next question to Mr. Satya. Do you have any experience in mapping avalanches using drones? Okay.
Yeah.
So there a lot of scope of drones, particularly many times we difficult to map using satellite data. Avalanches means everything is white.
Right.
Okay. So can you throw some light on that?
Sure. We actually specialize at Bonviero. We specialize in manufacturing heavy lift drones, and these drones are capable of carrying up to like 50 kilos of payload. And most of these drones today are operational in the J&K and Ladakh like region. So that means these are capable of like flying in very high altitudes up to 18,000 feet. So capability per se, this definitely like exists. And now looking at drones, drones have got also, it is a very exponentially like evolving space. Okay. And we have experience of using ground penetrating radars, and in high altitude avalanche conditions we have done like experiments where we have identified people buried inside. There are carcass buried and then people buried, and there are also water like pathways coming in, and these requires really like a heavy payload. Essentially a GPR would like a radar would weigh somewhere around like 5 kilos all the way up to like 30-40 kilos, and we have experiences doing that. I would say that it definitely takes time, and it also requires a lot of accuracy, as you need to fly very closer to the avalanche area. You need to fly within like maybe 3 or 4 meters, so you need constant like LiDAR access when you are doing this operation. Thanks.
Thank you. So my next question is to Dr. Rajesh. It is mostly on AI techniques. Okay, you have worked in AI, particularly landslide related studies. My question, why I am asking, we have International Charter on Space and Major Disasters. Okay, 17 space agencies are there in the charter. So for all the space agencies, one challenging task is to identify the buildings damaged due to a landslide or flood. Okay, means we have to extract the building footprints using space data. There are, so can you please explain what are the limitations and what is the possibility also? Because now they have thrown a challenge to the world. They have announced AI-based challenge to identify the building footprints affected in the landslides or floods. Okay, to develop algorithms using multi-resolution satellite data, both optical and SAR data, and whoever wins that challenge, and they will be given award in Paris in October this year, in 25th Silver Jubilee celebrations of the International Charter. There is the AI-based challenge. The subject is AI for Earth observation. Okay. Now my question is, what is the scope of AI and what are the limitations, considering the shadows and corner reflectance, everything?
Well, for damage assessment, if the buildings are completely collapsed, it is very easy to identify comparing the pre and post scenarios. But most of the time we have vertical imageries, we don't have oblique imageries. If also we have oblique imageries by drones, it is very difficult to quantify the cracks or quantify the damages due to landslide or floods to the buildings. We do not have a particular degree of damage which can be recognized by drones manually. So yes, CSR CBRI has recently developed one artificial intelligence based damage assessment of buildings, mostly the cracks, but I think it needs some more time to develop a robust technique which can automatically detect the damages and quantify them. But from my experience, I can say it is not fully developed as per now, and it needs some more time.
Thank you. So, Mr. Nilay, you want to add something to this?
Yeah. Sir, one thing I'd like to add is when we throw these challenges, there are many data sets also that are made publicly available with these challenges, and those are called as benchmark data sets. If you look at those benchmark data sets, there are very few samples for Indian context with reference to Indian sensors also. So probably there can be an exercise where a community-driven exercise where such kind of labeled data sets can also be given out in public domain, wherein such sort of benchmark data set can be expanded, and indigenously developed models can also prosper and receive state-of-the-art results.
No, mainly what are the challenges in identifying? For example, recently in Vijayawada floods. So we were asked to do the number of buildings affected in the Vijayawada floods, Bodameru River flooding. Okay. So there is a scope in AI, I believe, but in the short period, see, we have to give input in hours only. So developing AI algorithm and implementing it, it is not practically possible in the real time. So we have done manual analysis, okay. We have provided some input, but later we did some AI work also, but that is also has not given full satisfaction to us. So what is your idea on that?
Then what next can be done is something related to geospatial aided AI operations also. So we also have to identify the actual science behind what is actually the signatures that are actually affecting in actually causing these damage not getting detected by these models. And then we have to implement some statistical models and actually augment the AI models with them. So that is probably one of the approaches that can be taken.
Thank you.
Sir, I have a...
Sir,
Yeah.
please.
So, I think Dr. Arunima mentioned about Ministry of Panchayat Raj, or was it Mr. Pradeep? Yeah. So, I just wanted to ask that this Ministry of Panchayat Raj has, they say, 3 centimeter resolution drone data. So, what is, how was it mapped and where is it available?
That's available with Survey of India. That's the nodal agency coordinating all of this.
So, all of India is mapped?
For
I'd like to answer that.
Yeah, please.
Yeah. So, okay. So the Naksha project is currently, it's an ongoing process. So most of the cities have been mapped, most of the units have been mapped, but the data has been now is in the in the ongoing process of processing it, and then delivering to the SOI, and then they will be uploading it.
Okay, so this is
So
a
it is in
national
the
project
process,
of the
yeah.
Survey of India,
Yeah.
in which all drone data is being uploaded in the Naksha project.
Yes. Similar project is there for DILRIMP, that is DILRMP. So that is for the land revenue, and the states have been given mandates that you need to map all the land records and digitalize it, so that further the process can be done. All the things will be done in a digital format only.
Excellent. You want to add something?
Yeah, so Naksha is the 3D mapping project.
Yeah.
The Suamitwa project, which was village mapping, is almost complete, and that data is already with SOI. I think 3.5 lakh villages have been mapped, but this is only the Abadi area of the villages.
Okay.
So that was done, that is the Suamitwa program. Each state has its own large-scale mapping program being done by various land revenue department of each individual states. That is being done by the states with support from SOI. And what Arunima was, what you're talking about is the
Land
Naksha
and
program.
revenue.
Yes.
Yeah, Naksha project has 2 phases, that is the 2D modeling and the 3D modeling. So 3D modeling in some districts are being done, and in 2D modeling some districts are being done.
Great.
So both of them are not being done in one district.
Thanks.
Is it available to open?
Currently not available in open. Naksha is not available in open. It is, as I said, the project is ongoing. So until and unless it's complete, you'll not be getting it.
Even if it is complete, what is the mode of operant? Like say for example, spatial data policy, less than 1 meter is not allowed for the public. So is it that data is available?
I think so. There
Can
will
you
be
please
some
introduce yourself before asking?
Okay, sir. Sorry. Myself, Muruganathan from NCSM Chennai. So we need, since some of the project we need a less than 1 meter resolution data. But when we approach, that is not, we are not allowed to use it.
Okay, so there are 2 aspects of the question that can be answered. One is Naksha has a different kind of licensing or different kind of permissions when you take the data from SOI. So that is there, but if you require the 1 meter, below 1 meter data, I think so it's better that you go in a other format to obtain it through regular permissions and other private partnerships. That can give you the data instantly.
Okay. Thank you.
So thank you, madam. Now one more question on AI only. Okay. Artificial intelligence, it is mostly data driven. Am I correct? Is it otherwise something different? Okay. Coming to the early warning, disaster early warning studies. Okay. So whereas it has 4th dimension called time, X, Y, Z and time T. Okay. How AI can be used in early warning studies like flood forecasting? Is there any scope of AI in flood forecasting? Okay, because flood forecasting cannot be data driven. Okay. Today there may be some event, next event will be entirely different. Okay. I have some doubts on AI. I will give one more my experience also. 2 years back, when ChatGPT came, my daughter was teaching me ChatGPT, okay, and when I typed my name KHV Durgarao in Google, I got so many links, with publications or some reports, some meetings, etc. When I typed KHV Durgarao in ChatGPT, it has generated some 50 words that KHV Durgarao is well-known dancer and he got Padma Vibhushan award. My daughter asked, when you became dancer, when you got award? Okay, because it is a data-driven model. So it has no data, that's why it could not give output. That is my conclusion from that. Similarly, flood forecasting, you can type your name also in ChatGPT. You will see the different results. Okay. And coming to the flood forecasting, it is not a data-driven model. Okay, or landslide early warning also. Time is the parameter. So how AI can give the solution for that? Anybody, any panelist or anybody from the audience can answer this. This is my question.
Sir, this is Nikhilesh. Here.
Please, Nikhilesh, please.
So we have been doing AI-based flood early warning system almost now 5 years, sir. Okay. So I think you are differentiating between Gen AI and AI. I just want to differentiate. So deep neural network with LSTM and conv-LSTM is perfectly working, where we have been able to achieve more than 90% I would say success rate, sometimes better than the simulations model. And we had trained over the last 50 plus years of rain, observed, and we have created a semi conv-LSTM and I would say data-driven side, physics-driven side model. And Godavari we are doing for Kaleshwaram and other areas of interest. And what we have seen is, sir, if you have long horizon data sets historic, which basically captures, like you said, the next flood could be based on a different event-driven parameters versus what was last time. So how, if you're able to capture these different variations of events, and the long horizon data sets do have spread of these events, your model would be able to do a better forecast. However, Gen AI side, sir, I think Gen AI is not yet in that format where geointelligence, physics is inbuilt into it. So it will do a lot of hallucinations and a lot of wrong, I would say, outputs.
Thank you, Nikhilesh. I know that Vassal Labs are doing a lot of works in hydrological modeling, flood forecasting. So whatever you're saying that you have developed these algorithms, standalone algorithms, or you have integrated with your hex softwares?
We have done hybrid, sir, both.
Okay.
So hydrologic responses are also fed into the conv-LSTM models, along with direct parameters like rain. So it's a fused model, physics plus conv-LSTM.
So definitely I will visit your office in Hyderabad. Thank you very much. Okay. So,
can I intervene?
Please.
Pierre from Switzerland. Just, I just come out last week out of a study that was done in Europe by one of our university, and Churcher have trained generative AI on floods on the data, because in Europe we have the chance to have 160 years of historical data for floods and rainfall, and they have applied these models that was generated in Latin America, in the Andes, Himalaya. And the results were quite interesting because it demonstrated that this generative AI trained on elements and information from one side of the planet and apply on the other side had an increased success rate in predicting floods of 25%. So that's really a nice and interesting approach, especially when we look at the challenge you have in the Himalaya region, when you are facing a significant shortage in historical data, that to be able to, instead starting from scratch with model that will be generated on this short amount of data, to use model that are trained on other area in the world. That's interesting. I'm happy to share this information after the conference.
Thank you very much. Thank you. So I have gone through some research papers on AI applications in hydrological modeling and flood forecasting. But though all those case studies are implemented in small areas, small catchments. Okay. So we are looking for that type of applications in big rivers like Godavari river system or Krishna river system, Brahmaputra river system, that type of things. Okay. If somebody can help in future, we will approach them. Thank you. Oh, thank you very much. Madam.
Just to introduce myself, I am Saroj Chanduri and I retired from NTP. I am Saroj Chanduri and I've retired from NTPC. So I was, for some time I was with Garuda UAV with Dr. Arunima. We were in the same organization. That time, NTPC had, NTPC and other hydro stations. We had an accident, I think, if you remember, February 2021. There was a deluge, I think. Deluge was there. So we visited.
Tapovan project you are taking?
Tapovan project was, I think, if you remember, it was yeah. So I was there, we had witnessed, what all happened on that Sunday. So me, along with Arunima, we had gone to NTPC. And I think, Arunima, if you remember, we had, we had just tried to create that use case for, early warning. So can you just, Yeah, that was an experimental one because NTPC already had a sensor installed over there for early warning system. But the lag time for deploying, for notification was just 5 minutes. So that wasn't helping them. So that's why they insisted that if satellites and drone merge together, the data, together could enhance the timeline for rescue missions. So that's when we, we suggested that, or we discussed actually that if SAR data could be utilized for early monitoring of the whole glacier, and then we can do that. So that was just an experimental one, wasn't in the papers like that.
So, madam, this Tapovan project, since you raised this issue, it is very important. This is one of the extreme disasters happened in India in recent years. Rishiganga, there was a massive flash flood in Rishiganga River in February 21. Almost I don't know how many people were killed in Tapovan hydropower project. Okay. Nobody was aware what happened. No cloud burst, nothing. Okay. Suddenly, big flash flood came. Many people got stuck in the project and died. The reason we explored with, when immediately we activated international charter, we got very high resolution satellite data, very high frequency data sets also we got it. Okay. Then we realized that there was some landslide, not landslide, it is a rock slide. From very interior place of that Rishiganga river, very massive rock slide, the rock detached from the hill that is equivalent to almost 40 football stadium size. Okay. That much rock got detached from the hill, fallen from the height of around 1800 meters. Okay. So when that kinetic energy fallen on the ground, it has created immense heat energy. Okay. The glaciated material and snow below that got melted. Okay. And it has created a flash flood to the downstream side. We created complete scenario post-event, but we could not do it before. What happened in that simulation modeling, everything we did it. And when we mapped that flow in the river using high resolution data obtained from international charter, complete event completed in 22 minutes. Rock fall to the dam inundation, 22 minutes. So no early warning system can give. Okay. Nobody expects that will fall. Okay. And create a such type of disaster. No sensor systems will work. No models will work within that short notice. Okay. And same thing happened in South Lonic Lake also in 23. So Riju Sab knows we worked together. So we morning itself 5:36 I received call from NDMA. So suddenly we got up and luckily we had 6 o'clock image. We noticed that something happened in Rishiganga Lake, sorry, South Lonic Lake, and there is nothing to correlate also. There was no cloud burst, no flooding, nothing. What happened also nobody knows, but something happened to the lake. Half of the lake got filled. Okay. Then realized that massive landslide in the lake. Okay. That created water surge in the lake and created flash flood, and many people died. That itself took 2 hours or something lead period to inundate the downstream project. Same, complete dam got washed up. Okay. So these two are the major disasters, extreme of extreme disasters we call it as, happened in India in recent years. Okay. Where, one question, if anybody is working on smart sensors, okay, Raju Sahab, I think, sir, because NDMA is working on that, installing sensors, particularly in such type of lakes, okay. If anybody working on smart sensors, whether it is useful to give alerts, such type of events, can please address this. Okay, thank you very much. So if something has some ideas, they can share during break also.
I
Okay.
want to take 1 minute. Just now we discussed about the Chamoli rock ice avalanches. It occurred in 7th February. It has 3 distinct phases. It disintegrated from Ronti Peak, 27 million meter cube of material detached. Then it joined Rishiganga Valley. It got converted to debris flow. Then at Josimath, it got converted to debris flow. Yes, I am working in that project with Switzerland, and our sponsors are here from SDC. Again, as sir told, what can we do? Now we have done the detailed event reconstruction and back analysis of the Chamoli rock ice avalanches. Subsequently, our Swiss team developed one simulation tool, RAMS Rock Ice Extended. Now we have implemented the same model in Gangotri, and we have identified somewhat 20 to 30 unstable zones which can potentially failure in the future. Now we have selected 4 which may immediately failure in next few years. We are doing the potential simulation, and also in next few months we are going to submit the report with the potential hazards in the downstreams.
Just last one line I just want to say, as we are couple of drone OEMs present over here, so we welcome each of you to actually share some requirement with us. Now you know that we specialize in building heavy payload, and something that did not exist a couple of years back, and we are specialized in flying also low altitudes. So please reach out to us for any requirement. We definitely want to work together to actually fulfill through the requirement. When we have real requirement, we can work on a pilot study, and we can execute together. Thank you.
Thank you. So thank you very much to NDMA also for giving this opportunity to us. Thank you.
Thank you, sir, and our presenter and discussion for shedding light on the transformative potential of AI and drones. May I now request Dr. Durga Rao, sir, to give the mementos to our panelists and then join us for a group photograph.
Group photo.
Our third technical session before lunch dive into real-time GIS and early warning system for disaster risk reduction. In a world where every second count, real-time disaster and early warning system are our first line of defense against disaster. This session will explore how technology enable rapid response and information decision making to save lives and reduce losses. We are privileged to have this session moderated by Dr. D.S. Pai, Scientist G, MOES. Our esteemed presenter and discussion include Dr. A.K. Mitra, Scientist F, Head at IMD, Dr. Seema Joshi, Vice President at ISRI India, Ms. Samita R, CEO of Resilience AI, Sri Dhiraj Mehra, CEO of Micronet Solution Airbus, and Sri Joel Joy, Assistant Commander, ITBP. Let's give a warm welcome to our moderator and panelists as we embark on this critical discussion.
Dr. Seema Joshi. So, good afternoon to all of you. So, in fact, we are in a critical time of the day. We are in between lunch and this session. So, we will try to continue, complete on time. However, we have got a very excellent speakers during the session. So, please bear with us so that we can complete this on time. The subject of this session is real-time GIS and early warning system for disaster risk reduction. All of us know that the early warning system is a very important tool as an adaptive for extreme events, particularly in view of what we talk about climate change and global warming, etc. In the morning, you might have heard that many of our speakers said in recent years IMD forecast was in very good. So it's not surprise that we had almost all components of the early warning system got a lot of technical support.
Every natural disaster
in recent years
has a story.
Because of improvement in the observation, models, high power computing system, even dissemination of this to the, it's not enough that you make a good warning or good forecast. Ultimately, it should reach to the last mile user. So this would not have been possible without the support of all the technology and development in the space-based observation. I would like to tell you that 90% of the observation that is gone into the model is from the satellite in the model. So as the satellite observation and radar observations are improving, our model forecasts are also getting improved. So in this session, we have got two speakers and then two discussion. How I'm going to conduct this session is that we will 7 or 8 minutes first to speaker. Okay, Dr. A.K. Mitra from IMD, probably he will talk on early warning system, operational early warning system of IMD. And then Dr. Seema Joshi, Vice President ESRI India. She may be talking on mainly on real-time GIS, on that particularly for early warning. And then about 3 or 4 minutes, I will give each of the discussion for either you present or discussion. Okay, once that is completed, we will open it for a question from the audience. Okay. Okay, Dr. A.K. Mitra, so please be on time.
Yes, sir.
7 minutes. Okay.
Yeah, I'll go quickly.
Yeah. You can keep it here, and 1% come.
Namaskar, good afternoon. I'm A.K. Mitra from IMD. I'll quickly go through of what discussion we already had. I'll start with the... Yeah, okay. Which one is next? This one? So I'll go with the real-time GIS and early warning systems for disaster risk reductions. I'll start with the say of what our Dr. Chauhan Saab has mentioned, that data is very much important, and we have seen that IMD's forecast has been improved a lot in last couple of years, and particularly last 5 years we have reached to the stage where accuracy of our forecast has been improved in manifolds. I'll go with some vision and mission of IMD, that we all know that our observation is a very, very important part here. And for that observation, our weather hazards to go undetected and unpredicted, we make sure that. And then accurate warning against the reasonable lead time. That reasonable lead time is very much important when we are talking about the early warning system. And then finally is impact-based forecast. Last 4 or 5 years, IMD has introduced the impact-based forecast. With the impact-based forecast, there are a lot of other, you can say, the subroutines or the units that we have added into. One of them is a space-based observation for weather monitoring and forecasting. If you can see the number of observations, we have been augmented with the number of instruments from the ground. But from the satellite, monitoring of weather hazards, physical understanding, the development of climatology, hazard mapping, assimilation of NWP models, and as the moderator Dr. Pai Saab has already mentioned, that 90% of data is being from the space being assimilated into the model. But the improvement, if you can see, there is a large improvement we have noticed, from 25 to 30% in NWP model forecast by satellite observations. So how this thing had happened? Because IMD has prepared a systems that called the early warning system or seamless system. And if you can see, we have categorized in the 4 categories: nowcasting, extended range, short to medium range, and seasonal forecast. But here the conference, with the meeting which we are having now, we will be focusing more on nowcasting up to 6 hours for all types of severe weather and all district and stations. How this thing had happened? Because we have a suite of operational NWP and climate models, right from nowcasting from 12 hours to seasonal 4 to 7 months. And if you can see here, this is the entire integral approach. This integral approach shows that how observational, communication, analysis and forecasting and dissemination. After that, there is the dissemination to the state government and other agencies. So the important part is the data is available. Whether the data is authenticated or not, that is the prime thing that we need to understand. During the disaster, we have seen that in the social media, there are a lot of other different type of mushrooming of forecast is going on, but those are not correct. Finally, we have to see that we have seen Dr. Manavendra has mentioned that whether GIS is the useful, whether AI/ML, Dr. Durga Prasad Rao Saab has also mentioned whether AI/ML will serve our purpose. But prior to that, we need to understand that what kind of data we are using, whether the data is authenticated or not. So that part, if you can see, then the role of disaster, role of institution and the dealing with the disaster will play the very, very important role in that scenario. So role of satellite in NWP modeling and early warning system, if you can see this graph shows a very important part of how those model, NWP model, along with the observation, can sustain your kind of a disaster which we are going to see. The nowcasting, if you can see, that bracket is only for 24 hours. But if you can see the warning activities, it will be larger into the early hours. And thereafter, it will go to the 5 days or 3 days or 4 days. If you can see in the last point that it is no meaning. But in the global model, if you can see, global model is start from almost like your 1 day to almost 5th day, 6th day, 7 days. So Chauhan Saab has also mentioned that cyclone is forecast as IMDs has improved a lot. The reason is because the system we have made, and there are kind of satellite data which is to be required, because conventional method is also not fulfilling our entire what we can say the requirements. Like our oceans to be required, and numerous data from the ocean, and over the ocean conventional observation primary limited to the single level data provided by aircraft, ships and buoys. Similarly, coverage these and other ground-based observation system is not sufficient for global atmosphere and particularly the ocean research and weather prediction. So we have a system of that global telecommunication system where number of data we are receiving from not only from Indian satellite, it is from NOAA, KMA, NRSC, CMA, JMA, EUMETSAT. So it is a complete system that is called the data reception system. And then observation has been seen every day by how many data from different organization or different part of instruments have been received. And this is the very important slide which I am telling you, that this is a complete system of decision support system which IMD has built, that is called weather analysis and forecast enabling system. So dealing with the disaster, we need a system. What kind of system? So we have a meteorological information communication system that is called MICS, and then data information processing system, which is very important. Somebody says that some fake news or some fake narratives may come to the social media, but you cannot follow that unless you have data information processing system, which what IMD is having. And then SIVS, CLIMS, WIFS, I'm not going to the deep. This is the structure that what we made in last 5, 7, 8 decade, and through that our forecasts have been improved. So role of satellite, particularly impacts-based forecast, has been improved, because earlier what will be the weather, now we are going what weather will do. This is the basically impact-based forecasting the nature. And then this weather information, weather transition, impact in estimation, and then response scenario. So these 4 categories have been specifically analyzed, and then this weather information provider will get this impacts-based information from IMD. Role of satellite is also important in impacts-based forecast, because still we need to calculate the risk. So what is the risk? Risk is basically risk equal to hazards into vulnerability. So these 2 things needs to be seen from the satellite also. We have a satellite from our optical range of INSET 3D, INSET 3DR, INSET 3DS. The paradigm shift has come in 2013 when these satellites have launched. It has a vertical profile of temperature and moisture. This has also been improved. But here when we talk about impacts-based forecasting, then your risk will be calculated by the hazards into vulnerability. Say I'm telling you, if there is a torrential rain over Cherrapunji, and there is again the same situation comes on a Jaipur, which one will be affected more? It will be Jaipur, because Cherrapunji receives the rainfall. So hazards and vulnerability will be 0 over Cherrapunji, but over Jaipur it will be very high. So whether do we have a kind of a satellite that needs to see this impact-based forecasting from the point of view which we need to look at. This is the hydrometeorology. There are discussion that satellite-based derived rainfall and soil moisture product are also operationally used by the guidance with the flash flood guidance. IMD has initiated with the NOAA and WMO, and it was also given to the Chennai, Bangalore, and other cities also. It is being planned. And if you see the agrometeorology, we have already seen that the 5 days and 7 days weekly forecasts have already been issued by IMD with the number of observations from the satellite, particularly soil moisture, evapotranspiration, surface temperature, NDVI, net radiation. So these are the area where the information is to be required for the impact-based forecasting, and then climatology applications for the long-term data sets. The long-term data set, when we talk, then INSO, yes. So MGO monitoring, number of monitoring also been possible from the satellite, and now we need to be utilize it. Now instant data sharing, we have seen GMA, WMO, a lot of other international collaborations, and operational agencies are along with IMD and sharing the data with us. Now one example I will give you, the heavy rainfall skill over 20 to 24 has been improved about, you can see 30, 14, 45% improvement in skill score of 24, 48 and 72 hours lead period. So that lead period is very, very important for disaster or any kind of a risk. And this is the last 5 years, the improvement is almost you are 40 to 45% compared to the previous 5 years. And an improvement, why this improvement has happened? Because this is the average absolute error during the last 5 years of the seasonal forecast improved. I'm not going to the one by one. I'll go with the improvement in thunderstorm and forecast skill during 21 to 24 last 5 years. 53% improvement in probability of detection, 35% improvement in critical success index, and 57% improvement in equitable threat score. So the way I have started, if you have authentic data, then only you can calculate it. But if you go ask anybody from them, anybody from other agencies, you will that they're just issuing the risk or the forecast. I'm sure that you will not get this score from them. Now, how did this happen? Augmentation of observation system from 14 to 25, last decade if I say. Weather station from 675 to 1208 have been improved. Radar 15 to 40, and next 2 years, entire India will be under the IMD radar. Augmentation of computing resources, now 28 petaflop in 2024. And the last line, if I'll go, the GIS-based decision support system, which I was saying that we have developed the GIS-based DSS, where the in-house DSS is giving the geospatial technology subjective to objective analysis technique. That is the most important part. So simply putting the data into the GIS will not serve your purpose. So objective analysis technique, large area to granular scale is very, very important, like what we have achieved in the Mausamgram. These are the gap areas which I would like to highlight in our this part of the world. The finer spatial, it is final, sir. It is the temporal resolution, geostationary satellite is to be required, constellation of satellites, scatterometers is to be required, global all-weather vertical profile of wind, temperature, humidity, constellation of cloud precipitation radar that we are missing here, that we needs to be filled up. I'm sure it will be filling up, and then requirement of 4th generation has been submitted to ISRO. Polar satellites, space-based active instruments also be required, and constellation of small satellite is to be also required. Thank you.
Thank you. Thank you. Thank you, Dr. Mitra. So now we will invite Dr. Seema Joshi for.
Thank you, sir.
So please, you also.
Good afternoon, a very, very warm welcome. Sir, first of all, thank you so much for giving me this opportunity here and to talk about the role of geospatial technologies in the real-time systems. Sir, as I see, I mean, if I, maybe, okay, I'll use this pointer. As we all know, I mean, in hazards, we have to answer a number of questions there and then, and that is where, I mean, we are seeing many successful implementations also. And so, like our early warning system in GIS has implemented the system for the tsunami, and IMD, the rich data is generated, and excellent early warning data has been prepared by IMD and shared. That is, again, a very, very rich information available to us. But my question here in front of all here is, unless until that rich data analysis information, early warnings that reach to the last mile, the real emergency support functionaries and citizens, it is I mean, not really effective to respond to the hazards. And that is where we see, I mean, there are many, many case studies if you see on the screen. I mean, there are many global and national implementations. But again, unless it is used in the GIS platform for the decision support, we are really not able to leverage that. So I'm just trying to bring in some of the aspects we are facing these challenges, and this is like INCOIS has already implemented for the early warning, and it's really saving many lives. But what I believe, or what as a geospatial technology is in the real time, because the information is received that there is a possibility of tsunami in such and such area, but then at the end of the day, those district magistrate and district functionaries, they need that information to take decisions in the crisis, and that too in the middle of the disaster-prone areas. So that is where what we are just trying to bring in here is that if that information is integrated and provided in the form of simple-to-use apps and dashboards and mobile-based apps and all, which can be leveraged by all emergency support functionaries, then only it will be really effective to use in the real time. So this is a video. I don't know how to run this video. Okay. If you can just play the video. Sorry. Anyway, I mean, this is a video, so I mean, you can just view it. This is showing a complete picture how the tsunami, because where at times when the tsunami is coming and eye of the is changing the direction, and this is a live use case when it was striking in this port, and then suddenly because of the wind direction and wind speed, it landed over onto the West Bengal area. So here what we have just tried to simulate that in addition to the simulation there and then, we can keep intimating the local functionaries with the information about how many districts, villages, infrastructure, roads, hospitals, schools, all those will be impacted, and where they should be evacuated. So even evacuation centers should not be falling under those. So that is where this kind of application was created, and I mean this is a complete end-to-end scenario how it has helped in functionaries in evacuating. And now this is another situation which I just wanted to bring in here in the GIS tools. So data is available, lots of information is available. Again, we need to simulate and derive the results and then finally derive the action plans. So this is again a quick scenario for the floods. Can you just run the video please quickly? So these are all videos actually. How to play?
Somebody can help.
Can someone play this? Let's go into the next. Actually, I wanted to really show this study to give you the real, how this real time can work. Can you just play previous one? Anyway, if it's sorry, let's not waste time. Is it not?
Yeah.
It's not running. Otherwise, I'll move forward. No problem.
Please.
Yeah. So anyway, I'll just quickly talk about this one. This is a complete scenario where the rainfall, how the rainfall is getting. We are getting the exact parameters of the rainfall. The system is simulating the right there and then how much inundation is happening. On the basis of that algorithm, AI algorithm which has been integrated here, and the hydrological modeling and all those HECRAS and all those models which has been, hydrologic models has been integrated, and you can see live, I mean, you can little make it fast forward. So here, I mean, this is, this will show that how much area is going to be impacted. In fact, this particular model we have tested with the Delhi scenario when there was floods in Delhi last year, and then we did this simulation, and on the basis of the rainfall, how much rainfall and the area and land use, land cover, all integrated information together, and we have derived this analysis that how much built up area and how much buildings are going to fall into that, and then using AI tools, the building heights, drone data. So we have integrated here drone data also, and using AI we have extracted those building heights. So how many floors of the buildings are getting are impacted, and then there was one scenario we have done it for the Uttarakhand also. So we have seen, I mean, in Uttarakhand, as soon as there is a rainfall, the roads, people get swept away on the roads because of the heavy rain and then water crossing on the roads. In this particular model, it will show how all those roads and infrastructure which are falling into that, they are getting impacted. And if we build some construction, I mean, some under mitigation measures, if we create some scenario, like here it is showing, if we create a small, mitigation measure, I mean preventive measure there, how we can deviate water from going towards the road instead, and it can be deviated. So these kind of models are available and in real time. The best part is these models can be used in a real time as soon as the rainfall and information is getting fed. Thanks to IMD, we get a very good information, so that information can be directed inside this model, and then its model can generate that inundation, flood, and then finally it can help us in evacuation measures and all that. This is another similar video where how much inundation has been impacted and all. Yeah. So, so this is where what we are trying to show, that it is not only, this real-time model is not only for the flood inundation and how much buildings are impacted. It can be for the functionaries also, where they should put a roadblock so that no unnecessary traffic jam will happen. So it's a real-time scenario, something where the flood is happening here, and if the this road is getting impacted, the traffic police or the person there in the field, they can mark a roadblock there itself, and then finally that information will be helpful for deviating the traffic. So that is what in this particular scenario we have tried it with a few of these states. Rather, one scenario was done for Andhra Pradesh also, so like Vijayawada, and we have tried to do this modeling there. And this is a live snapshot from there, what we have used from the data. So this is for the flood inundation. Similarly, I'll just quickly highlight, I mean, there are situations when we talk about the GLOF. We did a small POC with the NDMA actually, where we have just tried to do that POC. And here also we were able to generate outputs, but only thing is it needs to be in real time. We need to really build model on top of it so that it can help officers in taking decision in real time. So forest fire is another big hazard. I'll quickly talk about that here. Again, in my recent experience in Dehradun, I just saw one day morning, there was a little, there was smoke in the area, in the forest area. And I was just wondering whether it is some agriculture smoke or something what. But that smoke was coming since morning. And finally, in the end, if you see those snapshots, these are the real snapshots of that area. In the evening, it was a massive, massive fire and acres of land got burnt under that. So that is what I was just wondering. In GIS platform, we already have those models which can detect flumes, smoke, and these kind of information using the weather and those parameters, and then it can directly trigger and inform, send alert messages, and this kind of information systems we have implemented in some forest departments where FSI is sending alert messages, but then the message which is received by the FSI, it may fall in this beat or this beat because the resolution is very not very, very high. So what we have tried to use is we have incorporated and augmented that information system with more high resolution sentinel data and all. And if you see this picture in the sentinel data, this is a 10-meter resolution. You can see even a fire burning, and we can exactly detect in 10-meter resolution where exactly fire is happening in compartment or beat level. Like that. So this is how, what I'm just trying to say here is something for the similarly for the landslides, and COVID experience we will never forget. I think in this life, the kind of real-time information was required, and lots of data was there, but here and there, and finally at the end of the day, we were required to bring that data in the GIS, take decisions in the real time, and disseminate that information also in real time to the officers to take necessary decisions. So these are different applications, and then overall the key expectation is real-time information to be shared for the situational awareness and all, and for the smart planning, evacuation and all. But here I can just highlight that yes, GIS platform has this capability to bring drone data, sensors data, IoT data, information, other information from weather sources, from satellite imageries and all, and then all that information to be brought at a common platform, used for the processing and all in an automated way using AI models and all, and then subsequently it has to be disseminated to the last mile stakeholders who are the actual functionaries who will be working and responding in the field. And that is where I'm just trying to just 2-3 more slides here. Lots of information data.
Actually,
we
will lose time for interaction with the audience.
Yes, sir. Yes, sir. just quickly 1 or 2 here. This is how we can integrate all this information, sir. All different kinds of information. This is the advantage of GIS platform. Actually, GIS for real time. Actually, that is what I'm just trying to say here, because real time itself will not work until all information is brought at a common platform, and then only that real-time automation, vulnerability assessments and all models and everything, they will work. So first it has to be brought into the GIS platform, and that is where, and then all support functionaries has to be enabled, and that's what I'm just trying to bring in. And last but not the least, sir, last slide here, capacity building at the holistic level. I have seen the cases in my last 35 years of experience. There are implementations, there are softwares and applications, everything. But until people are trained and provided and orientation in how they can leverage and use it, again, it is of no use.
Yeah.
So that's what my request here is. Thank you, sir.
Thank you. Sorry for, because of short of time. Now we will move to the next, lecture by solution. We have got from solution provider. I will immediately invite Ms. Samhita, CEO from Resilience AI. can speak or present, whatever you like.
Thank you so much. We would want to roll out a video, and then I would want to have a dialogue. I think that's much more powerful than a presentation, if it is okay with you, moderator.
Yeah, what we can do is that you can speak for 2-3 minutes after completing all the discussion.
Just
we
one
can have
video we
question.
will roll,
Yeah.
and then we started the
Yeah.
dialogue, and I want to compliment with the presentation today.
Yeah.
Okay, fantastic. Can we please have the video?
Every natural disaster has a story, but a map without machine learning is map without navigation. $150 billion physical infrastructure is exposed to natural disaster today. Most of it mapped in advanced GIS and EWS, but not measured for damage, risk, and uninsured. We mapped a data center and its perimeter of 0.1 square kilometer in India in Resilience 360 for flood risk and heat risk in 30 minutes. The risk for heat is high, while the risk for flood damage is very high for the same data center. A diagnostics of why the high is high was provided to customer to action on architectural upgrade. At Resilience AI, we combine advanced GIS with ground truth structural damage based on 29 real-time disasters and more than 1 million buildings using AI/ML to bring actionability for disaster management with live signals. So the map isn't just seen, it acted for asset managers, risk officers, and government bodies.
Thank you so much for playing the video. Brilliant interaction since morning. I think I'll go back to basics. I think that's what I have done always. Disaster, I'm a student of natural disaster even today. There is so much to learn. It's not something that can be coded overnight. And it will need more than just technology and tools to come and solve for disaster. So on that note, today's conversation has two words. One is risk, and the other is management. I'm an auditor. My life started as a finance auditor. In our world, risk not measured is risk unresolved. And that's the parameter on which we start risk. And we have used the exact same knowledge when we use GIS tools, advanced GIS tools. But most importantly, I love the Vasar conversation on having physics plus ML coming together, because that is exactly how you can bring meaning to disaster risk reduction. Now, if you measure the risk, the second open conversation that I always love having in technology is what is the granularity? Where do disasters happen? Does it happen on streets, or does it happen inside your structures? Our entire life, since the time we have woken up in the morning, if I'm a construction site worker, starts at my home. And I go to my workplace, I work in critical areas, exposed areas, and then I come back home. So our second conversation when we are building Resilience 360, which is the heroine of this company, is all about structures. Because if we can do a disaster -1, which means disaster being day 0, and disaster before as a conversation at a structural level, and at that level of granularity, I think we'll be able to protect more and more and prevent the amount of damage that happens today. The third conversation, which I like flooring, because there are two words again in this for which all of us are looking up to the content. GIS is a tool. Real-time GIS is an aspiration. And we are all working towards it. नाइंसाफ़ी हो जाएगी अगर GIS पे इतना दबाव दिया जाएगा. So machine learning is an absolutely interesting way of progressing from a tool to using it for real-time risk assessment, risk measurement, risk management. And I would believe that that is the world even if we achieve. Of course, Gen AI using LLMs or SLMs is the next step forward, which will give you more accuracy, more conviction, and definitely more preventive way of taking a decision. But right now, I really think even the usage of machine learning is a good progress step towards the amount of data that we have harnessed. In summary, if I have to summarize, I would say disaster risk reduction and flip the script to disaster resilience And you are resilient only if you take actions before disaster, using technology which is in the hands of administrators, but also in the hands of private corporations, because they also have these structures. They also have warehouses, they also have office spaces. If both these public sector and private sector can operate using something which is as simple as your computer, a login and password, and can use the decision making, I think then we have harnessed both GIS and a true early warning, not a system, but a service. Thank you, Dr. Pai. I believe I'm on time.
Yeah, thank you. Now I will invite Shri Dheeraj Mehra, CEO Micronet Solutions. So you want to make presentation?
No, so that's what we just discussed.
Yeah.
So any point if you there is there I can
yeah.
answer.
So you can
content provider side.
Yes. So you can actually tell some experience where you might have applied, GIS. Specifically, what are the gap areas that you observe, applying to early warning system.
And they are more related to the administration side, which I can talk. Sir.
Yeah, please.
Yeah. I thank NDMA for inviting us, and I thank the chair for giving me an opportunity to speak here. So, as we are all part of this single intent that we want to save lives, so a lot of the early warning system is like ma'am said, it's aspirational, but what I want to highlight is the last man on the field, in the villages or in the district headquarters. Like I was just briefly sharing my views with Mr. Rizvi as well. So he's the one who is nailed on the cross. Why? Because he has no powers, he has no funds, he has no decision-making capabilities. So when we are talking about disaster management and risk reduction, we need to create an ecosystem. So ecosystem needs a whole lot of kind of a database building and capacity building solutions. So I would say one is the base layers. Base layer, you have land use, land cover, satellite imagery, the elevation models. Then you have sensors. You have multiple sensors, IoT sensors. You have satellite-based sensors, and then we have a visualization capability, communication and dissemination capabilities. What the gap we found is that whenever disaster happens, every government machinery suddenly wakes up, and what they ask is, "Arey, abhi ke abhi chahiye." So it doesn't happen like that. You have to create a process flow, because government में एक administration process है, procurement process है. It just can't happen कि आज अभी के चाहिए. क्यों? अरे मंत्री साहब को देना है. कुछ तो दो यार, कुछ तो दो. Things like this is a day. We face this on a daily basis. So my request to NTMA sir is, and the state disaster management agencies, that put those processes and ecosystem in place so that we as a private players can assist the department to deliver. Usi waqt chahiye to sir, okay fine, I can do a imagery, like one of the audience members said that she wants imagery of tomorrow. Yes, I can do that. We can do a very large imagery. I mean, we have multiple satellite constellations. I have 5 satellites on optical, 3 on radar, and in fact our satellite radar sat from MDA has been widely used by NRSC for all disaster management applications. We have DEM, and one more very critical component before I finish is that all the database, like Dr. Durga Rao sir has done an excellent job at NDEM. I'm really amazed that kind of data is available, because not every state has that kind of database, sir. So the data, it's a Herculean task to build a database, point number 1. Second, once the money is spent on that, nobody wants to update it. Updation is the key for effective response. With that, I rest my case, sir.
Thank you. Thank you. Yeah, now I will go to Shri Joel Joy, who is Assistant Commandant from ITBP. They are responsible for disaster management in the Himalayan region and are the first respondents to natural calamities, and also responsible for relief operations. So you can tell your experience.
Thank you, sir. Good afternoon, everybody. I am the last man standing between you and your lens, so I will close it very quickly. As you all are aware, ITBP is primarily responsible for guarding the 3,488-kilometer long Indo-Tibetan border. As the Sentinels of Himalaya, we are the primary first responders of all natural, all disasters happening in the Himalayan belt, be it the 2013 flash flood at Kedarnath, be it the 2021 floods at Uttarakhand that last panelists were discussed, the Lonak Lake Gulf in 2023, we were there, we responded first. So ITBP is the primary responder or the first responders, basically the first responders for all natural disasters in the Himalayan belt. Coming to the topic of the GIS, real-time GIS, please assume a scenario. A particular ITBP official who is posted in a border noticed a sudden rise of water level in a particular river. He is sending a report, that is one report. Simultaneously, IMD provided a weather forecast about an area, second one. Third one, some INSAR, NRC carried out some INSAR analysis of that particular area and found some alarming changes. Fourth one, a ground-based sensor that is also giving an input. So all these inputs are coming to the Disaster Management Authority, be it in a message, be it in a paper format, be it in a report. So the combining, the holistic approach, the holistic or comprehensive picture is not comes in the paper. When it is combined in a GIS system, you will get the complete picture, you will get a holistic manner. That is the role of the GIS. The next thing is all matured disaster disaster management platform like GDAX of UN, the USGS Earthquake Hazard Program, everything is built around a GIS system. You visit the site, you will find the GIS system. I think first they invested, it is my assumption only, first they invested in the GIS, then only they build the other things. Because you need something the spatial data need to be plotted somewhere, need to be analyzed, that there is a role of GIS. Coming to the point of what kind of a GIS system, sir, we were discussing in the earlier sessions, we need to use the open source GIS. Yes, we need to use the open source GIS system, sir. But we should not restrict ourselves to some desktop based GIS application. That may be a starting point, sir. That will be a starting point, but we need a complete holistic solution. That can be used as a capacity building also. We can train personnel, but the NDMA or the disaster management setup of the country need a robust and much scalable kind of GIS platform, which covers all the stages, starting from preparedness. For example, we need to carry out the impact assessment. There should be a facility in that GIS too. Then coming to the early warnings, suppose there is a provision to ingest the reports posted by the people from the field or from the security forces to that system. That system should be there. Then it should also include the response part also, sir. NDM, sir, from the previous presentation, I think that's a good starting point in this direction. We will build incrementally in this direction. So ITBP, coming to the last point, ITBP plays a very good role in the entire disaster management, particularly in the Himalayan belt. We conduct regular patrols all over the border, sir. We, especially in the context of GLOF, sir, we are patrolling all these areas. We know the water level. We observe the water level, and we used to feed that report that water level also to the state authorities or state machinery. That kind of role. And one thing is that sensors are installed, sir. In Lonak also there was a sensor installed. So the point, many of a time the communication broke. So that is causing a point. So ITBP forward locations can be used as an aggregator of all the sensors. So from there we can backhaul. That kind of a mechanism we can also think about. I'm stopping with one last statement, sir. The opening ceremony, in the inauguration ceremony, the respected member and HOD of the NDMA stated that the GIS or the technology cannot replace men, sir. It's very accurate, or it is very apt sentence. When the Lonak glow occurred in 2023. Sensors were installed at the lake. That didn't give the early warning. And alerts, Sindri, alert ITBP personnel who was manning the post, the forward location, he noticed the sudden rise of the water in the river, and that triggered the entire response mechanisms. So we need redundancy, and the technology is a force enabler. It will help us to reduce our burden. Thank you very much.
So you are correct. Both the technology as well as man, both should work together. Then only you can. Human intervention is very important. So now stage open for question. So 2 or 3 questions we will take. You can just let us know who should answer if you want, or we can same question can be answered by others. Please. Yes, sir.
So, Dr. Joshi mentioned about the creation of the platform, that we need to have a platform. What does it take to create the platform? What are the kind of technical requirements, financial requirements? Have we set up any platform so far? And if we have set up, how has it worked?
So, thank you so much, sir, first of all, for this query. Sir, platform, though this name is looking very big and all, platform establishing and all, but it is simple and enterprise implementation which has to be there. And there are many states already have this platform implemented. So recently in Uttarakhand also this platform has been implemented. It requires an enterprise software, simple, where we can publish data, access and integrate all different kinds of information. Now this ESRS platform, or any GIS platform if I put it this way, GIS platform has the capability to integrate different kinds of data seamlessly. Even the data is available in PDF formats, it can access that and geocode and prepare during the preparedness. It can help in preparing data and integrating all information. Now after preparedness, when the response, once the data is integrated, then it has to be disseminated to different stakeholders in the form of simple to use maps, apps, mobile apps, like that. So here this platform has these tools, inbuilt, readily configurable tools and apps which can be simply configured, and in a very short time it can be enabled and those apps can be created and provided. The live example is like in NDMA during the COVID, within 1 week's time this platform was enabled and all these stakeholders information was provided even till PMO level. Information was, the platform access was provided in MHA, NDMA and all at different functionary, state officers, even district level officers. Rather, one small example I just wanted to add here only, the hospitals, there was a requirement of oxygen. We all know there was a mega issue of the oxygen supply at that time, and it was required how to monitor this availability of oxygen in hospitals. Now district health officials, they used to ring every hospital and they used to collect data, aaj kitna oxygen aaya, how much is used and how much is left and all. So here the value of platform comes into picture, because that was not successful because they were not able to collect information on a regular daily basis. So here using this platform, we have configured a simple mobile app, provided that mobile app to the hospital representatives. They used to take just 1 minute a day in feeding that information, and all information was available in the center for analysis. So that is what I'm just saying. So implementation of platform is just establishment of a server with configuration, integration of the data, configuration of apps, and providing those apps access to different stakeholders and functionaries. And cost-wise, sir, I mean, it is very, I mean, it's not that high. I mean, within I can say limited budget of, let's say 2050, it can be achieved easily. Thank you.
Any other question? So if there are no question, I will
50 crore or lakh?
Sir, it's lakhs.
Yeah. So if there are no question from audience, I have got question for Samhita and Dheeraj. See, we talked about AI, drone, etc. technology. What do you expect other potential technology along with, your real-time GIS that can improve? You feel that early warning can be improved and that can help much better decision making,
Brilliant question. Can you hear me? Yes. Okay. We heard Gen AI. I think because we are at a stage of technology, one of the things that I heard during the entire day is data is available, but data is available in multiple different places. When you talk about real time, you want to solve for a query real time. That's one of the biggest problems. I ask a query at your last mile. There is an operator, there is an officer sitting in the last mile of a country. And once that query real time, what's the sea level rise? Or if I have given you a report of sea level rise for X number of years in an X axis, on a Y axis in a geographical topography, tell me what is my propensity of risk. The answer to that, and I love this because I've just come back from an address by Satya Nadella. There's this entire universe called agent. By the way, let me clarify, agent is not process or power automation. What you see as a chatbot is a process automation or a power automation in the world of technology. It is not agent. Agent is, think of it, it's like a switch. Today we all do API integration. I have to ask your permission. You have to ask my permission. We come midway and integrate as API, right? Think of it, I don't need to ask your permission. You have proactively allowed me to enter your zone of data. I have given you access to my zone of data. And there is this universe where they're meshing at a trillion speed to be able to give you that intelligence in near real time. I believe that today, agent-based innovation or injection is the best way if we really want to have authentic real time and not what we always traditionally say very shyly, near real time. That would be my summary of technology. But I am a technology geek and it comes out very promisingly. More than happy to listen to others.
Excellent.
Sir, I would speak from the domain of the satellite data acquisition capabilities in terms of early warning systems or decision-making tools that we can offer. I think Nikhilesh would be more appropriate to speak on the Gen AI and all technologies, but I would say that a lot of satellite OEMs are now building those capabilities on board the satellite itself. See, nowadays, currently what is happening is that the systems are designed and built so that you receive the data. Now, because of the advance in AI and cloud computing, what people have started demanding, oh, I don't want the satellite data, it's, I only want the relevant information from that satellite data. So a lot of satellite operators and the OEMs started building onboard processing capabilities to extract that particular information rather than, you download the data, process it and deliver it. So I think in the coming years, we would be very looking at, very exciting times wherein we get the required very precise data by processing the satellites on board and getting that information right away and integrated into our GIS systems. Thank you.
Thank you. Just Dr. A.K. Mitra, how do you feel that GIS that can improve your early warning system very quickly?
Yeah. As I mentioned in my talk, that the data and then associated with the algorithm, that needs to be improved, and then objective analysis. As Shri Joel Joy also mentioned that the triggering point has come from the last mile connectivity of that, not that system, that particular man who's sitting there. So we have to bridge this particular gap with the high resolution of data, with the frequent, high frequency of, temporal frequency of satellite data, which we really need now. And then as Madam Dr. Seema Joshi has mentioned that how last mile connectivity will be done with the proper GIS simulation of those data. So I think when these three things will combine, I think we can achieve these things. Thank you.
Thank you. So finally to Dr. Joy. So what do you feel that, for last mile reaching or how to respond, what do you feel that there is any gap or what exactly more that you expect from GIS?
GIS basically, in order to make it real time, the last mile connectivity is the most critical aspect. So with the advent of the new technology and the new communication satellites coming in the low Earth orbit, as you all know, Starlinks and all things, so there is definitely a revolution is happening in the last mile connectivity. Soon we will get, I hope that we will get some indigenized Atmanirbhar product in this aspect also, so that we can use that with all data security and considering all other aspects. That's my take.
Okay.
Thank you.
With this, I thank all my panelists for completing on time and giving good ideas, and also all the audience for bearing with us in between the lunch. Thank you. Thank you.
A big thank you to Dr. Pai sir and our brilliant presenter and discussion for such an eye-opening session on real-time GIS and early warning system. May I request Dr. D.S. Pai sir to kindly present the mementos to our panelists and join us for a group photograph.
Thank you so much, sir. Thank you.
Dheeraj sir.
Yeah. Is there, sir?
Yes.
Right at the end.
Yes. Please.
Now, ladies and gentlemen, it's time for lunch, the most anticipated session of the day. We invite you to mingle, share ideas, and maybe even exchange more than just a business card. Please carry your ID card with you, because lunch is in the next building. Lunch is in the Atrium Hall. Please be back.
Yeah. So we will come for a
Next building, sir. In the next building, Atrium Hall. In the town, sorry, it's down in this building. It's in the same building, down, first floor, Atrium Hall.
No, you did fine. You were doing your job and you were supposed to follow it.
space-based innovations. Our first session of the discussion dives into challenges in spatial data collection techniques for disaster management. We are honored to have this session moderated by Dr. Krishna S. Vatsa, member NDMA, and our esteemed presenters and discussants include Shri Sanjay K. Singh from SAC ISRO, Dr. Aditya Kumar Anand, Project Scientist NIDM, Shri Sumit Thapa from Technical Services at Hexagon, Shri Sandeep Srivastava, Director NGD and UGI Survey of India, and Dr. Avinak Shukla, Scientist RRSC North. Sir, please come and join us on the dais. All are requested to please come into the hall.
Good afternoon. Good afternoon, Shukla.
Yeah.
Scientist at NRC.
Over to you, sir.
Thank you.
Good afternoon. Let's begin the session. Safiji always slots me in the post-lunch session. It's one way of getting back at me. Thank you. Thank you. So we have this session on spatial data collection techniques for disaster management. You know, it's the most important aspect of the data collection. We are looking, risks are dynamic, risks are evolving, and we, I was just talking about we have just developed the program for lightning mitigation, and we identified 50 most vulnerable districts for the purpose of from the point of view of lightning occurrences. And then in the last 1 year or so, when the program developed and got approved, we are getting the messages that the risks, the spatial characteristics of risk had changed, and there are many other districts which are getting more affected. And so the districts that we have identified need to be changed. So this is actually very much an outcome of the way the risks are distributed spatially, and it's very, very important that we observe those risks spatially and find the patterns, and then we establish it. So, this is perhaps the most important dimension of risk assessment. So for that, to discuss that and various techniques, we have here two presentations, one from Sri Sanjay Singh from ISRO, and then it would be followed by Dr. Aditya Kumar Anand, who is from NIDM. So I invite Dr. Sanjay Singh. So now let's Sanjay K. Singh. Right. So thank you, and I would just request you to make the presentation brief and precise. Thank you. Thank you very much.
Okay, so good afternoon all of you, and I'm Sanjay Singh. So basically I will be presenting on the challenges in satellite data collections. I will restrict my talk to satellite data collection. So I will talk about what are the sensors we are having from ISRO and what are all the future plans. So those things I will be discussing. So just to start with, you can see there are various use cases I have put in the slide. So the left one you are seeing is the land deformation studies which are done. This is volcano studies done for using the US 04 data set. And then bottom one is the interferogram generated from INSAR data. This work has been done by my colleagues at SAC. And then you can see that wind vector is also there. Wind vector is used for cyclogenesis, so that is another use case. Then since morning we have seen that we have talked a lot about the GLF. So same study for same area study has been done by our colleagues at SAC using the US 04 data. So that is pre-event and post-event, both the data sets you can see. Then recently we had an earthquake in Myanmar. So for that Cartosat 3 data, which is a 0.3 meter data which was acquired, and that using that data we did the analysis. Basically we wanted, it was just to assess what kind of damage has been done. So you can see the bridge is broken and all those kind of many structures getting destroyed in that particular earthquake. Below to that is the AWIFS data which is used for detecting the forest fire, Los Angeles forest fire, which was recently happened. So that we did, that we had acquisition from there. Then as we can see that radar data, sometimes this optical data, many times it may not be useful because of the cloud coverage and all. So this is just one use case where we have shown that how radar data we are able to distinguish the features on ground. So okay, coming to remote sensing from space. So basically since I come from center where sensors are developed, all ISRO sensors are developed, and then remote sensing is done in from space in mainly 3 domains: visible, thermal and microwave domain. So optical region, mainly it is all passive sensors are there, and then thermal region we have MWR and LWR, those sensors are there. Obviously there are other sensors like for meteorology applications, there are other thermal sensors are also there, but MWR and LWR, they fall under this category. Then we have active sensors and passive sensors from both for microwave we have both active as well as passive sensors. Okay, so as you can see, the optical imagery, it provides the visual information. Then radar imagery, it penetrates the clouds and darkness. Thermal imagery, basically it provides the temperature or information, and then hyperspectral imagery gives basically the signature of a particular object. So these all sensors, if you see, they are all complementary to each other. So we cannot say that we can have one kind of sensor for doing the one kind of analysis. So all these kinds of sensors are required, and these all types of sensors are being developed at SAC. So this is a satellite data for disaster management. This particular slide tells about what are the limitations we have in satellite data collection. So technical limitations, already I spoke that spatial resolutions, temporal, morning also it was told. But if you see spatial resolution, if we want to do event monitoring at a smaller scale, then we require high resolution data set. And if we want to do at a larger scale, we require a lower resolution data set. So it basically depends on the type of the event, what kind of the resolution you want. So here right side, if you see this particular, I think the GIF is not playing. It is a GIF file. So basically I wanted to show here actually 3 satellites data, same area was put. It is a SAC campus. So Cartosat 1, which is a 2.5 meter data set, and then Cartosat 2, 0.8 meter, and then Cartosat 3, 0.3 meter data set. So how the features have changed and what are the kind of information, how the image sharpness improves. They are like developed over a time. No? These sensors are developed over a like 15 to 20 years time frame, and you can see, you can appreciate the what kind of the information you can derive basically from this high resolution data. Okay, temporary resolution, you already know, okay, we in disaster situations we require high repeativity, so those things needs to be addressed. So basically we are, for this kind of things, we are coming up with a constellation of satellites at ISRO, so that would address basically the temporal resolution issue. Then spectral bands, anyway, you know that we require optical bands needed for specific applications. So those are that, and you all know that cloud cover and those things are interference and sensor limitations. Though we may have all the sensors, but still we may not be able to collect the data. That is also possibility. So those are still the limitations which can be overcome by like non-space sensors like UAV or airborne sensors. Then coming to data access and availability, high resolution data, we get data at a very high cost. It will always be a costly compared to all data set. So that cost also has to be considered in our project planning. Then since data sets are not available with us when we are trying to get the data, that data providing agency will put you in the constraints. You cannot share the data to any other user agencies. So this also remains a bottleneck. And again, timeliness of the delivery and data gaps. These are also the two important issues which are limitations in data collections for disaster management. So again, continuing to that, so if you see the right side, this whole data processing flow is depicted there. So right from data collection, satellite data when it is collected, it has to be tasked, right? So that tasking, that morning you mentioned that whenever disaster happens, alerts are generated. Then satellites are to be tasked. Then those tasking, capturing the imagery, those things are the important activities, and this requires coordination basically between various agencies, data providers and users. Then as I told that high resolution data if we want to process, and low resolution data if we want to process. So high resolution data will be always a high volume. So we need proper compute power and processing speeds at the processing centers. So and specialized software and high resolution, high volume data process its own challenges also. So those are basically related to data processing and capacity related. Then integrating this satellite derived information with ground-based data, GIS system, these things anyway we discussed a lot. And then expertise, these things also we discussed. So coming to community and ethical concerns, the privacy also is an important issue that we have to consider while data collection and then data distribution. So basically this operation involves like right now we are having a Carto 3 for Cartosat 3 data set acquisition. We are having a Ka band. Okay, so Ka band is 1.6 Gbps speed is there, reception speed. Okay, and our data is generated at a high volume. It is almost 24 Gbps. So data has to be compressed. Still after compression also, the data we cannot transmit in real time. So those are the challenges we need to address. We need to have a better ground station capability from satellite point of view. We need to have a better transmission capability. So those things need to be addressed. And also when we are building a satellite, what happens is we put apart from imaging sensors, there are other sensors which works like orbit sensor, attitude sensor. Those things are already there. Now each of these sensors have got its own limitations. inaccuracies, I would say. So those inaccuracies, like suppose if you want to target a certain area and you are not able to target, so that means that accuracy is targeting accuracy. So targeting accuracy is also when we are having smaller frame cameras like 2 kilometer by 3 kilometer kind of frame camera. So we need to have a very good targeting accuracy, maybe in the order of 100 meters. Right now it is like 100 meter we have achieved with Kato 3. So those kind of accuracies are required and we have to enhance those so that we can target the required area on time. So that is coming from satellite. Then data processing point of view also, we need see these inaccuracies will lead to inaccuracies in the products. So we need to have better controls on the ground so that we can validate our products and then we can release a product which is operationally acceptable to the user community, like for disaster management.
Can we now conclude it?
Yeah, just one more slide. Okay. So we have Earth observation missions from ISRO. You may be aware this the Kato 1, Kato 2 anyway it has retired. 2A, 2B we may have historical data, so those things can be used. Cartosat 2S is 0.6 meter high resolution data at a swath of 10 kilometer. So that is available. And then Cartosat 3 we have 0.3 meter panchromatic and 1 meter multispectral data. Recently launched Microsat 2C has these channels, though they are frame cameras, they are smaller in size, but they can be used for forest fires and other applications. So these are the sensors basically which ISRO has to offer to the user community. Though these are like in upcoming HRSat mission also. HRSat is a constellation of missions where we are going to launch 3 satellites in a single PSLV. So there we will be having both we will having panchromatic, multispectral and IR. But IR what we are trying to do is, since we are having the camera size is small, it is a frame camera smaller, so we'll be putting innovative method where we can increase the swath of the ground so that it becomes like a 15 kilometer by 15 kilometer kind of thing. So that our sensor team is developing that mechanism, that is FSA mechanism they are developing. Then since morning I am hearing that digital elevation models are an important input for all disaster monitoring applications. So we are coming up with ResourceSat 3S mission. So that also is in the pipeline. Anyway, microwave HiSat 1 is not there now. 1A is still operational. US 09 has failed, which was like similar to planned, but it failed recently. So we could not put that in orbit now. NISR is coming up. The morning Prakash sir has expressed that. Then this scatterometer, anyway, we have seen that it is operational. GNSR is something new which we have come up, where we are using GPS signals. This is an innovative way of generating the things. So we have used the GPS signal, and that we have put the sensor to sense the GPS signal in the orbit. So this is like a passive microwave. So these are the various portals we are. Anyway, I think this has been Vedas and Mosdaq are SAC developed. I think Mosdaq generates inputs from for weather inputs. So that is being, and Bhuvan, anyway, it has been expressed. Thank you.
Thank you very much. I'm sure there will be questions for you, but maybe we can take those questions later. I invite now Dr. Aditya Kumar Anand from NIDM.
Good afternoon, everyone. Myself, Aditya Kumar Anand. I am working as a project scientist in National Institute of Disaster Management. Currently, I am working in a project development of National Highways Climate Adaptation Policy and Guidelines. So the main role in this particular project was the selection of national highways, and we have to select the 2,000 kilometers of national highways for our vulnerability assessment and multi-hazard modeling and climate impact projections. So my topic of presentation is what is the role of weighted overlay analysis tool in site selection of HiCap project, a case study from the Odisha. So first of all, I start with what is weighted overlay. Weighted overlay is a tool which applies on most of the used approaches in the overlay analysis, where we have a multi-criteria problems in the site selection process and the suitability models. So for the weighted overlay analysis, we first have to define our problem and break the model into sub-models, and we have to identify the input layers. So since the input layers will be in a different numbering system and different ranges, and to combine them into a single criteria, we have to weight each of them, and it must be reclassified into a common preference scale from 1 to 10 or either 1 to 5. It varies case to case, where 10 being the most favorable one. The assigned performance on the common scale implies the phenometric preference of the criteria. So in this particular process of weighted overlay, all the input raster must be in integer. There should be no floating point, means there should be no decimal degrees.
Can I just interrupt you?
Yes,
can you make the context of the presentation a little more clearer? People should understand what in the context of hazard risk assessment, what is the central idea of doing this weighted?
Coming to that particular point. And so now comes to the reclassification. Once we get the layers, we will reclassify them, and each value will have an input raster, and we'll assign a new value in the evaluation scale, and all the new values are reclassified into our original input raster. And supposedly, if you see this particular example in our right, there's two rasters file which are reclassified to two different categories from a scale from 1 to 3. Once we combine, we will give them a percentage. Supposedly the first layer we are giving a percentage of 75%, and another one is the 25%, and the output raster will become the value of 2. So this is basically I'm giving a background how we are selecting the site. This is a tool which we are going to use, which are using. So this is example. So this is the layout in which we are working. This is the layout for the ArcGIS Pro, in which we are inputting the raster layers, we are weighting them, and we are scaling them. So this is a case study for Odisha site selection. This is one of the study area in which we are covering on 5 major districts. The red line are representing our national highways along that all the districts. So for a site selection in national highways in Odisha, the input parameters
just one second.
Yes, sir.
Just to explain to the group here, why Aditya is making this presentation is because in NITM they are working on a very good project for the Ministry of Road Transport and Highways. In that project, the task was to select 30 spots which are highly vulnerable to landslides and whatever else. And once those 30 spots are selected, then the ministry will build better ways of making that part of the road resilient. So what this young man has done, since he's a full science guy, his language is very difficult to understand. He's basically, if you can go to the previous slide.
Yes, sir.
Yeah. So these red ones are the roads, no? The ones that you've selected.
Yes, sir. No, sir. This is the overall network. Which we have selected a selected network. I will show.
You will show that later.
Yes, sir.
So this is the whole network of national highways in Odisha. Now he is just telling us which are the layers he used to select the difficult ones. All was done sitting in his room, no field study, no?
No, this is the Pan India project, so it's not possible.
Okay, please carry on. And do it quickly so that
yes, sir, yes.
And do it in simple words.
Okay. So these are the particular parameters for site selection. We are using the slope, elevation, geology, geomorphology. And for the rainfall distribution, we have collected the data from IMD graded rainfall data. For this particular site, we have collected for the past 10 years. These are maps of from 2014 to 17, 18 to 21, and then 22 to 23. This is the annual average rainfall map for the 10 years we have used. And another parameter is the distance from the streams. And the next part is the flood susceptibility map, because our region lies in the Odisha area where the flood inundation happens. So for the flood inundation, we are using the flood conditioning factors, different parameters, along with the flood inventory, which can be used from the BMTPC or other reports, news reports. and we integrate all of them in a basic statistical model which can vary, and after that we validate that map and we prepare a final flood susceptibility map. For this particular area we get this particular flood susceptibility map using the frequency ratio, and one other map from the random forest we have prepared. So in this particular zone we can see the eastern portion is more susceptible to the flooding zones. After combining all these parameters, we reclassify all those parameters. When weighted overlay, we give the higher scale, which is the highest prone to landslide, prone to flood susceptibility. As the slope becomes steeper, the decreasing value will be given to the value 1. And similarly, those highways which are closest to the streams are giving the higher importance in terms to the farther from the streams. And we do the reclassification after that. And all these maps are reclassified. This is a tool in which we have integrated all these parameters, and these are the parameters, these are the raster files which we are using. The sum should be total of 100. Supposingly the first point we are giving the raster reclass, that is a flood susceptibility, which is giving the highest importance, then goes on to different parameters. And if we have a flood susceptibility, we are giving a scale from 1 to 5. Now if we are moving from different parameters, as supposingly I am taking distance from rivers, so it will scale from 1 to 10. So we can scale them accordingly. Similarly for different parameters, and in final we can scale them, those parameters, from a scale from 1 to 5, either 1 to 10 or 1 to 100, depending upon our own classification. Then we run the model, and the final input criteria as we got in this particular scenario, this is our final map which we have got. So you can see in this particular section, the figure A is representing the whole NH network which we are using, but our mostly area is hazard prone in the eastern portion. So we have selected this particular yellow line as a national highway for our study. This is our location 17 in our whole 30 sites which we are studying for this purpose. And this particular map is representing the whole network in which we are studying the whole 30 sites. It total spans for 2000 kilometers of national highways. Thank you.
So just to kind of conclude in simpler words, so what they've done is that they found these 30 sites by using 11 or 12 data layers, and they've done it on their computers in NITM. So that ability over there exists, and they were able to finalize the high risk areas. Now they will go there physically and study.
Thank you.
Ranking.
So, thank you. I think that concludes your presentation.
Yes, sir.
Yeah, thank you very much. So, do we have any question here before I go to the discussants? Yes, please.
Mr. Aditya Kumar, thank you for that brilliant presentation. My query was, you have done weightage overlay, and you have given weightage of 35, 10, different weightage. What is the criteria for that?
Supposingly, if I am considering a region of the coastal region in Odisha, so for that particular scenario, we have considering flood susceptibility as my primary element for primary parameter. Then if it comes to secondary, I will consider the elevation or curvature.
So these are the input layers you are saying, but I saw one input layer was given 30 and another was given 10, another was a 5. What is the criteria for this weightage?
The criteria was to the impact of flood on those particular layers, basically. How that particular scenario is impacting that area. In my region, in this coastal region, the flood is the most susceptible, flood is the most important part which is affecting all the national highways. But if I am considering the hilly regions, that the landslide becomes the most important part. So it will vary from region to regions. So the ranking will also vary in different zones.
Thank you. So I will now invite the discussants. So first I go to Mr. Thapa. Yeah, please go ahead, and if you would like to speak about.
Thank you so much for your time, and thank you. And regarding disasters, when we talk, especially in natural disaster, so main problem or challenges that come in data collection is weather. So when we talk about satellites, we get cloud. When we talk about drones, we get wind, weather, humidity that basically affect the your whatever you basically capture, that clarity you will not get, that resolution you will not get, the stability you will not get in the platform. So that is the major challenge that basically weather gives you. So in case of satellite, SAR is actually giving a good options. In case of drone, nowadays hexacopter drones are actually quite stable, and these can actually give you kind of data set that you require, the temporal data sets, because speed of data collection is also very important in disaster. So that's what basically. Another thing is spatial data management. That's what actually we want to say. So whatever data is basically available with us, with every department, that can be actually be shared with everybody. So once it can be shared in a, maybe a login based or user based, or maybe based on the government to government. So that data sharing can actually gives you a lots of option for or planning in case of risk mitigation, because data sharing is one of the important aspects in disaster. So in case you want to plan any early warning sensors, then also you require existing data, what is available with us. So that should be shared. That should be shared as a spatial data platform. Then I think as per the National Geospatial Policy, we are going in that direction only. And lots of data is going to be shared, and lots of petabyte of data will be available very soon. I think it is already available, and Sandeep sir will actually, I think, give you a much bigger context about that, how that data will be shared. So I think that's all I want to do, add as of now.
Thank you.
Thank you
very much. I think that the extensive sharing of data would lead to better triangulation. Can we say that?
Yes, sure, sir.
So, yeah. Now, requests Sandeep ji. Please come in. Thank you.
Good afternoon to everyone. What I see the challenges in challenges in the spatial data collection. First, I see there's a lack of common data standards. Data is being collected by the different government agencies, different private agencies, but in a different format, different projection system, different coordinate system, resulting which at the time of disaster we are not able to integrate the data in common platform. As far as the common standards are concerned, there are standards from OGC, standards from ISO for the data formats. And for the coordinate system, Survey of India has come up with the CRS network across the India with over 1,000 CRS stations at a spacing of 60 to 80 kilometers, and we are providing the surveys both in the static and RTK mode. It is free for the government user and some nominal amount for the private user. So whenever the data is collected, it should be collected in the national framework so that it can be integrated with each other. Second challenge, I see that a lack of reluctance of the different data provider to share the data. So the data has been collected by the government agencies, the private agencies. Some data is not shared due to the security reasons, the commercial reasons. And when the data is required, we are not having the data from all the agencies. Survey of India is taking the lead in that direction. We have already process of developing the unified geospatial interface with the help of IIC at Bangalore. This is geospatial data exchange, where which the data will be rest in the respective data service providers servers, and it can be accessed through the exchange. Third thing which I see, the data is available, there is a lack of competency on the user. So I advocate capacity building should be done for all the individuals in GIS software and open-based softwares. There are many open tools are available. And the fourth is that we have the lack of foundational data set. Not only the spatial data set, but also the infrastructure data, the population data, and other data as also. All these data should be available as a foundation data set. And at the time of disaster, whenever the analysis to be done, the foundation data set should be readily be available for this purpose. And Survey of India is now developing geospatial portal through which we are intending to disseminate all our data. We are already doing it with the online map portal, but for the analysis purpose, for all other purposes, we are in the process of developing the geo portal, where we are also providing the facility of bring your own data and create your own data. Some image basic foundational data set will be there, and you can bring your own data and you can just georeference it, you do some analysis, and then you take it back. We also supporting the crowdsourcing and citizen partnership, so that more data can be generated through the citizens also. Thank you.
Thank you. You mentioned that there is not sufficient foundational data.
Yes.
Now that we have created the base layers,
we are in the process of creating in the NJP. It is envisaged that orthorectified image of 5 to 10 centimeter for the entire country and a dam of 50 centimeter for the entire country. And Survey of India has already conceived it in National Geospatial Mission, which is announced in this current budget also. So we are just in the process of creating this foundational layer for ORI and DAM.
Okay, thank you. And now Mr. Avinav Shukla, thank you.
Thank you, sir. I'll be talking about the challenges that we face when we do operational activities as far as disaster management is concerned. I come from National Remote Sensing Center. We have got a disaster management support program. When I say disaster management support program, there's the word support in it. It implies that we will be using satellite data for providing assistance during disasters and crisis. We have had our fair share of experiences in understanding a lot of challenges that we faced. One, during times of extreme crisis and those events which are short-lived but high impact, we've missed at times mapping those events directly. Some of the times we've been able to capture it, like Sarah said, told you about the Chamoli disaster. We were able to capture real-time falling of the debris, and there was photogeological evidence also available. But this is once in a lifetime opportunity that you get given the current infrastructure that you have with respect to the space-based systems. So there is a very high demand, there is a very high requirement of a constellation of satellites which observe the country 24/7. And this it has to come from the users. We cannot say that for this particular application we require it. The demand aggregation has to be done. Second thing is the baseline data. If I have the satellite imagery with me, I require the baseline data with me. The baseline data is created, a lot of land use, land cover information, DEM, etc. are there. But usually the tendency is once it is done, everything is frozen for 5 years, and thereafter things proceed. The updation policy comes, the update happens, then after a decade maybe the updation will happen. But within this time frame, a lot of change occurs on ground. And therefore, at times, the analysis is a false flag. And when we do some kind of a impact assessment, you make a mistake once, it is acceptable. Twice, it is understandable. Third time, nobody will believe your maps. So as far as the spatial challenge is concerned, these challenges are there. Then, as sir has rightly said, that the data ownership is there, but it is fragmented in nature. Because of this, there is lack of interoperability in the data. He provides me data in table format, I provide in shapefile, he provides in GeoJSON. You as a user first have to struggle between these three of us. In the meantime, the most critical entity in a disaster is the turnaround time. That goes into dustbin. So this, some kind of a SOP has to be created, some kind of a data bank has to be created, wherein all the data should be readily available to all the users, to all the concerned people. Then with the given technological advancement, it is quintessential that there should be a very dense network of IoT sensors, and there should be redundancy also. If one of the sensor fails, there should be provision of some other source to get that information. And all of this has to be integrated together in one single disaster framework. Otherwise, everything goes into toss. Suppose if I go through everything, I am in a position to give you a good map also within a given turnaround time. Then the problem that happens is with respect to the person who is going to use that data. At NRSC, when we prepare a flood map, it is a GeoPDF. A GeoPDF allows you to have the lat-long location within the PDF. You do not require a separate software. But most of the times, the end user is not really aware of that. So capacity building is a very important aspect when you look at disaster management. Disaster management, robust disaster management is like preparing a very good sword, katana sword, and handing it over to a person. But if the person does not know how to wield that sword, it goes into vain. So capacity building again comes into a very focused, as a very focused entity. As far as again the capacity building is concerned, we've seen there is a digital divide that we have observed. When we have tried to do some crowdsourcing with our own data sets, with our own apps, the data comes from the urban area is very dense with a lot of information. But again, in the rural areas, we have seen that kind of a digital divide happening. So that has to be plugged in. So these are some of our issues that we've seen. Operationally, there are some challenges which cannot be addressed, and with time only it will evolve. For example, the trade-off that we have to do with high resolution data and the swath. If there is a high resolution data, the swath of the satellite becomes very narrow. I mean, the area that you will be observing becomes very narrow. The requirement is for a very large area to be observed with very high resolution, but that can be addressed using constellation of satellite. Again, some of the challenges that we've seen is if a area becomes flooded altogether, you do not have a proper control point to understand where exactly was this thing earlier and where is it not. So these can be addressed with time, but the issues that I raised beforehand can be addressed without any kind of scientific intervention also. Right.
So if I ask you, what would be your recommendation for the NDMA to have a constellation of satellites, would you be able to provide us?
Yeah, we will be more than happy, sir.
Yeah.
We would be more than happy, and we are striving towards it. We want that a lot of demand should come from the user agencies, and we will do our best to provide as much as we can for the nation, sir.
So that is my second question. Do you conduct any survey of the users to what what are the services that they demand, how frequently do they demand, and to what extent you are able to meet those demands, and what is their level of satisfaction?
So we do conduct user interaction meets wherein we take these kind of feedbacks from the user. Other than that, whenever, since the topic is a disaster, I'll stick to that. Whenever we send a product or a map to the concerned user, we also give a feedback form along with it. The tragedy is we do not get a reply. I mean, we get a blank feedback form.
There is one joint working group under the chairmanship of GIS, in which all forecasting organizations, CWC, IMD, INCOIS, DGRE, all are there. So already he has conducted 3 meetings only to get the input from the forecasting organizations. What are the requirements from the space-based requirements? Okay, like floods, how frequently you need data? Okay, daily or daily twice or fortnightly, like that. Similarly, landslides. So that information being collected already. We are making a report on that.
No, my question is to what extent the states are happy with you?
Sir, particularly disaster management things are like Assam, Bihar, UP, those states are there. Their floods are very prolonged floods. you will have floods for 2 months, 3 months. Okay. Even if you give one flood map once in 3 days, they will be very happy because they will be getting at more than 30 or 40 maps during the flood period. But some floods, particularly short duration floods will be there, flash floods will be there. So it is difficult, if the satellite is there, pass is there, we can capture it. If satellite is not there, difficult to capture, we will miss that event. Okay. So particularly states like Uttarakhand, Himachal Pradesh, the disasters in such states we miss many times. Okay. So they want this type of high temporal resolution satellites, means frequent coverages.
Thank you. Floor is open. Please raise your hand, ask questions. Thank you. I am Mohammad Kaikobad Ali. I am assistant professor in Jamia Millia Islamia. My question to Sanjay Kumar Singh sir, you talked about hyperspectral remote sensing. So my question, how we can use hyperspectral remote sensing for disaster risk management? And in India we have HISIS, hyperspectral remote sensing, but there are limited access to it. Unlike the Aviris in USA, which has repeated, they have a lot of capturing. So how India is going to improve the hyperspectral remote sensing, and how we can use it in disaster risk management?
Specifically, I cannot tell you how it will be useful in disaster management, but what hyperspectral data will give you information is basically you are having a multi-resolution imagery, spectral resolution.
Yes.
So you would be able to make out the composition of the material, right?
Yes.
So you will have, like soil, it has a proper signature in all the wavelengths, no? So that full wavelength you are observing in a narrow bandwidth. So that is the advantage you will get. And coming up with that next question, ISRO anyway, we are planning that 4-meter hyperspectral, that anyway it is announced, so it will be shortly coming up in space, 4-meter data.
May I add to the second part, please?
Yes, please.
I am Dr. Dev from Galaxy. There are a couple of hyperspectral companies which are popping up. One is Vyvern, which is outside India, but there is an Indian company which is coming up with hyperspectral. In fact, they have already launched 3 satellites. That is called Pixel. So commercially, data are also now going to be available.
Yes. With respect to hyperspectral, recently I studied an article also from US. They use the hyperspectral images for, they identified the liniment, means a fault zone, new fault zone that may trigger the earthquake. So in that case, they studied the hyperspectral images.
Yes, sir. Aviris is very popular in USA, and they are doing such kind of work. Yes.
So for landslide prediction or earthquake prediction, that can be a. Sir, and one more thing for Sandeep, sir. Sir, the CRS system which we are saying that, is it available for all places of India, or?
Yes, it's available for all the places.
So what is the mode of operandi to get that, sir?
So we have the website crs.surveyofindia.gov.in. You can go to that site, you can register yourself. If you are the government entity, then there is a free of cost. If there is a private, then subscription charges will be there. So you can register yourself there, and we are offering 4 services. One is an RTK mode, where you will get the accuracy 3 to 4 centimeter. The second is the DGNSS service, where the accuracy is 30 to 40 centimeter. You can upload your data and we will process it, it will give the coordinates, that is also there, and we also provides the raw data. If you ask the data for certain period, we will provide the data to you also.
Sir, if my data existing in one datum, is that means rightly the datum which you are using WGS?
Yes, we are operating WGS 84.
Okay. So if it is using say, different datum, then the transformation parameter will be there, or?
Then the transformation parameter would be required, but it depends at what scale you are capturing the data. If it is in smaller scale, then transformation parameter will do the things. But if you are collecting the data in the large scale, then it would not give such accuracy.
Okay, sir. Another thing is, actually recently we are focusing on wetlands of India, entire India mapping. Actually, we are facing the administrative boundaries, which is not unique in every state. Even if you are going to the open source, the administrative boundaries, like say for example, state boundary or district boundary.
Maybe we can I request you to take this question bilaterally? Maybe I invite others to raise questions. We have limited time, so thank you. Yeah, please.
Thank you. My question is also to Dr. Sandeep. It's about, you briefly mentioned about the 50 centimeter DEM that is being generated for India. Could you, like it's the most important parameter for floods, landslides, could you maybe expand on a little bit how it is developed using LiDAR, or when it will be available, or it will be open source?
Actually, we did the National Hydrology project where we used the LiDAR for generating this high resolution dam. It is available for the entire UP, Bihar and part of Uttarakhand. We are in the process of developing this dam for the entire country as well.
Thank you. Any other?
It is not for complete country. No, it's not for the complete country. It is for the
DTM available with India is not for complete country.
Presently, we have the dam of 10-meter resolution for the entire country, but we are in the process of developing the 0.5-meter resolution dam, and it is available for UP, Bihar, and part of Uttarakhand as a part of National Hydrology Project and NMCG.
What is the source for 10-meter dam, sir? I mean,
it is our topographical contour sheets, and we had did the contouring for 5 meters, 10 meters, and that from that.
So basically interpolation, sir.
No, it's not interpolation. We have in our topo sheet we have a 10-meter contour interval.
20 meters.
Not all the sheets, 50,000 sheets, it is a 20 meter,
yes,
but 25,000 sheets is a 10 meter, 5 meters even.
Okay, sir. But those are for very little areas.
75% of the country.
Okay. We also have ISRO's CARTO DEM, which is also 10-meter resolution. That is also available.
So, thank you. I think.
Sorry, sir, the contour is available. Recent topo sheets.
Yes, it is available in the recent last survey topo sheets. Yes, it's available.
Okay.
You can directly download the dam from our website.
Okay.
Sir, one more question, sir. This is
yes,
Sandeep sir regarding dam only. So 50 centimeter is also publicly available.
Presently, we don't have this geo portal from where you cannot directly download
it.
But data is with us. For the government agency, we will provide, no problem.
Okay, thank you, sir.
Thank you. So there's so many questions. So very happy, and I know it was it evoked a lot of interest. I think some of the key takeaways from this session: satellite data is available, but it has several limitations, and it's time to think of a constellation of satellites. To that, we also need to think of better ways of integrating the data. Data is available on different platforms, and bringing them together is a challenge that must be addressed collectively. The third part is how do we improve the capacity of the users to handle the data. And then I believe the remote sensing application center in states were set up largely to build the capacities. They have not been very successful in doing this, undertaking this task. So this is, we need to.
Yes, it requires further penetration.
Penetration, thank you. So these are some of the most important lessons emerging from this session. Thank you very much. Thank you very much for your presentation.
Thank you, sir.
And thank you all the discussants here. Very, very valuable insights. Thank you.
Thank you, sir. That was a fascinating discussion on challenges of spatial data collection. My sincere thanks to Dr. Krishna S. Vatsa and our esteemed presenters and discussants for highlighting both the obstacles and the innovative solutions in this space. I request Dr. Krishna S. Vatsa, member NDMA, to please felicitate our esteemed panelists.
Way of India. Is Mr. Makwana just? Oh.
Take a group photo.
Thank you.
Thank you, sir. Thank you, everybody. Ladies and gentlemen, it's time for a quick refreshment break. We will reconvene at 4:30. A small announcement. Someone of our colleagues' diary has been taken by mistaken. My front side of my colleague. Someone has taken her diary by mistaken. Please return back. Thank you. Sorry. Welcome back, everyone. Our final technical session of the day focuses on innovative enterprises in space-based disaster management. We are honored to have Shri Safi Hassan Rizvi, Advisor NDMA, as our moderator, and joining him on the panel are Shri Kiran Ramesh Hundarangi from SkyServe.ai. Second is Shri Nikhilesh Kumar, CEO of Basar Lab, Shri Vibhor Sharma from Capital 2B and Red Start Lab, Shri Devajyoti Pal, Vice President at Galaxy Eye, Kevin Abraham Cherin, Executive Lead of Agnikul Cosmos. Let's welcome our moderator and panelists. Sir, please come to the dais. Our panelists are requested to please take your seats. Over to you, sir.
कुर्सियाँ बड़ा मुश्किल है यार थोड़ा सा उधर वाले को गिरा सकते हैं Can you shift his chair a bit? Yeah.
Thank you.
Okay, welcome back everybody, and the ones who haven't come back also. So thank you for joining us again. We are running very short of time, so we should have finished by 17:15. We have about 40 minutes, so we'll take about 5 to 10 minutes more depending on the discussion, with your permission, sir. And we have General Atta Hasnain with us, so he's a real stickler for time, and we get very scared. So hence I've taken permission from sir. So we will now get started. So the interesting part of this session, why we added it, was that one of the big things that have happened with the 2022 policy, geospatial policy that was released, essentially opening up data, and how Survey of India started opening up data as they spoke of in the last session. The private sector is now not something that you do not, talk to, you do not look at them. The whole idea is juxtaposition of both minds, both experiences, and both philosophies. So that in that context, we've kept this session. So we've seen a lot of startups which are very innovative, very deep tech. They are used on the security side, they are used on the disaster side, and the whole intention is to encourage the startups to move as fast as possible and maybe reach cutting edge at a global level. Hence, we've invited 5 experts. One is Mr. Kiran, who's come from SkyServe, then Mr. Nikhilesh, who's the CEO of Vasar Labs, and then we have Mr. Vibhor Sharma, who's a venture capitalist who's been investing in deep tech startups for a long time. Then we have Mr. Devajyoti Pal from Galaxy. They have also done extremely good work as a startup, and these are startups that have persevered and survived, which is why they really deserve a clap also. And we have Kevin Abraham from Agnikul. So thank you all for coming, and we'll quickly move on. So request to SkyServe and then Vasar Labs for a quick 5, 7, 8 minute presentation. And you may have attended the whole day. Since you have, actually I saw you attending. So if you can be a bit brief. Thank you.
Good afternoon, everyone. Myself, Kiran. First of all, thank you so much for the opportunity to NDMA and everyone present here, and also NRSC for in collaboration organizing this. So I will start with what we are doing at SkyServe, and also walk you through a couple of issues that many of us have spoken since morning. So I feel like my presentation is going to be more of a summary sort of thing for all of us. So So as we are aware, we are going through a lot of climatic changes across the globe. And since I come from Bangalore, so you might have heard about a lot of floods that have been taking place in Bangalore recently. And we come across these kind of challenges every year. So, and this is happening so often these days because of climate changes. And when it comes to geospatial data, we see that since we have outgrown a lot of things, the data which is available to us, it's a huge amount, but it's in different places on different platforms, and also very costly and disparate technologies that we have. We have to plug in this data, we have to plug in that data, and also the response to this particular changes that are taking place, it's more of a reactive and less of a proactive. But I heard a lot of speakers mention a lot of things since morning, that there have been a lot of improvements have been done to take a proactive actions. And also we have intelligence gap in terms of this data coming to the on-field people who can take actions and who can do something about it, right? So a little bit about ourselves. So we have a couple of solutions here. STORM, which is nothing but onboard satellite data processing or in-orbit data processing, which is a solution that we have been working from last 4 or 5 years, and we are already working with the satellite operators. I'll explain that in more detail in another slide that I have. Our sites is where we have environmental intelligence such as methane gas detection or soil moisture, vegetation index. These are details, something that we have been putting on the sites. It's openly available for anyone to use and consume data and make a sense out of it. They can also request for a custom data if they want, and also they can run their own models on this platform via us. And we have last GIS, which is again location intelligence platform that allows any insurance companies or urban planning department to assess the locations for the risk involved, whether it is infrastructure details, climate hazard details, and the administrative details. So I don't have to repeat this slide, so you know what's the benefit of satellite data if you are using in your day-to-day activities to tackle the disasters. So again, so what we need is, like, when I spoke to Sushmita, and before I prepared this presentation, I wanted to understand what sort of audience is coming and what I should be covering and what I should not be covering. So I segmented it in 3 steps. One is pre and during and the post. So whatever the satellite data or any other data that is available via drone or via remote sensors that are available on the ground, these all has to be come together to give us pre-data that allows us to estimate the amount of impact, and also what could it do if it happens, right? And then we have something that in actual happening. So for example, how many buildings were affected, how many people were displaced. These all details is something that happens when the event is happening, and the post disaster in terms of what's the impact of this and what has caused us, like what in economic value, how much it has cost us, and how much of time it would take to recover this all things, right? So if we can holistically look at this all 3 things together while we combine this data from different sources, then we'll be able to answer or tackle this particular issue more effectively. Right. So I have been hearing since morning that, for example, we don't have enough constellations up there. We don't have a right satellite or at the right time on this particular location. How do we solve this particular issue, etc., etc. So on the STORM, which I showed you in the first slide, what we are doing here is we are not planning to launch more satellites. We are planning to use the existing satellites to the best of its capability using the in-orbit data processing. So we are currently working with Earth observation satellites which are already in space. So we can deploy similar software, or you can call a stack that can be uplinked to any satellite which is already in the space, or it can be put on the satellite which is about to go into space. And applications, if you see,
it could be any application. It could be flood application, it could be wildfire detection application, it could be agriculture application. These models or application that you have been processing on ground can be optimized to run in space. So as and when the data is captured, it can be processed, and the only insights or analytics can be downlinked. So you don't have to spend time in waiting for the images to come to you and then you process it, right? So this is something that we have already demonstrated with a couple of satellite operators, and we are in process to work with more satellite operators of different sensors and use cases, right? So this was just like what I was explaining pre-actual and post, where we can bring this all data sets into a single dashboard, which can allows you to do the, I'll just come to the next slide, so this will be much more clearer. So we have where we can forecast the particular risk, whether it is a heat wave or a flood or a landslide. Then we can assess the actual impact of this particular disaster on given location and given property, and then we can plan and recover based on what's the scheduled shutdown time for that particular businesses on ground, how much it has impacted to that particular location, and what has to be done. This can be very helpful for the one is for the government and also for the private insurance companies who actually work with infrastructure like hospitals or urban buildings to claim and settle the insurance much more effectively and assess it better. So that's all from my end. Thank you so much for your time and consideration.
Great, thank you. Thank you, Mr. Kiran. Now we'll have Mr. Nikhilesh, CEO of Vasar Labs. So I thank all of you for, especially the people who came in the earlier sessions from the private sector and yourselves for coming by and making this a richer discussion. Yes, please.
Thank you, sir. Good evening, everyone. I'm Nikhilesh. So Vasar Lab is a 10-year-old company, and we are focusing on taking data and science to users' hand, predominantly in climate vertical. And we are focusing on water, disaster, agriculture, and forest. And while we are doing that, over the last 10 years, we have built a platform which will create some of the words that have been used, whether it is a sensor-based data, so IoT stack, big data to bring all the data as a fusion together, and then bring remote sensing, AI, ML, and also some of the things that we discussed today. It needs to be real-time, so automation pipelines. And I'll just walk through some of the use cases that we have done in disaster predominantly. And this is one of the product, which is weather monitoring, which is seamless weather monitoring. And we saw weather is one of the most important when we talk about disaster, whether it is cyclone, heat, or flood, or any other thing. Bringing the weather in a holistic manner is very important. You got one agency, IMD, bringing stations which are observed data sets. Then you have state, which is bringing a lot of AWS and ARG stations. And then you have nowcasting happening. Then you have multi-agencies who are doing also on the forecasting, which is short, mid, and long horizon. So what we have done is we have brought all of them with huge amount of data processing. And some of the data processing in nowcast is happening at every 10 minutes from remote sensing, bringing cloud top temperature. And then more than 70 radar stations across the country we are ingesting every 15 minutes, running AI ML on it and creating a nowcast product, and then seamlessly merging at every hourly weather station data. So we'll just play a video to show that.
Nowcasting techniques enhance predictions by providing short-term, localized weather updates using radar data, EUMETSAT, and cloud top temperature to understand the spatial rainfall intensification at sub-hourly intervals, which is very crucial to forecast river flow and riverside early urban flood warning and mitigation. It can be used for both flat and terrain undulated urban cities to understand the historic, nowcast, and short-range forecast rainfall intensities with detailed damage assessment.
In order to understand the rainfall patterns from last 3 days to next 3 days, Seamless Rainfall module has been enabled by using 1 hourly observed rainfall, nowcast, and 3 hourly forecasted rainfall. Like the nowcast module, user can seamlessly drill down the rainfall patterns over any region of interest, including all administrative.
So we're working with more than 7 state governments and many cities, and also at central government. wherein these solutions are either going further to the flood forecasting model, which is this slide I'm showing, or is also going to the command centers where people sitting is able to understand the intensity of the rain in a usable format, mm per hour, what is the volume that will come in a particular basin. This is a visual clip from our Tamil Nadu implementations where more than 13 basins are automated for weather-based flood forecasting, where every point of interest is being measured, and those IoT sensor data are feeding the models, which are hydrologic and hydrodynamic, and creating a hydrologic responses at individual point of interest in the rivers. And a very user-friendly interface that you can see is some of them sensors are having red beacon, which is basically alerting there is a flood in the next 3 days. You click on it, you get to see a heat map which is telling, hey, how wide the flood is. So that's bringing you the weather story of it. You click further and you see the gauge and the time series of it. Next. Then we translate these data sets into now hydrodynamically. So at a river scale, doing the forecasting, bringing ensemble uncertainty, we are using 51 ensemble runs, and all of these are happening in automations. With every 3 hours, the model's updating with the latest data sets which are coming from forecasting agencies and also ground data which is coming from sensors. And these hydrologic models are presented into simple GIS. Next. Then at a city scale, so river scale, then city scale. So what now you are seeing is a place in Kerala where Periyar Basin we got a work to do, and as a part of that, few cities were vulnerable. So we had created using high resolution DEM, 0.5 meter DEM. And what you're seeing is using again AI, we created the building footprints, the roads, all the channels, and you see some colors and representation, and on the right hand side you're seeing population impacted, number of houses impacted, road length impacted. At the bottom you're seeing is a time bar which is also showing you a peak. You see color red representing which are the hours where majority of the houses are getting inundated. You zoom in and you now can go and see individual asset areas. So let's say airport, I would like to show you. So in this case, now you are seeing a zoomed in view near to the, this is Cochin airport actually, and simulating a scenario which actually had happened. And you see some colors are getting red, which are basically, which are the roads approaching the airport getting red. Red means you cannot now use it. And this is based on depth of the inundation. So time wise, location wise, asset wise, population wise, so that the alert can be given to the people who are impacted, houses that are impacted. Alert also can be given to the public assets like airport and others and roads where their impact is happening. Next. This is another visual where we zoom into a village area where, again, very simple animation. And these animations are all web-based. These are web-based systems accessed by anybody with login. And you can see how as the water bulge out and in, you have different exposures to different buildings. Next. And then we zoom in further to very critical assets. And this is again a web-based 3D using high resolution DEM data to understand which exactly, how the water will approach to an important facility and which area is vulnerable. And then if you want to do mitigation measures, so how can you do what a levee or different structures? And these simulations are happening in the web on the fly for a user to be able to understand what kind of first risk, exposures, and then structures that can be added. Next. Some other works that we have done using remote sensing is drought predictions, which is again governed by drought manual, and we have automated that for state of AP where various indicators are done. Another important one, which is forest fire, and what we have done is making use of remote sensing, created two things we have done. We have created a pipeline of remote sensing data sets, which is bringing informations on what is the fire load, what are the species that are there in that area. Then we merge the DEM data and wind, dynamic wind data, dynamic temperature data, and create forest fire spread simulation model. And this can be done at a very, very large area. This was done for few areas in Australia. And similarly in India, it can be done at any scale, where models can be created and set into automation pipeline for telling how if a forest fire is happening, how will it spread, so that sacrificial measures and water measures can be taken up. Next. These are some of the solutions. So we deployed a holistic disaster information and management system in AP, which included right from heat wave to cyclone to cold wave to flood to all the disaster that a state would have. So one unified system for all disasters. Similarly, we have done a couple of other solutions in Kerala, in Telangana, in Odisha. Next.
So we've passed 10 minutes also.
Next. Next.
Nikhilesh?
I just want last one, sorry, sir.
We'll have to minus 5
Yeah.
minutes.
Next, last one. So I just want to add here, since the beginning, one of the topic was open source, and a lot of questions were asked about whether it can be done or not. I would just like to highlight that we saw that there was a gap, and to address this gap, the entire solution that you just saw is a glimpse of very few among what we are doing, is all based on open source technology. And of course, you cannot use open source directly, so we have actually built it to make it usable by customers. Also, these solutions are in existence for more than 7 to 8 years in some of the states, sustainably running. In some of the places, we have finished the contract and it is running sustainably. So I'll just pause here, and thanks a lot for giving the opportunity.
Thank you. Now we'll go to Galaxy, Mr. Devjyoti Pal, and for your comments on what has been said and if anything you wish to add.
Yeah, I think satellite imagery and interpretation plays a big role in disaster management, but there are certain limitations when we look at the conventional satellite images. If we are looking at optical, then we have a cloud cover. If we look at SAR, then we have the interpretation issues. So here is Galaxy, which is coming up with a concept or building a satellite which we will be launching by this year end, where we are putting in SAR and optical on same satellite. So with the same look angle, objective is to fuse these two data together to make SAR more interpretable or optical cloud free, whichever way you want to look at. So you can say this is a claim, but we already have developed a sensor for drone, which is SAR plus optical, with similar configuration. We have already tested it with Army. We are working with NESAC for developing a biodiversity use case. So we have captured the data. We have seen this work perfectly. So we have now confidence on the technology. Recently, government had a program which is POEM, the PSLV orbital experimental module. We had put our edge computing platform there. So objective was to capture, take the data, do the auto co-registration there, and put it down, downlink it in the ground station, through ground station. We have tested that and we have been 100% successful in that. We have been told by InSpace, which is the regulatory body of ISRO, that we have completed it successfully. What we can proudly claim there is we have tested this module on Bermuda Triangle, where most of the satellites fail, and we have passed there also successfully. Now,
I'm so glad you didn't vanish over there.
Yeah. We are not there to vanish, sir. We have to make it work. And recently, we have developed a module of data fusion, the SAR and optical data fusion, and change localization. We don't call it change detection, we call it change localization, because where the change has happened, we highlight those through a AI/ML based model. So this has been very recently used by our defense in fusion of our SAR and optical, as well as identifying the changes. Here we face one problem, that when we are taking SAR and optical, we are taking it from two different sensors where the look angles are different. Time of capture is different. Hence, we are facing a temporal and perspective mismatch. when Galaxy's satellite is launched, which we calling it Drishti, we will be capturing both of them together. So these mismatches will be taken care. An interesting anecdote before I finish this, how we started. Of course, the liberalized space policy came into picture, so we thought of this. But our founder, who is the CEO, he was in TCS Research Lab and he was working on forest fire. And that's where he faced the problem. Then he took the SAR data, which he couldn't understand for 15 days. So he thought, why don't we merge together and bring up something where this problem can be solved. That's how we were born. So disaster management was the point from where we started. And our objective is to serve defense, disaster management team, and the agriculture. These are the three major objectives.
Alexa is the constellation of how many satellites?
We will be having a constellation of 15 plus satellites, because we want to have a daily revisit so that this temporal resolution issue can also be taken care of. So in October or November when we are launching, it will be one satellite, but over a period of 3 to 4 years, we will have 15 plus satellites.
Thank you. Thank you. That was very eye-opening. Mr. Kevin Agnikul.
Thank you for having me here. I think it's a really wonderful platform where I think a lot of points got discussed. I think to the biggest extent where I can contribute to this conversation here is you have satellites, we can definitely take it to orbit. Not saying that ISRO doesn't do it, but we can also do it, and we are trying to get there. So what stood out for me, at least from the different requirements that everybody talked about, even with the payloads that anybody would carry to orbit, is that everybody wants a lot of sensors within one unit or minimum number of units. And the temporal resolution is definitely something that can be addressed if we plan the missions better. But the larger challenge is that you're stuck with having limited launches and also have minimal amount of payload that you can carry. So I think when the requirements, if the users generate them, get collated, one thing that is to be strongly considered is how much are we expecting out of each satellite in terms of its use case, and what kind of a constellation are we building towards. Each of them will have their own use cases and mission plans, all of which need to go hand in hand with the capacity that the nation has. So along with ISRO driving forward the launches that we have, if there are other players that can contribute to this effort, that will also help us augment our use case as well. So it really starts from here. What does an end use really need from satellites, and how can the rest of the ecosystem catch up to support that need? Because all launching satellites is basically throwing something hard enough so that it keeps falling forever. We just need good enough reasons to keep launching. So I think the use case here really should drive that conversation in the nation, and looking forward to that from here.
Excellent, thank you. So yours is a company that is focusing on launch vehicles. Yes. You focus on satellite launches. SkyServe also focuses on satellites.
Data processing on board.
Data processing on board satellites, and I guess Vasar Labs does the similar analytics.
Analytics processing.
Okay, great. So we made a good choice of a wide spectrum of the whole business. So the good points that I picked up was that onboard processing. Instead of downloading everything, you do onboard processing, so you cut down download by 99%. Yes. The download costs and the download time is cut down by 99%. That's an excellent point. Then the point that SkyServe mentioned was plugging into New Year satellites rather than launching your own. That is something we'll come back to you to clarify. I mean, if it's a nice plug and play, then everybody would want to do it, but then if it's already working, we would love to know. Then Nikhilesh told us about the nowcast and the way you can do things in almost real time, which is different from even 3 hours. It's down to say 10 minutes, 15 minutes, 20 minutes. So that is also very useful. Then Galaxy has spoken of what Dr. Durga Rao and our JWG, which MHA has created. We were discussing this very problem, that why are optical sensors on a different satellite and microwave sensors on a different satellite? Why are they not in the same? So the basic reasons were 2 or 3, one of which kind of stayed in my mind was that what is that? Look angle is on the side for remote sensing and it's at the bottom for optical satellites. Now they were telling us over lunch and they've just said so now that they are fusing both of them, and the same satellite can look at the side as well as bottom and do remote microwave pickups as well as optical. Good. So that's something we'll be able to factor into our report. Great, that's a great positive. And then about the launches, the 2 obstacles you mentioned about limited launches. You can't keep launching satellites all the time. And minimum payload is quite an obstacle for you.
Yeah.
Okay, great. So we'll go to the investor, the venture capital investor. So how do you see the satellite industry, which I don't think anybody here is beyond 10 years, how they have developed over the years, and something more if you'd like to share?
Yeah, thank you for giving me this opportunity. This is a terrific initiative. Mike, lean in a bit. Yeah. Audible now? Yeah. Thank you. I think there's been tremendous progress, which is both good and bad. And I think, serendipitously you chose a good mix of companies, because in my view, the stack is 4 or 5 things. One is the hardware, which is your assets and payloads in orbit, on the planet. Then you have the software component. Then you have the machine learning AI component, and the last but not the least is the data component. Right. All of these have to come together for geospatial information to be available as insight, which is actionable. Right. In the last 5-6 years at least, there has been a great pace of achievement in terms of innovation here. In fact, last I read, there were about 150 or such number of registered space tech companies in India, right? Which goes to say that the interest and the motivation is huge, right? But unfortunately, it comes with its challenges, which is what I experience, from the lens of, investing in companies which are sort of, on the bleeding edge of technology. Is that until now there are not more than 2 customers in India for these companies, right? One is ISRO and one is DRDO, right? Things are changing, but the rate of pace of change is very, very slow, and then therefore for these companies to be able to sort of economically viable, the options are to go outside India, right? Now what I see here is that there's a brilliant use case for NDMA, right? I may sort of hazard a recommendation of saying, you should not look at just disasters, but look at, becoming an agency for resilience and sustainability as well, right? Because, if you look at all sorts of data, which is local as well as, across the country, owing to climate change, a lot of things are changing, right? Which means, crops which were, easy to grow in one area may be harder to grow in the same area in a certain cycle of weather. So can this information be used for resilience in agriculture, for instance? Just a side random thought, but what I'm driving at is that it need to be more and more use cases for companies like these to be able to monetize their capabilities, right? Working with the government, monetizing it, going beyond the L1, L2 mechanics is hard for a lot of people, right? And therefore innovation, needs more success stories in these spaces, in these areas. And only then a lot of new people will come up and say, what, I'm going to do a startup which helps, the space ecosystem and so on.
So that's a very interesting point you raised, that there are just 2 customers for these 150 startups, ISRO and DRDO. There's a lot of private people who must be buying data from these companies, and
There are, but it's not sizable enough in India. For example, we had one company which was looking at geospatial data for insurance and reinsurance in India. But the affordance of insurance per se is very different in remote areas, right, where a lot of these calamities happen, right? But if you look at places like the US, a tornado affects a lot of people, cyclones affect a lot of people, and the affordance and the cost of real estate is very different out there. So
Okay, so that's interesting because we had another workshop on disaster risk finance to discuss insurance. So we came up with exactly the same problem, that low penetration of insurance on disasters. Home insurance, apparently the penetration is only 1%. And this is urban areas must be higher than 1% and rural must be way below 1%. So that is the problem that is impeding companies from coming in and using your products, the space tech products. Okay, so that's interesting.
I mean, if you look at most of the natural disasters that have occurred in the last decade or so in the country, right from flash floods to GLOF to cyclones, I mean, they're in areas where people can't afford insurance.
Okay, yes, very well said. Great, thank you, Vibhor. We'll come back to you quickly. So we go to Kiran. What is this plug and play?
Yeah. So the software stack that we have built, so imagine it like an operating system that can run on any device. So we are a hardware agnostic. So for example, every satellite has a different sensor, a different resolution. So the software that our operating system, I would like to say, it can be uplinked to any satellite which is already in the space. So currently we are only working with Earth observation satellites. So imagine you have limitation on number of satellites which are there in the space, or limitation of developing different sensors and the resolutions. So this software can be deployed or uplinked, and your applications that you have, which you have been processing data on, for example, a flood as an application, can be uplinked. It has to be optimized because for the computing power and also the time that we have when it is onboard satellite, it's very less. So we have to optimize it for the space computing, and then we have to uplink or deploy the model. And as and when the satellite comes in contact with any AOI that of your interest, which you will specify in the model that you are deploying, it'll process and it'll just downlink or disseminate the data and the insights instead of images.
Great, that's interesting because that points to say 10 years down the road, when as it is we talk about satellite crowding in space, there may be an international consortium that might say, okay, let's start limiting the number of satellites. In that case, this idea may come very much in handy. That's a very interesting thing. But it basically depends on whether the owner of that satellite allows you to.
Yeah. So that's so most of the satellites which we have, so commercial satellites, so they are open to different collaboration on different applications. Another thing is that so this takes the entire processing part of it to the new level, where our on this operating system you can detect particular location for the cloud that is available. Let's say if you say that cloud should be like 25% or less than 25%, we can onboard itself, we can automatically detect that cloud and we can accept or discard the image based on the requirement.
Okay,
right?
great.
So we don't have to dump the images that has a lot of cloud. So it has no use case even if it comes down.
Excellent.
Right? And also the spectral bands that we have. So I think if I'm not wrong, a professor from IIST, he has done some work on hyperspectral band where he's saying based on the use case, why not we choose only respective bands instead of using all the bands, so that we can reduce the power consumption when we are running this models on board satellite.
Thank you.
Yeah.
Thank you. So Kevin, quickly tell us that are there enough queries coming for launches, or are you stalling on that?
Definitely there is interest, but the interest, like Vibhor said, is mostly from people outside, because people looking to develop a certain payload will also be looking for where that payload will be useful.
So are you saying that Indian private companies are not coming forward to
there is definitely interest. That's all I can say.
But interest has not turned into business yet.
Yes, interest stays like interest for a while.
So sir, what is your view on that?
So in fact, as I was sharing with you, we are incubated from the same institute, IIT Chennai, right? And both the CEOs are very close friends. We are also eagerly waiting for their successful completion. They have done some orbital launches. Now the main launch, once it happens, we will be certainly shifting with them. So because as we proudly claim, we are 98% funded by the Indian venture capitalists. So we want to be Indian. We do not have any other branches as of now in any country. And we will love to work with Indian companies and Indian startups so that the space ecosystem enhances in India.
Great, great. So Vibhor, tell me this, that why are Indian private companies like massive multinationals and all that we have, why are they not investing in their own satellite systems or a consortium of them?
Until now, though, obviously the space sort of territory was very heavily regulated and controlled by two agencies. That has unlocked only recently, right? So I'm hoping that with new startups coming to sort of create possibilities for launch vehicles, constellations up in the sky, use cases will emerge and people will start using. But I don't think they would be very interested in hardware. They would largely be interested in the insights that come from these platforms. Because that makes more sense for them, and that's less expensive than launching the whole stack.
May I add here something? Yeah. One of the largest organizations in India, Infosys, has already funded in us.
Okay.
Right, and they are one of the biggest funding organizations. So, since they do not have, as rightly highlighted by Vibhor, they do not have the expertise in hardware. They are not coming in directly. But they are interested in the ecosystem. That is why they have started funding it. We are the first organization where this kind of funding has happened, and I'm sure other places also certain talks are going on at advanced level. Other point which I will like to add here is, being the bigger conglomerates, I have a gut feeling that they are waiting for the startups to succeed and then they acquire.
Okay, so they're waiting for guys like Vibhor to keep funding, and
exactly. That's how I look at it. But please don't quote me.
You are already on YouTube. Yes, Nikhilesh. So what is your assessment? So you must be smiling after this conversation that it's only your business that the big businesses in India want, the analytics.
Well, I'll be happy. But yeah, I think the point is, the GIS world, which was predominantly, if you see, 20 years before, was primarily a tool for planners and designers, and perhaps the use case was one time in nature. But today, given the climate change scenario and also the urbanization, I would put, as the disaster has closed in more frequently and also more intensely, the need to monitor in real time is very, very high. The user story has shifted from once in a time of design to keep watching it. And as it is on keep watching, that's what is driving the satellite need. That's what is driving the need to have different types of satellite, right from optical to hyperspectral to SAR, and also different products derived out of it. And it needs to go also to now new user groups. So it needs to go to the actions taker. It needs to go to the State Department first line responders. It also needs to go to the individual citizens. Because today when we talk about floods, a very controversial subject, that what is the flood plain? And are we encroaching into the space of water rather than water reaching us? So I think it needs to go everywhere where a risk assessment is dynamically done, but also early warning and action to be taken is in the hands of the responders and also stakeholders.
Okay, great. Thank you. So that's very interesting all through. So are there any futuristic points you want to make? Something about looking ahead 10 years in the future. Right now, Government of India has opened up data. It's opened up, Survey of India is working towards opening up everything. Everything has been loosened. In space is the new regulator. Anything else you think you would need Government of India to open up on? Anybody can think of anything?
May I?
Yeah.
So, if you look at recently, as you have said, Government of India has taken a lot of initiatives where startups and the space ecosystem is getting a lot of insights, and there is a lot of activities which are happening. One of the very important activity which is happening is which is called EOPPP, which is run by InSpace, where they are trying to encourage startups to launch around 12 satellites of different configuration, which is very good. Somebody will win amongst 5, 6, 7. But what we need to also look at is the demand. There is no direct, linkage between the launching of satellite and assured demand. We will launch satellite, whosoever wins, that consortium will launch 12 satellites. But will they get that demand on priority basis? So that demand also needs to be looked at. We have seen till very recently, most of the government departments try to use Sentinel or NRSC data, right? We can't, beat NRSC in the price point because we have our own way of working, so prices will be higher. So that demand for the newer players will be difficult to come by. We need to look into that.
Okay, great. Thanks. Again, that same point, demand and supply. So any last words?
I think, there should be carve-outs from, different government bodies. There were a large amount of funds sort of, allocated in the budget and the earlier budget also on R&D and enabling startups around 10,000 crores. There should be carve-out for enabling agencies to become customers, right? As opposed to just funding startups. There's enough startups in an early stage, they can be funded also. But if you have a carve-out where you either subsidized these companies to work with the agencies or you gave them contracts to test out things, that'll be something, that'll really enable them. If you look at the US, that's what NASA and other bodies have done to ensure that the companies get revenue. SpaceX practically sort of, was built on the support of NASA paying it.
Okay, so what the general subtext of what everybody is saying is that because you're not getting enough business, you're feeling like going to international sources where you're able to get the funds and you're able to get the business. So that is something that we need to figure out how to arrest that. So I think that's very interesting. One or two questions we can take if there's something for our companies here.
I have a quick comment.
Yes.
Yeah, this is Niket. I'm from the Resilience AI team. So there is a startup, I think, that's being incubated at IIT Madras called Space Tug, which is working a little opposite to yours, wherein they are working with satellites that have gone dead or they are not working, to either make them functioning again or to bring them back so that they can be recycled and sent back again.
Very interesting.
So there are a couple of more companies. One is Digantra also.
Yeah.
Yes.
Yes.
They are clearing space debris.
Yes, please.
Yeah, I'm Nirdesh, I'm from IIT Delhi. My question is to SkyServe, and from what I understood about their data process was they are kind of compressing the data on the satellite and then using the downlinking for bringing the data back. So I wanted to ask more on the because when you're compressing, you're essentially kind of removing information and then using some kind of photon code, you're trying to bring it back when you are on the ground. So about the information loss and if it may introduce artifacts which are like not there but due to your modeling or on the edge and then downlinking they might come. So all about like will the data integrity be maintained in that or not?
Yeah. Thanks for the question. So I'll just repeat it. So you're asking, one is where there are going to be loss of data when we compress it in space. And the second question is, what's the data integrity and security part of it, right? So the first one, yes. So in terms of models, so these models that we are uplinking or deploying are not developed by us. So these are the models which are already available with the end users. What we are doing internally is optimizing and making sure that those models can run in space, right? So whatever the demonstration that we have done, we recently did one demonstration with NASA JPL, where models were given by them, and these were majorly into disaster related use cases. We have not seen so far any concern or issue in terms of data loss. That's the first thing. Second thing, security part, yes. So I just have to say
plain and simple, which in terms of that, we make sure from our end it's safe and secure. And also we have particular platform, for example, which will be given to the end users. So model is being optimized and tested, simulated on ground first, and then it is uplinked from the end user itself. So we are not interfering in terms of processing and mediating. We are just providing the software stack. So just like Android, you have different applications, Zomato, Swiggy, etc. So similar to that, we do follow certain policies or the clauses in terms of that. But again, so someone discussed in the morning that no matter how much secure you do things, but there are chances it can get hacked or get
Good point.
right.
Thanks.
So yeah.
Thank you. Thanks to everybody. Thank you for a nice, engaging discussion. Before Ashok throws us out, let's get up.
Thank
and
you,
exchange
sir.
mementos.
Thank you, sir, and our remarkable panelist. I request Shri Safi Hassan Rizvi, advisor and DMA, to take a moment to felicitate our esteemed panelist. Please, all are requested to take a group photograph. Thank you, sir. Ladies and gentlemen, as we wrap up our technical session, we will now transition to the closing session. Please stay with us for these final remarks to cap off this enriching day. For closing session, I request Member HOD Shri Rajendra Singh Sahab and Dr. Samir Saran, DGM RRC North, Lieutenant General Syed Atta Hasnan, Member NDMA, Dr. Krishna H. Vatsa, Member NDMA, and Shri Safi Hassan Rizvi, Advisor Mitigation. Please, sir, join us on the dais. I request Sri Safi Hassan Rizvi sir for the overview of the workshop. For overview of the workshop, sir. Over to you, sir.
Thank you so much. Thank you to the members of NDMA and staff at NDMA and staff at NIDM and staff, all the people who came here today. So in a nutshell, the takeaways are that a lot is being done by NRSC and by the private sector. There are a lot of nuances that are arising as to how to make it a for-profit industry. The start has been very good, and a lot of issues remain, especially with regard to where will they get commercial demand from. Earlier, the model was that the demand came from government and the supply also came from government. Now, to privatize that, the demand also has to come from the private sector and the supply also has to come from the private sector. So the supply side seems to have worked itself in fairly well. The demand side of the private sector seems to be slightly lacking. That is one takeaway. The other is that as regards the processes that the Government of India's National Remote Sensing Center has done, the number of satellites that are up there, the Earth observation satellites have been going up, but obviously some of them have to be retired, then they have to be replaced. So about the 4 or 5 active ones right now, we really need to improve those, increase them, especially because of the temporal issue. The temporal issue means that once in 8 days you get again a proper picture of the right place if it's optical, even if it's remote sensing. So ISRO is forced to depend on the international network that it is a part of, that Dr. Durga Rao was talking about, those 30 countries that we have links to. So there is a clear case to expand and have an Earth observation satellite constellation. The Ministry of Home Affairs is working on it, and a committee with NRSC and NDMA and various other government organizations is working at it. So that is a big demand which we must fulfill. We will be trying to push that along as we do. Now, as regards disaster management, when we speak of the newer things like cloud computing and machine learning, so cloud computing, machine learning is already being integrated. As in the morning session, we were told that it is not just the data or the GIS or the map. It is also the fact that you have to push it into the cloud and you have to make it machine learning based, otherwise you will not be able to create a proper workflow design. That is a very good point, and for the future there is no way that we can avoid it. Then a very interesting term came on retrofitting. So retrofitting, what do you do with all the databases that you have that are 30-year-old GIS databases? How do you retrofit them to be on the cloud and to be amenable to machine learning? So that was another interesting point, and especially when the members of NDMA have for long been grappling with this word with regard to preparedness for earthquakes. It's a new usage of the word, but that was why we like to interact with the academics and get to know from them. Overall, it's been a very interesting workshop with a lot of takeaways. We'll come out with a book like we did on that earthquake thing today, and we will soon, I hope soon, we'll get that book out and all of us will be having access to it. So thank you so much, Ashok.
Thank you, sir, for that comprehensive recap. Next, it's privilege to invite Dr. Samir Saran, DGM RRSC North, to deliver a special address.
Thank you so much. Respected dignitaries on the dais, Lieutenant General Saeed Atta Hasnanji, member of NDMA, Dr. Krishna S. Vatsavji, member NDMA, Shri Safi Ehsan Rizviji, advisor NDMA, all the speakers, past speakers, distinguished delegates, invitees, ladies and gentlemen. A very good evening to all of you, and my greetings to each one of you. Well, at the outset, let me express my appreciation to NDMA for organizing this workshop and providing platform to all the stakeholders for dialogue, knowledge sharing on this important topic, harnessing space-based Earth observation and GIS technology for disaster risk management. My compliments also to the team, NDMA and NRSC, for meticulously designing the whole workshop, and the topics of the technical sessions were quite apt, and I understand that my colleagues, that in-depth and intense deliberations were made in all the sessions. Well, as pointed out by Shri Safi Ehsan Rizviji, that Earth observation and GIS are no longer auxiliary tools. Rather, these technologies have become the backbone for effective and informed decision-making in disaster risk management. As you already know that ISRO, through its dedicated disaster management support program, has played a central role in providing critical information across the disaster life cycle, ranging from response, mitigation, as well as preparedness. Well, the geoportals like Bhuvan, Bhunidhi, NDEM, as well as MOSDAC have been instrumental in democratizing access to geospatial information, visualization, and analysis at various levels of governance for disaster risk reduction. Well, I'm sure that these initiatives and efforts have been highlighted by our ISRO colleagues during the technical sessions, and therefore I will not repeat them once again. Although a lot of activities and efforts are ongoing in the country, but we must admit that a lot still remains to be done. Well, one of the foremost challenges we face today is capturing short-lived but high-impact events such as GLOF, like South Lodak Lake, then flash floods like Tapovan, Chamoli, cloudbursts, landslides, etc., that unfold in a very short time but leave behind large devastation. Now, these events test not only our readiness but our technological limits. Now, since the time is limited, I would like to touch upon a few points which I think might have been delivered or deliberated in the past sessions, which will focus on the thrust areas according to my viewpoint. The first and the foremost thing is we must significantly augment our space infrastructure to ensure that observation gaps no longer hinder timely action. We need to have constellation of satellites which should be multi-sensor and agile EOSat satellites with high temporal resolution and repeativity and appropriate resolution. High spatial resolution satellites are equally needed and critical in rapid damage assessment and risk assessment. This must be accompanied by robust processing chain integrated with AI models to ensure that the turnaround time from satellite observation to information generation and dissemination really happen on a near real-time basis and not in hours. With the enabling policies and space and geospatial ecosystem in place, the non-government entities can definitely complement and supplement the government efforts in this endeavor. Well, we really have to gear up, not only in the area of geoinformatics, but I would say that we need to really develop robust and reliable early warning systems as well as predictive models, especially using space-based inputs. And I'm aware that many efforts are ongoing in this direction, but we need to come out with robust methodologies as quickly as possible. Well, if you look at the different technologies, like we really have to strengthen the scientific observation network and enhance the usage of disruptive technologies. Like for instance, we have to integrate IoTs, we have to see AI and machine learning algorithms for seamless integration of multi-resource data coming from different platforms, including UAVs, social media, crowdsource information. Like we need to have very different level of citizen science approach, which has to be ingested into the system. And of course, we have UAVs, AI-powered chatbots, and of course, digital twin is also one of the upcoming area where we can develop these scenarios and really monitor them, which will ultimately complement and supplement the satellite-based observation. Well, we need to foster an ecosystem where technology is not just made available, but it is used at all levels of disaster governance. Capacity building of individuals as well as institutions is probably one of the most important need of the hour. We must launch a forward-looking capacity building missions to enhance the skill set of DRR professionals at all levels and make it a continuous process. Well, if you look at the potential of EO satellites and GIS, it is truly unlocked, and only when institution systems are trained to receive, interpret, and act on this information swiftly. Further, building mass awareness in the key to building disaster-resilient society. And I would say that further PRIs, NGOs, as well as civil society can play an important role to generate mass awareness at the community as well as local level to be better prepared for any disaster. Well, there is a need to mandate the integration of geospatial intelligence in state-level disaster management plan, and this would ensure that last mile stakeholders are equipped not just with advisories, but with actionable spatial tools. Mitigation and preparedness, though less visible than response, are far more critical. In fact, hazard zonation, maps, urban vulnerability assessment, high-resolution DEMs, and other relevant geospatial information must be mainstreamed into development planning process. Well, we need to move from hazard-specific susceptibility mapping to multi-hazard spatial risk profiling as well as possible, covering even the transboundary areas. Well, there is an urgent need to mainstream the role of NGs as well as startup in disaster management for not only building the ecosystems, but providing the data to generate and provide disaster-specific information from risk assessment and early warning to damage mapping and resilient reconstruction. Well, if you look at the overall, I would like to conclude that DR requires a comprehensive approach that leverages not only the potential of space technology-based data information and services, but also available other sources through drones, social media, IoT devices, etc. Well, adapting sustainable development practices, collaboration, and capacity building are the key elements to build resilience and reduce the impact of disaster. Well, I'm sure the deliberations in the workshop have been useful and would have generated a lot of ideas and way forward. Well, NRSC ISRO remains committed to supporting NDMA, state authorities, and the community with timely, reliable, and mission-critical geospatial inputs for DRR. I must stop here now. Let us together build a decision-making and enabling as an aware ecosystem for DRR. So thank you so much for the organizers for giving the opportunity. Thank you all. Jai Hind.
Thank you, sir, for your inspiring words and for highlighting the critical role of space-based technologies in strengthening disaster resilience. For our valedictory address, I am honored to invite Lieutenant General Syed Ata Hasnain, member NDMA. His distinguished career and strategic insights in disaster management make him the perfect voice to reflect on today's discussion. Please join me in welcoming him, sir.
Thank you very much, and let me compliment, before I compliment the organizers, let me compliment the audience. This is the bravest audience I've ever seen in Delhi. We can stick around at 5:45 in the evening and still be hearing. I still see eyes are all open. But compliments. I think this has been a wonderful, what little bit I saw of it. I was sorry I was not here in the morning because I had some other things to attend to. But what I saw just now, amazing, gladdened the heart completely. I happen to be fortunate enough to come from a community of people in the sense that both the professions I follow, defense, that is national security, and disaster management, both are related to your science, right? And I still remember the year 2000, around 2000, when we were talking about space-based applications in the armed forces at that time, and people were saying, space and army, hamare liye kya hai yahan? Nothing. I was just happened to talk 25 years later to one of your colleagues here just now, was telling me and showing me the imagery which has been downloaded commercially on the damage assessment during Operation Sindoor, all over, everywhere. So, very, very common terminologies, very, very common methodologies and science which are being followed. Everything is very strategic. Whatever you are doing is actually strategic because it makes a difference to national security, it makes a difference to national growth and progress. There was a time, if you remember, I mean even a few years ago, when you found drones in Afghanistan being used and being remotely piloted from Tampa in Florida. That's how accurate drone technology had become, right? And it was all based on your science. The aspect of navigation, satellite navigation, and today damage assessment, of course, based entirely on Earth observation. So it's a great science, it's growing, I know. I could see the sense of dismay somewhere in the community here about slow business opportunities. I can assure you every science has gone through this dilemma. But you are bound to exponentially jump beyond. There's no doubt about it. Right? I can tell you, for example, I visit almost all the 750 DDMAs of the country. Hardly will you find, I mean, I'll say in 3 or 4% places where you'll find the actual exploitation of geospatial technologies as such. Unless the awareness comes, unless we use enough of IEC, unless a whole community of people aware of science, of this science, grows, you are not going to get it. And therefore, actually, it is your responsibility also very largely to contribute to this. We in the NDMA compliment Rizvi Saab that this is a huge contribution that the NDMA is making towards this. And not once in a year, it should be done many times in a year. Perhaps not in Delhi, it should be done in various parts of India. This kind of a seminar or a symposium, whatever you'd like to call it. I can tell you the ideal, I mean, what one would be looking for in capacity building would be embedding GIS training in SDMA and DDMAs. The EOCs should be brimming with this science completely. Encourage short courses and certifications, integration into governance. There should be a dashboard available everywhere. That's the kind of thing. You should be having dashboards all over. In every office, in every EOC, dashboards should be everywhere. I remember the Chamoli incident, which was just referred to just now. I also remember the Sikkim incident and the whole aspect of early warning. This will have to come about sometime, where, I mean, humanity can't live with climate change in this manner, that we are hit by huge deluges of water on us in such a manner and we don't come to know about it. It will develop and you will see that you will be the ones who will be the beneficiaries of the entire thing. So citizen engagement, you will find mobile apps and social media overlays ultimately coming on GIS maps for public warnings, volunteer coordination and incident reporting, talking about Abda Mitra warnings, you're talking about normal Sachet warnings. Sachet is at its infancy at the moment today. At just the infancy, you're going to huge development, your science merging and integrating with something like early warning, the conveyance of early warning, such as an app like Sachet. Every man, every woman will have that thing in his hand to say, here, if such and such disaster is coming, where is my route of evacuation? If the tsunami is coming, which is my route of evacuation? Which is the shelter that I go to? Where is my early nearest relief center? All this will have to be ultimately mapped out. So a vision for the future, in just 1 minute more, a vision for the future. Imagine a DDMA that during a cyclone warning instantly generates risk maps overlaid with shelter locations, vulnerable populations, and evacuation routes, something which I just mentioned, all updated in real time. Imagine a panchayat office, down to the panchayat level, accessing Bhuvan maps to plan water bodies and flood protection. This is not only just possible, probably it's already happening in many places, I know, but this has to become it has to exponentially rise. And the strategic opportunity, let us not just see Earth observation and GIS as only technical assets. They are actually strategic capabilities for the nation that empower institutions to act early, act smart, and act decisively. The future of disaster risk governance in India lies in intelligent decentralization powered by open data and open tools. So I wish to compliment all who have contributed to this important dialogue. Rizvi Saab, compliments to you for leading this entire thing with your team. Thank you, and let us go forward, not just to map our vulnerabilities, but also to reduce them completely. Thank you very much, and Jai Hind.
Thank you, sir, for your profound remarks. Your vision for integrating technologies and policy in disaster management is truly motivating. Finally, it's time for our concluding remarks. And for that, I would like to invite Dr. Krishna S. Vatsa, member NDMA. Please, sir.
Thank you very much. Much has been said by Dr. Sharan and General Hasnan by way of way forward. I don't have much to add. I just would like to say a few things by way of concluding this great discussion today. Very exciting, very insightful. We started this journey more than 30 years back, when the disaster management community looked at the space products and services with a lot of hopes. And the space community also promised to deliver it. Somewhere there was a mismatch, there was an asymmetry. And the kind of services that we thought would guide the disaster management practice did not materialize in full. And I'm sure we all could recognize it. It's not that we didn't make progress. We did make a lot of progress. I remember we used to get the satellite images, and then we would start digitizing them here when we would get the satellite images. And it was a very, very labor-intensive process. It would go on for months and months. All those things have been actually now no longer necessary. We get the digitized map directly from the satellite. We have now the base maps available for the entire country. We have several layers of maps which we can combine, manipulate, and we can come up with several types of maps which can help us. Our resolution of data has improved considerably. We are now thinking of 5,000, 1:5,000 scale map, 1:1,000 scale map. At that time we used to have 1:100,000 scale map. So computer systems have become high-end, a lot of storage is available, we have web-enabled GIS, and we are having several sources of data, not just the one source of data that used to come from NRSC. Now we are talking of the constellation of satellites. So all these things are definitely great indicators of progress. Where we need to make a considerable stride is how we are using all this to make our decisions. And that's where we are lagging and where we need to have better dialogue between the space community and the disaster management community. It's not enough to generate the maps. It's equally important that the maps be used to arrive at the right decisions. I can give you many, many instances drawn from our own practice. We do the post-disaster needs assessment after a disaster. We need the maps pre-disaster and post-disaster. That would make our things much, much easier. We can easily compare the data and look at the damage and loss in a proper way. It's very difficult to get pre- and post-disaster maps. So we still collect the data manually. We look at everything manually. That's, it is something that can really be simplified through space technology. We are dealing with forest fires. We are getting very good early warning system. We get alerts, but the mere generation of alert is not enough. How we are dealing with the forest fires based on those alerts is far more important. And that's where the forest guards are complaining. You are telling us about the alert, but we know it on the ground. How do we deal with these alerts? What is the size of the fire? What is the magnitude of the fire? How do we deal with those things? Lightning. We are completely helpless. People die every day, and then we have not been able to help the people. Urban floods. Again, the satellite maps are not available. We are not very clear about the level of inundation. These are some of the limitations that we are grappling with. At some point, the disappointment sets in, despite months and years of investment, so much of resources that we have put in. The kind of decision support system that we always talked about has not emerged yet. And that's the challenge that we need to deal with. And that requires a better communication between these two communities. What is very, very important today is, and that discussion brought out very clearly, is that now we have a new space policy, we have a more liberalized system through which the services offered by the private satellites are also available. We can think of the constellation of satellites, we can have more continuous observation, we can have more granular data. All that can be used very well to arrive at the decisions. What is more exciting is the new system of new technology of AI/ML, how the satellite observations could be combined with AI/ML to develop this to arrive at the decisions. I think these are some of the most exciting possibilities that are on the horizon. It's important for us to invest optimally. These are the things that require investments. And somewhere we are also very shy of making the investments because we are little apprehensive. In the past, we have made so much of investments, it has not yielded the results. But I think this is the time to make the right kind of investment so that we get the right kind of results. We need to think of more feasible models of public-private partnership, which we have not been able to develop. We also need to utilize the drones, IoTs, and all those things very, very effectively. We need to create more digital platforms where we can keep the data, all the data that we are collecting. We have a lot of data. Only thing is, how do we use the data to arrive at the decision support system? And then what is equally important is that all the states, all the districts are participants in this capacity building exercise. We had this at the state level, we still have the RSACs, the RSACs have not been performing, at the level, which it was expected. So RSACs need to be strengthened further. All the states, all the districts, we need to have a GIS system. We need to have that decision support system. It has to be one network throughout the country through which the NDMA can work closely with the SDMA and DDMAs. These are some of the most important takeaways from the discussion today. Thank you very much for participating in the discussion. We got to know of so many possibilities and so many new beginnings, and we promise you that we will work with all of you to take it further. Thank you. Thank you very much.
Thank you, sir. Thank you for your valuable insights. I request Lieutenant General Atasnian sir to please felicitate our special guest, Dr. Sameer Saran, DGM RRSC North, with memento. Sir, please.
Sir, please.
Thank you, sir. Thank you, sir. At last, we extend our heartfelt gratitude to all our speakers, moderators, presenters, discussants, and of course our wonderfully engaged audience. We hope today's discussion have not only inspired you, but also equipped you with valuable insights to enhance India's resilience in the face of disasters. Thank you for making this workshop a successful, and we look forward to continuing this journey together. Have a safe travel and wonderful journey. Jai Hind.